So welcome everyone to the 5th edition of the Natural Legal Language Processing Workshop. My name is Daniel. I'm one of the co-organizers of the workshop. I work at Bloomberg, and together with my colleagues Nikos Aletras, Leslie Barrett, Ilias Chalkidis, Catalina Guanță, and Jerry Spanakis, we are happy to welcome you to the workshop. As you know, we organized the workshop to bring together NLP, machine learning, and legal communities. And foster collaboration between these areas and discuss applications of NLP into the legal domain. We accepted the following paper types. These are just some high-level statistics for this workshop. Just hide these. Yeah, so we have in total 32 publications that were submitted and directly accepted to the workshop, and in addition we also have 10 presentations from findings papers, findings of EMNLP. We would like to thank our very large program committee because we received again a record number of submissions, and each paper received at least 3 reviews. So that involved having a very large program committee, which we are very grateful to have helped us. If you want to follow from home or in general NLP, we have a YouTube channel with the talks, with recording of past workshops, and the current workshop is also recording live there. This is in terms of materials, you can see the proceedings. They're already on the ACL anthology, starting yesterday. If you want to share anything on Twitter about the workshop, please use the following hashtags and @mention our workshop. And if you want to keep in touch afterwards, just a reminder, you can join. We have a Slack community. We have around 300 or more people, and you can directly join using this list. And we also have a mailing list on Google Groups. And we also have our website, nlpw.org. And we'd like to thank our sponsors as well, similar to past years, Bloomberg and ERC Human Ads Project. They have sponsored the workshop, and that involves the Best Presentation Award, which we will award at the end, worth $500, and a catered lunch during the poster session for everyone attending. So with that, I'm just going to, because I know we're kind of running late, I'm just going to hand it over to the first speaker. Amit is going to present, or anthropomorphization of AI, opportunities and risks. Is Amit on Zoom? Or anyone from their group? Let me check if Amit was going to be here in person. Oh, he's going to be remote. Okay, so should we just switch to the second presentation in the interest of time? Yeah. And if Amit joins meanwhile, then he can go second. So we're going to join from the laptop. Okay, so we're going to have Carolina Camasa present NLP for crypto asset regulation, a roadmap. Just come here so you can see, and you can use this.
I need the permission to share the screen. So like whoever is sharing, I think needs to take it down. Yeah, but it says you are sharing, so I can't.
Oh, it's yeah.
Updated, so I need to update the so. was sooner than I expected. So I'm missing the last few minutes of preparation to get out. Yay. Let's set my timer. Okay, I made it. Good morning, everyone. I'm here to present my paper, which is called Legal NLP meets MiCAR, Advancing the Analysis of Crypto White Papers. I'm Carolina Camassa, and I work in the Applied IT Research team at the Bank of Italy, which is the central bank of Italy. And the title is a lot of words, so let me break it down for you. Let's start from the concept of a crypto white paper. So a white paper in general, as defined by the Britannic Encyclopedia, it's an authoritative report detailing an issue, position, problem, solution. I have trouble hearing. Now? Okay, sorry. Or even a commercial product and service. So the classic example of a crypto asset white paper is the Bitcoin white paper, which is quite famous, and it's a purely technical document. But if you look at white papers now, they are documents with a huge variety. So you go from purely technical white papers similar to the Bitcoin one to documents that are basically marketing publicity documents. And so there's a few problems with them if you want to maybe do some NLP with them. Problems that might be the lack of machine readability because they're not meant to be easily extractable from the PDF, for example. They make a lot of unfounded financial claims. And since there is no shared template or standards, they might rely a lot on aesthetics and being eye-catching rather than the actual content. So I had this pretty big data set of white papers, let's say around 2,500, and I wanted to see what people had been doing with them. I thought, there's all these free documents on the internet, someone must have done some kind of NLP on them, but actually this is one of the possible searches you can do, but you can see that on arXiv there's only one paper, which is the one I'm presenting. And there's a few more on Social Science Research Network. And when I was doing my literature review, I realized that, in fact, most of the research on white papers was not done by computer scientists, as you can expect, but from people who have a finance and business background. So they don't have, of course, a technical background. So but the first contribution from this paper is actually a survey of from the NLP point of view of how these white papers were analyzed, again, mainly from people who work in a business domain. And this is reflected in the kind of techniques they use to do textual analysis. So a common a recurrent theme is that the textual features were just extracted, usually using dictionary-based methods or just count-based embeddings, so more traditional techniques. And then they were integrated in econometric models, so regression models, basically. And in this table, you can see the main NLP tasks that were performed. Now, I was talking about how the existing ecosystem of white papers is quite confusing, both if you want to work on them from a technical point of view, but also, of course, if you are maybe a customer who wants to buy these crypto assets. So I was not the only one thinking this. So the European Union came out with the MiCAR, the Markets in Crypto Assets Regulation, which is a regulation that was published recently in June of this year, and it aims to regulate crypto asset public offerings, which were previously known also as initial coin offerings. And one big part of the content of the regulation is actually, it actually regulates what should be the contents of the white paper and also the format. So it aims to fix some of the problems that I talked about at the beginning of the presentation. And you can see some example of the requirements in the image on the right. And so the second contribution of the paper is to think about how different NLP techniques, specifically some literature results from Legal NLP, how they could be used and adapted to also help different stakeholders in the new MiCAR regulated ecosystem. I will not go into detail because I saw that my 5 minutes are up, but I just wanted to emphasize that doing some more research, both academic and industrial, on this topic could benefit the 3 different stakeholders, which is the regulators themselves, so people who are in charge of checking that these white papers actually comply with the norms, the issuers, so they can do the work previous to publishing the white paper. They can check maybe automatically if it is compliant, and of course the potential investors themselves, because imagine if there are some tools that enable them to easily gain insight about the crypto asset markets with NLP. So that was it. And I think the question session is after the next one. Yes. And you can find me at the poster as well. Thanks.
Okay. Okay, thank you very much for the presentation. And we're going to switch to the next one, which is on the potential and limitations of few-shot in-context learning. Yeah.
Hey, yeah, I'm joining online, if that's okay. Yeah, that's me.
Okay, yeah, take it away.
Awesome. I hope you're able to see my screen, my slides.
All looks good.
Thank you so much. Yeah, so I'm Dhananjay, and I'm going to be presenting my team's contribution through this paper, generating metamorphic specifications for tax preparation software. So let me start with the problem, right? Knowing the exact amount of tax someone should pay is extremely difficult. If I were to just walk up to you and say, hey, how much tax should these 2 individuals be paying? It's very hard to put a number on it. And if you're writing tax preparation software to test if it's working correctly, it's very difficult to do because you do not have these gold standard outputs, right? Now, there is this notion of metamorphic testing. So for those of you who do not know, metamorphic testing frames test cases as comparisons. So instead of knowing the exact expected output for an individual case, you can compare 2 different outputs that you expect from the system and see if it's working based on your intuition on how the system should work. So take, for example, the second graphic that I've shown here, right? So you have 2 individuals who are the same in every regard, except one individual has children and the other individual does not have children. Now, that gives you some intuition in that the person with children should probably pay lesser tax than the person without children, right? And that way you can check at least for this case, if your tax preparation software is working properly. Now, this provides like a unique opportunity for NLP because there are these tax guidelines present and easily accessible to all of us. If we can use these tax guidelines to generate these metamorphic tests, right, we can see if tax preparation software is working correctly, if it's fair, if it's charging individuals the right amount of tax based on the properties that they put into their form. Now, what does that mean? You can't directly give natural language to a system and expect it to work. So you need to first convert it into some sort of formal specification, like first order logic. And that is already a good thing because LLMs have been shown to achieve good results on FOL generation tasks. But this particular problem statement that I'm talking about has some unique challenges. So like the first challenge is obviously tax codes are like organized in these really complex document structures. The second one is the language that's used in these tax codes and guidelines is extremely legal, and it doesn't really resemble the language that you find in like curated datasets for first order logic. And I think a really big problem is LLMs have been evaluated on like direct translations from like, oh, this is my natural language statement to my first order logic. But we're really focused on generating these metamorphic statements, right? These metamorphic comparisons. And so that sort of contributed to our question is, can GPT, I'm sorry, can GPT 3.5 generate metamorphic specifications, right? And so in order to test this idea, we asked a human expert to go through the tax guidelines and curate specifications, metamorphic statements that they perceive to be true after reading the tax guidelines. And we also asked them to write its representative FOL formula. And what we wanted to see was, can GPT 3.5 go from a curated specification to the FOL representation? But what does this mean? So let's just break this task down even further. So when we're going from natural language to first order logic, we first need to generate the predicates, and then we need to use these predicates in some sort of first order logic representation, right? So we designed experiments to find different ways to prompt ChatGPT and analyze how well it can perform. So here are a couple of the strategies that we tried, right? So the first one that we tried was this end-to-end prompting strategy where we sort of give the prompt at the beginning and say, okay, given this metamorphic statement, generate the predicates and generate the first order logic using those predicates, right? And after and the second prompting strategy is this explicit decomposed prompting strategy where we give it a prompt first saying generate the predicates. We take the predicates in a new context. We feed ChatGPT these new predicates and say, take these predicates, generate my first order logic. And then we do some sort of qualitative evaluation based on how good the generation is, right? And like, long story short, can GPT 3.5 generate metamorphic specifications? Yes, to some extent. It can extract metamorphic specifications, but more work needs to be done before it can actually be used for the purpose that we're envisioning. I wanted to share some choice results. So we found that GPT is better at generating predicates, first order logic predicates, than it is the first order logic representation, right? And this is for both the end-to-end and the explicit cases. We found that the explicit case works better than this end-to-end cases. Like decomposed strategies for prompting works better. We found that the number of examples that we provide in the prompt directly impact the performance. And I think this is also backed by a lot of literature. And lastly, we found that there is some decrease in performance as the number of predicates increase, right? So this was our work so far, and we've seen that transformers can go to some extent to extract metamorphic specifications, but I wanted to highlight a couple of steps we're taking to move this idea forward. The first one is we want to see if we can use external sources. So we already have a lot of first-order logic data sets out there. Is there any weakly supervised methods to convert these first-order logic data sets into this metamorphic format? All right. And I'm sorry, I'm seeing a few messages in the chat. I will just get back to it in a second. And also, can we sort of leverage, language models trained on code, because there is some sort of consistency in the way logic presents itself. So yeah, this is what we mean by using external sources. And the other one is closing the loop. So we have these first order logic specifications and we want to write tests. So we can only guarantee a certain level of clarity with the extracted specifications. What is the noise level that is acceptable to write tests, and what kind of results actually come out of the tests that are written through our specifications? And can we sort of use that to close the loop? Can that sort of improve our specification extraction process? So that would be my presentation. Thank you. And I think I'm over time, so I'm going to just stop sharing.
Okay.
But yeah.
Sure. Thank you very much for the presentation. And now we have, I think, 5 minutes for joint questions from both presentations. And I think there were some on the chat already.
So I can ask that question if it's okay.
Please unmute.
So this is my question for Dhananjay. It was a good presentation. So I was just curious. So you're basically using GPT to convert tax codes into into first order logic, right? So do you point GPT to a particular tax code, or do you embed certain portions of it in the prompt? How do you go about that?
Right. Yeah. So one of the authors on this paper actually read the tax guidelines. So there was an IRS document from 2021 that he understood, and then he converted into metamorphic specifications in text. Is it fine if I share my screen? It would be easier for me to sort of talk about this.
Yeah, sure. If it's easier.
Thank you so much. So the idea is, if you can see this statement, an individual who qualifies for EITC must receive a higher return than a similar unqualified one. This particular statement does not exist in this form in the tax guideline. This was curated by one of the authors, right? And
okay.
what we're doing is we're giving GPT this particular statement because I feel like this is an easier task, and it has to sort of start with this step and then go to the next step of automatically sort of taking your tax codes. So there was some manual labor involved in actually making this more concise.
That makes sense. Thank you so much.
Yeah, of course. Thank you so much for asking.
Thank you. Questions from the room as well, or if you're on Zoom and you want to ask a question, just feel free to unmute. I had a quick question actually for Carolina. Do you have any sense about, so the crypto assets were hot and there were a lot of white papers study on. Do you have like some historic analysis, for example, of or like what we can expect to happen, like historical analysis of kind of the frequency, if they're changing any type, any kind of qualitative insights?
So I've noticed mainly qualitative analysis that the market was already well, I don't want to say regulating itself, but it's starting to converge towards some more shared templates. So they figured out what looks maybe more professional, and they are imitating that, including, I think, copying and pasting a lot of legalese, like at the beginning, some things are kind of disclosures, but not really. So it's converging towards that. What we can expect is the European Supervision Market Authority already published what some guidelines, technical guidelines on the format that they should have. And it's actually a machine readable format that doesn't leave a lot of space for fancy graphics. So we can expect more boring white papers, but they're going to be more constrained. And I think probably they will just keep publishing two versions, like the official version and maybe the more creative version.
Okay. Thank you for your answer. Any other questions? Sure.
I have a question for Dhananjay. So in the decomposed prompting strategy that you tried out, did you mentioned that it's easier for the model to generate predicates than generate first order statements directly. So when the predicates were converted to first order logic statements, how was the performance then? Did you see a performance drop as compared to generating predicates?
So I just to sort of like make sure I'm understanding your question correctly. Your question is, was the performance of generating predicates different than, say, when it was done in an end-to-end prompting strategy? Is that your question?
Yes.
Yeah. So we saw that it was somewhere in the same ballpark. It hadn't necessarily changed too much, but I'm only talking about the two-shot process, like when it saw two examples. But yeah, it was somewhere in the same ballpark. So yeah, if that helps you answer that question, like we saw a slightly higher performance, I think, for the explicit case, but we also saw a higher standard deviation. So
All
yeah.
right. All right, thank you.
Slightly, like we're talking about small numbers though.
Okay, thank you. Any other questions from the room or from Zoom? Okay, if there's no questions, we can go to the next presentation. It's already 9:35. So the next presentation is NOMOS, Navigating Obligation Mining in Official Statutes. And the presenter will be Andrea Penisi.
Yes.
If he's online. Yeah.
Can you see my screen?
Yeah, you can see.
Perfect. Good morning. My name is Andrea Penisi. I'm a senior AI engineering manager at Inisa, and also I'm a researcher at University of Basilicata in Italy. Today I'm going to present NOMOS, Navigating Obligation Mining in Official Statutes. So basically, identifying obligations in legal text is a very challenging problem due to the fact that legal texts are very long, and also the sentences in legal text are very long. And secondly, the law is very interpretable, and so basically the knowledge and the experience of the expert is a very important key factor in understanding if something is an obligation or not. In the state of the art, there are many methodologies that try to deal with this kind of problem. Many of them based on classical machine learning focus more on contract law. Other, like based on LSTM, are not able to well aggregating the results, and so basically you at the end you do not understand what is an obligation and what is not. Other like based on TCN and they are not able to classify long sentences. And what we did in this, and what we are going to present in this work, is a comparison between several of these algorithms together with a solution that we are currently using for extracting the obligations. We selected basically three main methodologies: simple term frequency, inverse document frequency, and an SVM, a TCN network, and we chose TCN over LSTM because of its ability to extract low-level features, and also the fact that are able to capture high-level temporal information. And then we chose BERT. This is our solution. It is based on the combination of positional embeddings together with word embeddings, and we have also a TCN layer, and then we have two kind of pooling layers that we combine together. We use a max pooling and an average pooling layer because basically in such a way we keep low and high level information, and we merge them together, and then we basically use a dense layer, and then we classify the input as obligation or not an obligation. We basically finding the network parameters, we used several methodologies. For the classical for the SVM, we use a grid search methodology, while for the TCN and our own solution, we proposed basically we used a Bayesian optimization, while for BERT we used the standard parameters for provided in the state of the art. Then what we did was to label a dataset of almost 75K sentences from the Code of Federal Regulation and the Australian Legal Institute, and we performed two kind of tests, a quantitative test and a qualitative test. In the quantitative test, as you can see from the tables, we compared all the algorithms, and since BERT and NOMOS are the best algorithms, we just went more in depth in order to understand how they classify obligations and not obligation sentences, and we see that NOMOS is slightly better than BERT. Then what we did was a qualitative test on European regulation. So basically something very new to these algorithms. And basically we discovered that NOMOS perform very well on this kind of regulation without no false negatives. So to conclude, NOMOS is able to deal with different legislation using less parameters than BERT, and one of the drawback of NOMOS is that it's not reliable in distinguishing between obligations directed to a private party with respect to the obligations directed to authorities. And what we want to do in the future is to add also an attention layer to the network in order to improve the distinction between these two. Thank you, and that's it.
Thank you. So we'll head straight to the next presentation, and the QA session will happen at the end of the session at 10:15 estimate. So the next presentation is long text classification using transformers with para-selection strategies. From Mohit Tuteja and Daniel Gonzalez Jukla. So I see Mohit is online. to present?
Yeah, hi, I'm sharing my screen.
Okay, perfect.
Yeah, hi everyone. I am Daniel, my co-author will be covering this paper today. It's in Thomson Reuters. Okay, the problem statement is that legal content is too long for most NLP models, and what we are looking here is training a cost-effective and well-performing model on long sequences. These are the experiment data sets that we've used for the experiment. So we have 6 data sets in total, 5 legal, 1 medical. And on the left table, you see that the first 2 data sets are internal from Thomson Reuters, while the other 4 are publicly available. So Mimic 3 contains medical documents and the rest are legal, which is our primary focus. And we have 5 multi-label data sets and 1 multi-class, which is SCOTUS. All data sets have a high number of average words per document, easily exceeding the usual context window of 512. Yeah. So here's the experiment setup. We have evaluated 11 methods using a standardized methodology across all the data sets. We have 3 predefined learning rates, and we are using, these have been used for each transformer model. We have our evaluation metric would be micro F1. We are using for repeatability fixed seeds, consistent batch size, and accumulation steps. We have tried to make minimal changes to the data sets. We use the data sets mostly as is, unless some data has some missing observations, then we have to remove those. Observations with missing labels, then we have to remove those. Then the base model selection is Roberta, which is the baseline transformer model we'll be using. And here are the approaches that we tried out. So you have TF-IDF plus neural net. This is the traditional baseline. It's a very simple network with just 1 hidden layer. Then you see 5 variants of Roberta. These are selecting different chunks of the document. So you can take it from the start, end, or both. There is also a custom approach that we evaluated here, which was more around training the first model here, the TF-IDF for full documents, and then using that and the training labels to identify the most important chunk for each document, and then training a Roberta model on top of it, right? So the idea is to get the most important chunk from each document. And once you have it, train a Roberta and then see the performance. We also evaluated 2 variants of long former, HATs, and mega. This was also further pre-trained, and the details of the pre-training can be found in the technical appendix of the paper. We've done 3 models trained per approach per data set using the learning rate. So the results that we're sharing here will be on 198 trained models. And this is the paragraph importance distribution when you see it across the data sets. So these 3 are TR data sets. And what you observe is there is a U-shaped distribution in terms of paragraph importance, with the first and last chunks being usually the most important ones. Mimic 3 is different because the important chunks are towards the end, and the LexGlue data sets have importance evenly distributed. And these are so this is a outcome of the paragraph selection strategy, and there too, that's a positive side effect that you kind of see this importance, and then you can use it in your evaluation, and also carries forward to our results. The results are that we don't have any clear model that outperforms that performs best across, but you can look at the last 2 columns, right? So long former first 4096 tokens is the overall best performant, but is also the least efficient. So you can see that it's the highest average micro F1, but takes processes the minimum documents per second. TF-IDF plus neural net is a pretty strong baseline, actually surpassing our expectations and coming pretty close to the other models, and is also by far the most efficient one. And the message is that concatenating usually works, right? So you see Roberta concatenating first and last, and long former and HAT, and that usually does good. And in fact, long former and HAT, if you use the first and last 512 tokens, they give you a comparable performance to the version with just the first 4096 tokens. But at the same time, it's 4 times more efficient. So that's a good strategy. Conclusions and future work, model training guidelines. What we're recommending is, again, try the TF-IDF plus neural net. You can find the technical details and parameters in the paper. And it really gives good performance. So if you're 1 to 2% fine with lower performance, you just go with that. Otherwise, you can plot the paragraph importance. If you have U-shape, you can consider concatenated models. We're not presenting results from LegalBert here, but LegalBert is just as good as Roberta, sometimes outperforming as well. So you could go for LegalBert or Roberta for the concatenate starting in, or if your goal is higher performance, you can do the same with Longform or HAT. For more uniform paragraph importance, you could consider long models because there you can't really help much. Information is distributed. And future work could be Llama 2 and Llama. Stop sharing.
Thank you very much for the presentation. So the next presenter will be Marco Rovera, who's going to present their paper, Italian Legislative Text Classification for Gazzetta Ufficiale. And you have this on the desktop, right?
Yeah. May I use this one?
Yeah.
Does it work?
Yeah, I think it works. Yeah, it did work.
It work.
Okay.
Okay.
Full screen. Okay.
Yeah. Okay. Full screen. Oh.
This is the editor. Control A.
Yeah.
Oh, there. All right.
You're not sharing.
Oh, sharing. Shit.
Good morning, everybody. My name is Marco Rovera from Fondazione Bruno Kessler. Sorry. My name is Marco Rovera from Fondazione Bruno Kessler, Italy, and today I'm presenting this work called Italian Legislative Text Classification for Gazzetta Ufficiale. Gazzetta Ufficiale is the official source, official journal record of the Italian legislation, which includes every legislative act issued by a major Italian institution. And it is really a key device in Italian legislative process, if you consider that most of legislative acts in Italy have as a requirement to be first published in this official journal in order to take effect. And while being published, legal acts, legislative acts are being assigned one or more label from a subject index, and so far this has been done manually. So what we did in this project was to develop an automatic pipeline for classifying legislative documents in the Gazette. The dataset provided by our partner, Istituto Poligrafico, based in Rome, which also, by the way, is the institution who curates and publishes the Gazzetta. The dataset counts 360,000 labeled titles. So we focus on titles of legislative acts, so quite short texts. And the time span ranges from 1988 until early 2022. And it counts 7 million tokens. This dataset has been annotated over time with a taxonomy counting 1,500 unique labels. So, and this taxonomy is structured over 4 layers. One main layer, which is somehow the backbone of this taxonomy, and which is also mandatory, meaning that each document has to receive at least one label from this layer, which is the open labels layer. And then there are other 3 optional layers, which are used as a additional refinement. So the problem is a multi-label classification task with a large tag set. Therefore, we adopt a stratified approach for creating the splits, and we set a cutoff threshold for labels with less than 10 overall assignments, given the data sparsity in the dataset. And we evaluate 4 different models, 2 general purpose BERT models for Italian and 2 domain adapted legal models for Italian on this dataset. And what we found is that using only titles, we can achieve fairly good performance of 0.87 micro F1 score, but also that domain for this task and on this dataset, domain adapted legal models do not outperform general purpose models. We also performed an error analysis, and it emerges that the system, the model, tends to be able to learn the taxonomic structure, and this is further highlighted by the fact that most errors occur within each annotation layer. We set up a demonstrator, so you can find it at this URL, and you can play around with it and try all the models we described in the paper. You can also use your own text if you want, and see what happened. And the dataset has been released, is available on GitHub, on our GitHub account, and as well as the model, which is available. We just made available the best model on Hugging Face. So if you are interested, please drop by at the poster session, and if you have any questions. Thank you very much.
Okay, thank you very much for the presentation. And our next speaker is going to talk about towards mitigating perceived unfairness in contracts from a non-legal stakeholder's perspective. So that's Anmol Singer, right? Okay, please. You're going to share? Okay, let me just unshare mine.
Good morning, everyone. Today, I, Anmol, I'm here to present our work at ECS Research on mitigating perceived unfairness in contracts from a non-legal stakeholder's perspective. So contracts are legally binding agreements among different parties, and it is very important that we comply with them. Otherwise, they can lead to financial and legal ramifications. Legal teams within organizations undergo various iterations to ensure that they are perceived as fair by all stakeholders. However, we observed that there was a critical gap in the contract drafting process, which was that the perspective of non-legal stakeholders. Now, these people are not directly involved in contract negotiations, but are nevertheless responsible for a successful implementation of the contractual obligations. These stakeholders can be project managers, engineers, designers, delivery personnel, and so on. So to capture their perspectives comprehensively, in this work, we automated the classification of potentially unfair clauses from their perspective. So the first aspect of our work was to analyze and comprehensively define fairness from the perspective of non-legal stakeholders. So to initiate this, we conducted an empirical study, a questionnaire-based study involving 15 non-legal stakeholders. These stakeholders hailed from various backgrounds, and we also corroborated the findings by sharing them with 3 legal professionals to gain their perspective. Based on the findings of the study, we formulated a ternary classification task. It essentially classified contractual clauses into 3 categories: fair, potentially unfair, and clearly unfair. In the case of clearly unfair clauses, these were the cases where there was a direct imbalance in the rights and obligations of the parties. An example of such a case can be a clause which, say, unilaterally gives one party the right to terminate or modify an agreement. Subsequently, there were potentially unfair clauses. This was an interesting case because there was some difference of opinion between a few legal and non-legal stakeholders in this regard. But it largely said that all ambiguous clauses that may lead to a perception of risk can be also considered potentially unfair. Apart from that, there were other cases of potential unfairness that we observed. Some can be very contextual project-specific scenarios, and even human-level factors affecting fairness. Because large language models at this point do not deal with such contextual factors, especially in the case of long documents, very well. We eliminated project-specific scenarios and human-level factors in this work and focused on identifying potentially unfair and clearly unfair clauses. Our data set consisted of 45 English contracts, which we used for fine-tuning our models. This data set was manually labeled, and since it was a very manually intensive task, we chose about 1,200 sentences for labeling, and the rest of the data set was kept unlabeled. So there were 2 major challenges in dealing with the classification. The first was the unavailability of labeled data, and the second was class imbalance, because the data set was skewed in favor of fair clauses, and potentially unfair and clearly unfair clauses were very limited. So the first strategy that we used was a combination of semi-supervised learning and data augmentation. So to augment data from the minority class in our data set, we used ChatGPT. We generated sentences using a few shot prompting strategy for the minority classes in the dataset, and subsequently use self-training, which is a semi-supervised learning paradigm, to improve the performance of the base classifier through unlabeled sentences. Subsequently, we also experimented with the in-context learning capabilities of large language models. Specifically to tackle this ternary classification task, we experimented with few-shot chain-of-thought prompting, and we also incorporated direct prompting as a baseline. Moving on to the results, it was observed that, so for data augmentation and self-training, we experimented with BERT. And for other prompting-based guidelines, we experimented with large language models such as Vicuna and Llama 2, which were fairly larger in size as compared to BERT. However, we observed that self-training and data augmentation combination performed the best. It outperformed chain-of-thought prompting by a margin of about 12% if accuracy is compared. So this was very interesting because large language models typically are good at, they've been shown to be good at in-context learning capabilities, but still we observed that in this particular case, semi-supervised learning was outperforming that. So to analyze the model predictions further, we did compare the predictions made by chain of thought through a qualitative analysis, and we observed that there were specific cases where large language models were kind of struggling with identifying instances where complex reasoning was involved. For example, there was a sentence which sort of was a misclassification. There was a word which said frequently, which is an ambiguous term, but it was followed by a term once in 2 weeks that sort of creates boundaries and negates the ambiguity of the particular sentence. The model misclassified this as ambiguous because of potentially unfairness, but in reality, this sentence is a fair sentence. So we observed that such cases where contractual language was a bit complex, the model misclassified the sentence and did not perform the reasoning accurately. So in conclusion, we formulated a task to classify unfairness from the perspective of non-legal stakeholders. Our experiments using a combination of self-training and data augmentation outperformed other in-context learning approaches. And in future, our goal is to build an end-to-end assistant that can provide recommendations to legal stakeholders regarding the perspectives of non-legal stakeholders. Thank you.
Thank you. So now we have our next presenter. So the paper is low resource Deontic modality classification in EU legislation, and it's going to be presented by Kristina Minkova.
Okay.
Okay.
Hello, so my name is Kristina Minkova, and today I'm going to present to you our research with Shashank Chakravarti and Gijs van Dijk on low resource deontic modality classification in European Union regulations. Okay. So what is deontic modality classification? It is the task of training a classifier to classify sentences in legal documents as either obligations, permissions, prohibitions, powers, or rights, or non-deontic sentences. And it can be extremely important for example, for making law more machine readable and for implementing it in, for example, automated compliance checking systems and norm identification algorithms, or for legal argument mining. So our motivation for this research stems from the fact that human-based approaches and rule-based approaches are very error-prone, and also they're very difficult to transfer to different legal systems or changing legislation. Another main bottleneck was the data scarcity, of course. We thought we can collect the data ourselves, and we started doing so, but we quickly found out that it's very time-consuming and costly, because for legal annotation, you either need a few annotators to avoid bias, but you also need a certain level of agreement between them so that it's consistent with the law. So at some point we were like, okay, is there, with the current data that we have, is there a way to reach or exceed the state-of-the-art performance, given very limited data? So one way we thought of doing that is by leveraging, for example, in context knowledge of pre-trained networks like BERT, or by using a small classification model that requires no pre-training and is more robust in a lower resource setting. Also, is there a way to adapt the data by, for example, balancing the classes, or by using a different loss function so that we get better results. So in more detail, we gathered 200 unique EU provisions annotated by 3 annotators. So each set had around 560 deontic sentences and 75 non-deontic sentences that were very imbalanced and skewed towards the obligation class. So the first technique was to undersample the majority class, and the other technique was to use focal loss together with the unbalanced data set, because focal loss aims to downweight the loss from well-classified examples, so focusing the model more on the harder minority classes. The experimental setup consisted of a legal BERT on one hand, pre-trained on EUROLEX data, and the fusion model on the other hand that required no pre-training and consisted of convolutional BLSTM layers and attention layers. From the results, we can see that both models were biased towards the obligations and permissions, but the fusion model significantly outperformed a legal BERT, and it showed to be less sensitive to class imbalance and also more receptive to prohibitions and rights. In terms of class balancing and focal loss, there were no extreme benefits, because more or less those techniques led to focusing the models from certain classes in favor to other classes. And we saw that the misclassifications of both models were overlapping, and some of them stemmed from a genuine disagreement, others from longer dependencies. So what we see in the future is that we can focus more on extensive data retrieval and annotation. We can also implement ensemble models that capture better the genuine disagreement. And we have to further investigate smaller classification models that focus on low resource tasks and on, for example, focal loss on data sets with higher class imbalance. Thank you very much for your attention.
Thank you. Thank you for the presentation. And our next presentation is transferring legal natural language inference model from a US state into another. What makes it so hard? And Alice Kwok will be presenting.
Good morning, everyone. My name is Alice Kwok, and today I'm going to present my work titled Transferring Legal Natural Inference Model from a US State to Another. What makes it so hard? So, to start, assessing legal documents validity can be framed into a legal natural inference model, legal natural inference task, when 2 adjustments are made. First, we need 3 inputs: a statement that should be evaluated and the conditions that's relevant to the evaluation of the statement, and a law, instead of 2 inputs like premise and hypothesis. And also, we need to switch the label to support, refute, and unrelated instead of entail, contradict, neutral to better fit the purpose of the task. And developing this legal NLI model is highly beneficial. Like, we can assess legal documents validity automatically, but it is very difficult to develop, especially if it is in the United States, because different United States state have different laws. So there is no guarantee that a model trained on a single state law would work equally well in another state. However, it is very difficult to gather data from all 50 states. It is really time and labor intensive work. So we were wondering if it's possible that we can transfer a legal NLI model that is trained on one United States to another state. So there's the focus of our work. And we also focus on the task of assessing the legal will statement's validity in this work. And we also identify sources of error by conducting error analysis. So this is our method, and it's actually simpler than what it looks. So we use two legal NLI dataset, one consisting of a data from Tennessee, and another consisting of Idaho wills. So with these two datasets, we fine-tuned a transformer model, the Volta one, and we predicted both in-domain data and out-of-domain data. And what I mean by in-domain is the data from the same state. So for instance, if we are using the Tennessee model, that's going to be predicting Tennessee states, will statements. And for out-of-domain, for instance, if we are using Tennessee model, it's going to be Idaho data that we are predicting. And after that, we compared the results from these two different settings. And afterwards, we used LIME technique to conduct the error analysis. So this was the method. And here are our results. So we'll focus on these F1 scores. And as you can see, both Tennessee model and Idaho model show very good performance in the in-domain setting because both of those models had over 90% F1 scores. And another thing to notice is that the models can be mostly transferred to another state, but it seems like their performance in the cross-state setting deteriorates. Like, for instance, Tennessee model only got about 66%, and then for Idaho model is around only 80s. So that's lower than in-domain setting. So we wanted to know what made those performance drop in those out-of-state, out-of-domain setting. And we found out that one of the major error types was wrongly predicting support or refute cases as unrelated cases. And we also found out that this came from the model's failure to recognize laws in another state due to some stylistic differences. And what I mean by stylistic differences was something like capitalization. For instance, in this case, we can see that, I'm not sure if this is seen in the screen. Yep, so this execution is actually a keyword for this case. This was relevant to will execution case. So this makes no sense that the model used execution to make prediction as unrelated. But it did. And we found out that this came from the capitalization of these law titles because Tennessee model was fine-tuned only on Tennessee wills or Tennessee laws, but it hasn't seen any of these full capitalization cases because Tennessee laws doesn't usually contain fully capitalized words. But on the other hand, Idaho laws, all the law titles are fully capitalized. So it seems like these subtle differences in styles has caused this model to perform worse in this out-of-domain setting. And another thing that we found out is there were many cases where the model wrongly predicts unrelated cases as support or refute. And interestingly, we found out that this difference, this came from the difference in statutory section numbering system. And what I mean by statutory section numbering system is these low numbers. And as you can see, the model utilized these number pretty much to predict this unrelated case as support. And this is because of the difference of this numbering system. In Idaho, Idaho state laws use these title dash chapter plus section numbering. Like for instance, if the title is 14 and chapter is 1 and section is 1, it comes up to 14-101. But there is a small portion of Idaho law which use different section numbering system, like title dash chapter dash section. So because of this difference, it seems like the Idaho model learned this difference and use this to distinguish between those that are relevant and then those that are irrelevant. However, in Tennessee, there was no such differences, so it seems like Idaho model struggled with the statutory numbering system. So here's our conclusion. So we found out that the legal NLI model trained on the data from one state can be mostly transferred to another state, but it seems like the performance deteriorates considerably. And we found out that two major causes for the performance drop is the model struggling with identifying equivalent laws across states when there are stylistic differences. And another is that the difference in statutory numbering system between the states make the model less well-performing. So we can suggest hints for the design of the future legal analysis system, which is first, including a knowledge base with equivalent laws between states would greatly help improving the model's performance. And second, normalization of the low text formats, such as capitalization, can also be very helpful. And our work also provide empirical support to the legal experts for the argument that legal documents such as wills should be standardized because differences in legal documents, like very sudden ones like capitalizations even, or like formats between the states can easily interfere with the model's performance. So that was the end of my presentation, and thank you so much for listening.
Thank you for the presentation. The next one is legally enforceable hate speech detection, and Chu-Fei Luo will be presenting. I think I saw him online. No, he's here. Oh, yeah, you're presenting from your laptop, right? Okay.
Thank you. Hello. I lost my slides, so I'm just going to be presenting my poster, if that's okay. My name is Chu-Fei. I'm from Queen's University in Canada, and today I'll be presenting my work, Legally Enforceable Hate Speech Detection for Public Forums. So hate speech is currently a very serious issue on public forums such as social media, and so it's very important to policymakers and other stakeholders that we should be able to regulate the content that is being published on these platforms. And so we want to create a new task to evaluate automatic detection methods. And we call our task Enforceable Hate Speech because we want to assist policymakers in finding samples of social media posts that are indictable under the law. At the same time, this is also helping with a known issue in hate speech detection called like inter-annotator subjectivity. So different people can have different thresholds for what is hateful and what is not. And various existing hate speech data sets also have issues with like poor inter-data set performance. So a model trained on one data set can perform poorly on the test set of another compared to like training and testing on the same data set. And so we hope that legal definitions, which are like standardized and brought into law after many rounds of revisions, are more rigorously defined. And so we take legal definitions from 3 sources of Canadian law. So one is criminal code. The second is human rights codes, which is provincial civil law. And then finally, hateful conduct policies from social media platforms. And next, we annotate a bunch of social media posts with the help of legal professionals. So we give them the full body of law related to our 11 definitions of hate speech from these 3 sources. And then they are asked to identify offenses. Sorry, that's a bit offensive in the diagram. But after they identify potential offenses, they then map violations of our definitions. For data collection, we sample from previous data sets, as well as some of our own collected data. And this is to gain lexical variety in our data, as well as to compare how our definitions compare to others. And we find that in general, our legal definition has a lower positive rate compared to existing works. And after consulting with the legal annotators, we find that previous works conflate hate speech with discrimination. And while these are very related issues, they're also different in a legal context. And so for experiments, we run zero-shot instruction prompting with several baselines. And this is just to simulate like the scenario where a policymaker just has a definition and they just want to ask like ChatGPT what to classify them. And so then we do 3 classes of like a violation, does not violate, and then an unclear class for when the context is incomplete. And so we experiment with GPT 3.5, GPT-4, as well as a whole suite of open source models, including Falcon, Wizard LM, and Llama 2. And then this is our prompt template. So it's just a very condensed format of the legal definition that we give to our legal experts. And then we also ask for reasoning. And so here is our results table. And so you can see that GPT-4 performs the best, with GPT 3.5 following after. And then the smaller language models that we were able to test are a little bit after that. And they perform roughly around the same as random guessing. And after some error analysis, we find that the reasoning of the smaller language models can sometimes be lacking. And actually, the reasoning of GPT-4 can sometimes exhibit this behavior as well. I don't know if I can zoom in the full way. Okay, that's all right. But I'm just talking about the table 1 here. So for example, this is a explanation from Wizard LM, and it is wrongly predicting a violation of Criminal Code Section 318, which is advocating genocide. And it's comparing to annotator notes. And you can see that Wizard LM notices the same aspects of the post that are problematic as annotators. So it's just like promoting the hatred of women. But it's wrongfully predicting this as genocide. And so this is sort of showing that the language model can understand social media posts, but it might have a bit more difficulty understanding like our legal definitions that we're providing it. And yes, this is pretty much it for my presentation. For more details, please feel free to find me at the poster session. Thank you.
Thank you for the presentation. I should have mentioned this is a findings paper, an EMNLP findings paper, as well as the next one, which is the last in our session, which is named More Than Votes, Voting and Language-Based Partisanship in the US Supreme Court, and Byron Fang will present.
Hello everyone, thanks for being here. My name is Byron Fang, and today I'm going to present our EMNLP finding paper, More Than Votes and Voting and Language-Based Partisanship in the US Supreme Court. And first, So first, let's look at the partisanship in court and in American system. And partisanship can roughly categorize into 2 parts. One is Republican, and another part is Democrat. And in the Supreme Court system, justices are usually nominated by the president and is confirmed by the Senate. And the nominations are usually aligned with the interests of the party where the president affiliated with. And current research has showed that the court are now sharply divided by the nominated party, which the Republican nominees tend to be more conservative, and the Democrat nominated tend to be more liberal. And in line by this, and in our finding papers, we propose 2 research questions. The first is, to what extent do our arguments reveal justice partisanship? And the second question is, how does language-based partisanship align with the voting-based ideologies. And so for the task, and we model the task by given the justice speaking, which is the instance, and trying to predict the speaker's affiliation, which will be Republican versus Democratic appointees. And for the dataset, we obtained the transcript from the Super-SCOTUS dataset, which is the dataset we also published in this workshop paper. And we created the instance by concatenating all the terms from the individual justice in a single court hearing. So as an example shown on the right-hand side here, we have the conversation in the courts, and we extracted the specific instance from the particular justice. For example, we have the porter's duty here, and we concatenating all the speaking from the particular justice and try to predict it, the affiliated party of that particular justice, which for him will be Republican nominated. And so for our experiments, we run the 10 false cross validations, and we run the Burr model, and we compare with two baseline. One is random and another one is majority. And from the experiments, we can see that the Burr model outperformed the baseline method and is indicating that the wording of the oral arguments actually reveal the justice party affiliations. And for the next, so for the next one, we investigating how does those language-based partisanship align with the voting-based ideologies, and based on the hypothesis that the arguments actually reveal justice partisanship, which is Democrat versus Republicans, and we predicting the binary partisanship of the speaking justice and from the languages, and we compare with the voting ideologies, which obtains by the justice voting in their final case decisions, and we use the Martin and Quinn score to quantify the ideologies from their voting. And as shown on the right-hand side, we have the speaking from the justice, and we have their voting, and we compare the political leanings with them from them. And so the first experiment we did was at the course levels, and as shown in the graph here, the gray dashed line represented a neutral line, which means that there's no political leaning. And above it is more conservative, below it is more liberal. And the blue line represented the Martin and Quinn score, which is the voting-based political leaning. And the orange line represented the language-based partisanship. And as we can see here, and these two measurements have a very strong correlation, which with roughly Pearson R-score equal to 0.6. And further, we experimented with the justice level partisanship, and we plotted the justice level partisanship for the justice over their tenure. And for illustration purpose, we only show two justice here, and different color represent different justice. And the dashed line represented the voting-based ideologies, and the solid line represented the language-based partisanship. And we can see that the Republican affiliated and the Democratic affiliated are consistently split by the neutral line. And the MQ scores and the language-based partisanship for the Democratic justice, which is below the line here, below the gray dashed line. And they're actually well aligned over their tenure. And for all the Democratic justices, they have roughly larger than 0.6 Pearson's R-score. So for the takeaways, and we propose an analysis framework and showing that the Burr-based classifier can reliably predicting the affiliated party of the justice based on their linguistic signals. And we derive the language-based partisanship scores, and we compared it with the established voting-based ideologies at the cause and justice level. And we also made our data and the codes available in the GitHub links here. And thank you.
So that's the last presentation of this session. So we were a bit behind schedule, so we're actually in the break. But I think we can take some questions in the QA, and if you want to go grab a coffee or a snack, you feel free to do it. So there were some questions in the chat before. If you want to ask a question from Zoom first, if not, we can go to the room. Okay, Ilias.
Hello, I had a question about the very last presentation.
It was about the political inclination of the justice, and I want to ask that, of course, there is some sort of political affiliation from the justices, but I guess your results may be also affected by the topic. So maybe in some years in the corpus, they discuss more sensitive topics, and then their political affiliation can be more clear. And then in some other case, maybe they are pretty much neutral topics that are not very contradictory in terms of conservative versus liberal. So did you try to consider how this kind of thematical change affects the result, or how you can use it to normalize the results to track it a bit better? Thanks for the questions. And one of the experiment we were trying to do is trying to extracting the important tokens from the text, so that we know which actual tokens actually giving away the information of our linguistic signals. And we were trying to see if we can extracting some important tokens, and so that we can know that how those linguistic shipments, and it could probably break down into different topics too. But we realized that it's because it's in a conversation, so it's a bit hard to extracting very meaningful words there. So I think that's a really good question. So probably it will be like in the future works that people can actually look into the actual text and to see which words actually giving away the information, and then we can break it down into different topics so that we can see, for example, in the security, and the previous one maybe like invading the house or all these things. But right now we're more talking about cybersecurity, so it will be it's a very interesting. It will be very interesting to see those things, but maybe it will be in the future work. Cool. Thank you.
I also have a question for Bao Yan. So your analysis is at the purchased level, right? So I wonder, a lot of U.S. Supreme Court decision are like majority decision, which is like supposedly written by one judge and joined by, I don't know, 4 or 5 other judges in the court. So how do you sort of attribute authorship for those multi-judge opinions? Like, is it gonna be attributed to just the leading justice or every judge on that decision?
Repeat again.
So for those decisions that like decided by multiple judges, do you attribute it to just like the leading judge who supposedly wrote that decision, or do you view it as like joint decision by every judges?
Right. So for that, that's mostly just for one particular justice voting. So every justice in the data set, they have the voting for every individual justice, and for each voting, they're actually indicating their political leaning. So we in the data set, they do have the majority voting, but when they do the voting ideologics analysis, they only looking into one particular justice voting, so that they can divide their party leanings from that.
And for the text analysis, is like when you actually look at the opinions rather than just the voting, is it also at the purchase level?
Yeah, because in the paper we actually have 3 levels. One is at the cause level, and another level will be the justice level, and we also have the case level. That's what you might be referring to. It's the majority voting, so it will be based on individual cases. And yeah.
Any other questions from? Otherwise, I can ask. I wanted to ask a quick one for Chu-Fei. Did you do any other experiments going beyond zero shot, just to kind of see where kind of the, kind of what's the room for improvement?
Right, yes. We use the LMBFF method to adapt Roberta Large for prompt tuning. And so we did some experiments with generating silver labels with GPT-4, as well as self-training. And for our task in our data set in its current iteration, I guess, the labels are too rare to learn, like the fine-grained labels for each definition. But we did see improvements on like coarse-grained, like is there a possible violation? Yes, no, or unclear. But yeah.
So there's more in the fine grained.
Yeah.
Okay.
So I have again a question for the same paper. You said that there was a discrepancy between what is considered hate speech from a legal perspective, and what sort of definition people used in building previous data sets from Twitter. And I want to know if you have some more insights about what was the, maybe in what specific subjects there was a discrepancy, because before what's considered hate speech in this data set and what is legally enforceable. So is it more about specific ethnic groups or LGBTQ groups or some other of hate speech towards other demographics maybe?
Yes. For the legal definition versus like other definitions, it wasn't a matter of protected groups. It was more like the legal definition is more about overt statements of hate and like the dehumanization of people in general. Whereas like a lot of the other works, for example, there's one called implicit hate speech that's more focused on microaggressions and more like subtle forms of discrimination. Yeah, for the purposes of our work and creating a very concrete definition of hate speech, we just focus on overt statements.
Thank you a lot.
There was a question from Zoom for a while. So Carolina, do you want to unmute?
Yes, hello. I have a question for the speakers of long test classification using transformers. Yes, can you hear me?
Yeah, we can hear you.
Oh, thank you. Oh, yeah. Yes. I am curious about the methodology and the segmentation that they apply to the tests before passing them through transformers. So I really want to hear more about how they organize pre-processing the data sets to pass through transformers. That it makes sense?
So are you looking for pre-processing for the paragraph selection, or in general pre-processing across
Yes,
all
the
of
method.
those?
Yeah, I would say the methodology. How did you decide to select the paragraph before passing to transformers? This is my question.
Yeah.
How do you decide? What was the methodology to do that?
Yeah, so the idea there is that you have basically a baseline model, which is the TF-IDF plus neural net, a simple neural net. Using that baseline, we first score all the training samples, right? Training documents, and then split them into chunks. So basically, yeah, so you have what I'll call a document level baseline model. You use that to score all the chunks in any given document, and then use the chunk that has the highest prob for the target label for that sample. So because you have the luxury of having labels in the training data set, so you can use the label. And the idea is that given the label, which chunk gets the highest prob using the baseline model, we use that chunk.
Okay, thank you.
Yeah, my question is for the large language models paper. So did you measure the consistency part of it? If you're using ChatGPT, for example, did providing the same prompt and structure yield the same result again and again? Or was it just a one-off test or evaluation? I think the question is for Chu-Fei for the large language models yeah.
Sorry, could you repeat the question?
Yeah, basically my question was, did you check for consistency in terms of the results that were obtained by, let's say, for example, ChatGPT, or was it just a one-off question, in the sense one-off prompt and you got some results and that was evaluated?
Yeah, we just had one-off results.
Okay.
Yeah, but we used greedy decoding, so it's like the most deterministic answer.
Okay.
Sounds good. I think we should probably stop here to give everyone 15 minutes to grab coffee and snacks, and we'll restart at 11 sharp. Thanks to all the presenters again.
Bye, Bashor. Yes, can you hear me now?
Yes, I can hear you.
Okay,
But
can
I
you?
think everyone is in a break. So yeah.
Okay, I think we have Vaiba, the first speaker. He's with us. Vaiba, can you unmute yourself and start presenting?
Yes, am I audible?
Okay, cool, thanks. Cool, you can start whenever you're ready.
Oh, thank you. Yes, so hello everyone. My name is Vaibhav Mavi, and I'm here to present our paper, Retrieval-Augmented Chain of Thought in Semi-Structured Domains. So I'll start with a one-line overview. This paper focuses on leveraging the strong natural language understanding abilities of LLMs for answering complex questions in legal and financial domains by exploiting the semi-structured nature of these documents. So to start with some background, we are familiar with like multiple prompting techniques which are used with LLMs, and they have been proven very successful. We have zero shot and few shot, and we also have chain of thought prompting. So in chain of thought prompting, we have the in context examples, which are like pairs of input and output samples, in this case, question and answer. And we also provide a chain of thought reasoning, which is a step-by-step reasoning process, which is used to derive the answer. So, and chain of thought has been successfully used in multiple applications. So we want to use this technique. But the major drawback of using LLMs is that they do not work well with long context. As we can see on the figure on the right, the accuracy starts to go down when we increase the number of documents in the input context, or like we increase the length of the input context in general. And this is an issue because in financial and legal documents, we might need to use information coming from different sources. And we might have complicated questions which require very long context. And doing so will be a major challenge. And also, since we want to use chain of thought prompting and in context examples, and we want to have multiple of in context examples, that will also lead the context size to blow up. So we want a way to like very efficiently restrict the context. So therefore, we need some retrieval techniques. And to do so, we first observe that the text in legal and financial documents are semi-structured. So as we can see on the figure on the left, this is an example of a section from US Internal Revenue Code. And the text is organized into sections, subsections, bullets, paragraphs, which can lead to very easy extraction of information. So what we do is we build simple retrieval algorithms to retrieve these pieces of information which are relevant to a particular question. And we then feed it to the LLMs. So first of all, the data that we use comes from two data sets. One, SARA for a legal domain. It has questions based on statutes from the US Internal Revenue Code. And each question is either an entailment or contradiction. So it's a binary problem. And on the other hand, for financial domain, we have FinQA, which contains questions based on financial reports. And in this case, the final answer is a real number, or in some cases, percentages. So we also output the program. In this case, a program is defined as a sequence of mathematical operations which are needed to derive the answer. And the methodology is simple as explained. Like we use two basic components shown in purple, the retrieval and LLM. Retriever retrieves the context, and we then append the retrieved context and the question to the in-context examples. And these in-context examples contain the chain of thought reasoning, which were manually created by us. And we append them to get a chain of thought prompt, which we feed to the LLM to generate the answer. And we get these results. So on the left-hand side are the results for SARA. And the top section is traditional baselines. The middle section is GPT-based baselines. And the bottom section is our models. As you can see, we experiment with GPT-3 and Llama 2 models. And we see that the model based on GPT-3, along with the retriever, can significantly outperform the current baselines. And even the Llama 2 70 billion models is able to perform well. And as we know, like the model performance increases with model size, and GPT-3 being 175 billion is much better than all the Llama 2 models. And on the right-hand side, we have the results for FinQA. And so the second section contains the results of our models. We see that we're able to get a very similar performance on program accuracy, but the answer accuracy is actually lower than the program accuracy. And this can be attributed to the fact that LLMs can produce correct programs, but they have very frequent arithmetic errors, which leads to incorrect answers even when the program is correct. So they're able to find the correct equation, but they're not able to solve the equations correctly. Yeah, so in order to conclude, we see that the advantages include that since we use in context learning, it avoids the need for any training, which saves significant time and cost. It avoids any data privacy issue that can come from training. And chain of thought reasonings improve the interpretability of the system, which make them easily usable. And for limitations, we have like frequent arithmetic errors that we just discussed. And since we used a very simple rule-based and word-based retrievers, we think more powerful retrievers can get better performances. Thank you.
Do you hear me now? Yes, okay. So yes, again, we have a joint QA session in the end. So we'll move to the next paper. It's called Mixed Domain Language Modeling for Processing Long Legal Documents. Do we have the, yes, we have the authors here. You have to join. Perfect, and you talk to the microphone here, and you're muted, right? Perfect.
Okay. Okay. Hello, everyone. I am Wenyue from the startup Claudius Legal Intelligence. Today, I'm going to present the paper and also the language model, Legal Relectra, mixed domain language model for processing long legal document. Okay, so here's a brief introduction to the Legal Relectra. So Legal Relectra is a small language model focusing on applications in the law with specialization in personal injury civil suits. Here, the small language model is compared with large language models that we have, like GPT 3.5 or GPT 4. Personal injury legal cases arise when an individual suffers harm from accidents or injury, and someone else might be legally responsible for the harm. And this can due to negligence, reckless behavior, or intentional misconduct. Personal injury law allows the injured person to go to civil court and get legal remedy for all losses stemming from the accident. Personal injury claims are quite common in lawsuits, constitute a substantial part of civil litigation. Therefore, having a language model that specializes in personal injury cases is vital for AI in law and legal business. So here are two main challenges for building such a language model. So first of all, we have very limited access to high quality pre-training data. So data on civil cases is often siloed due to privacy restrictions, and there are few publicly available curated dataset. So therefore, we focus on development of a small language model, which can be trained, tuned, and run on small dataset in a cost-effective way. And the second part is long document. So we all know that legal documents are notably very long, and in order to extract the key information, such as the information of plaintiff, defendant, accident process, decision process, also description of the injuries, in a case, it often requires long-range text comprehension and reading. Thus, as a small language model, we adopt the reformer structure with context length 8,192 and pre-train this model in an Electra style, where we have a discriminator and a generator. And the discriminator is used as the final language model. So here's our pre-training data set. So we know that we have very few data set that's actually for personal injuries. Thus, we accompany this with general legal document and general medical document in order for the language model to get enough legal knowledge and also medical knowledge. So for the legal part, we have data from case descriptions from different legal branches that we cooperate with. And sources from legal sources include court listener, which is a huge data set, include oral arguments, opinions, judges, judicial financial records, and federal filings. Initiated by the Free Law Project. For the medical part, we use the MIMIC dataset, including doctor's notes and letters. For the mixed part, which is actually the personal injury that combine both legal information and medical information, we have personal injury case description from Supreme Court opinion, academic literature, court listener, BYU law, and also quick case descriptions from attorneys and legal firms. So in total, we have a 12 gigabyte corpus, which is similar to the amount of corpus when pre-training BERT. So we test this small language model on 2 real-world applications. One is named entity recognition, and the other is legal case retrieval. So in named entity recognition, we want to extract relevant information or key information from the text, such as information about plaintiff, defendant, and case type. And we compare with other small language models, such as BERT, also legal BERT, clinical BERT, etc. And it does show a pretty good performance. And the second one is legal case retrieval. And we all know that when doing legal analysis, either in firms or in academia, a crucial step is to identify similar legal cases from a given collections. And so here is our task. We manually construct a data set comprised of 500 cases selected by law firms from Kentucky and Louisiana. Each case encapsulates various information, and we conducted these experiments in without any fine-tuning because such data set, like a larger data set for fine-tuning this model, will be very, very hard to construct. So we only have the test data set here. And from the experiments, we manually check the top 1 retrieval result and check whether this retrieved article has a matched claim type or injury description, gender, age, medical expenses that are usually key information in personal injury cases. And we can see that we have a very high performance on claim type and injury descriptions, but notably not very good in expenses, which is usually represented in multiple numerical numbers. So here is our model. Thank you.
Thanks to our speaker. We move to the next talk. I think we have the speaker here, Tanmay. The paper is called Large Language Models Are Legal, but They Are Not, Underscoring the Need for Better Legal LLMs. Perfect.
Hi, everyone. I'm Tanmay. So our paper is based on the idea that several domain-specific LLMs have been developed, such as Bloomberg GPT for finance, MedPalm for medical questions, and so on. And so we investigate the LLM scenario for the legal domain. So to start with, the current SOTA models for the legal tasks are typically BERT-based variants. And the major implications of this is that BERT-based models typically have 512 tokens as the context window size. This is a major challenge for long documents, as can be seen in the legal domain. Another limitation is that such transformer models that use BERT have a traditional attention mechanism which requires a quadratic memory. This was taken from the LEXTREME benchmark paper. So you can see that a lot of the tokens are 2,000, 3,000, and around that range for subwords, and it could increase for few short settings, obviously. So now the question that we like to tackle is that with the surge of large language models, they have large amount of parameters, large amount of pre-training and in-domain knowledge, large context window size, time and memory efficient attention mechanisms, some being even linear memory attention mechanism. So the question is, can LLMs address the aforementioned problems, and how well do they perform on legal tasks? So more formally, our contributions are: we conduct experiments to compare and analyze the zero-shot performance of tree-chat-based LLMs to that of state-of-the-art in-domain models. We analyze our results, quantify whether LLMs conform to expected advantages, and provide insights for further research. And we also provide an overview of the most recent LLM research, the benchmarks and datasets developed for legal NLP, the challenges faced when applying them to legal tasks, and popular approaches that solve them. So coming to the data set, we use the LEDGAR subset of the LEXCLU benchmarks, which is a contract provision classification task of 100 unique labels. So we sample only 1,000 samples from the test set for zero-shot classification, but we maintain the same class distribution for generalizability. And this is the prompt for reference. As for models, we consider three chat-based LLMs for zero-shot evaluation: OpenAI ChatGPT, Meta Llama 2, and TIA Falcon. And for comparison, we consider two legal domain models. One is LexGPT, which is derived from GPT-J and pre-trained on Pile of Law. And for the SOTA, we have Legal Birth in the LexGlue benchmark. So on the right side, we have a rough comparison of the context window size and complexity and the number of parameters. So coming to our results, we found that smaller in-domain models perform better than larger chat-based LLMs. And the best chat-based LLM, which is Falcon, performs 19.2% micro F1 and 26.8% macro F1 lower than the best in-domain model, which is Legal Birth, which itself is much smaller than LexGPT, the current legal LLM. This is taken from the paper ChatGPT may pass the bar exam soon, but has a long way to go for the LexGlue benchmark. So if we look at the last three columns, which is zero-shot ChatGPT evaluation and few-shot ChatGPT evaluation, Legal Birth, which is the best reported score, performs best on all the tasks. Coming to a label-wise analysis of our results, for class labels with only one example in our sample test set, the chat variants surprisingly show the same results. They fail to predict them currently, except the qualification label. The others being assigns, books, and powers and sanctions. Further, labels that are semantically similar are frequently mislabeled by the model, such as taxes, tax withholdings, etc. And on average, only 95 of the 100 total classes in the reference labels are present, which severely brought the F1 score down, micro F1 score down. So for a subjective analysis, our findings highlight that the perceived advantages of LLMs that have over BERT-based models cannot substitute for the obvious edge in-domain data can give to much smaller models. So this could be expected, as the latter is more naturally suited for benchmarks classification tasks rather than generative models, which are prone to issues like hallucination. And our label-wise findings reflect this too. However, if we limit the application of legal models to NLU tasks, large context may not be necessary for classification. This could be because verbose legal text could turn out to have very similar semantic content. To conclude, we examined three general-purpose LLMs in zero-shot settings on a multi-class contract provision classification task using the LEDGAR dataset of LexGlue. Our study shows that these LLMs, even though not explicitly trained on legal data, can still demonstrate respectable theme classification performance, but are easily overshadowed by smaller in-domain models. So the result highlight the need for better legal LLMs. In light of this, we also present a review of related data sets and models, which we hope will get an overview of the field. So coming to the limitations of our work, testing how different prompts affect the performance would be useful. However, we only experiment with one prompt for simplicity. As we use an API for the chat-based LLMs, we were limited with the generative style for classification. It would be useful to evaluate the rank likelihood directly. Though we maintain the same label distribution for 1,000 samples, this may not still be generalizable, especially for labels having a low frequency. And we only evaluate on LEDGAR. Other works present results on the entire LexPool benchmark, and we focused on different models. So the future work could be legal and administrative data sets such as Pile of Law and MultiLegalPile can serve as pre-training data for LLMs. So LexGPT was trained on Pile of Law, and it could be further improved by using RLHF And that could be extremely helpful, paying wage for the first legal LLM to produce state-of-the-art results. That comes to the end of our presentation. Thank you.
Thank you, Tanmay. We move to the next talk. The title is Exploration of Open Large Language Models for eDiscovery. I think Samit is also online.
Yeah, I'm sharing my screen.
Yeah, Tanmay, you have to stop sharing so Samit can share.
No,
I think now you can, Samit, you can share.
Yeah. Are you able to
Thanks.
see my screen?
Yeah, it's perfect. Thanks.
Okay. So hello everyone, my name is Sumit and welcome to this talk on exploration of open large language models for eDiscovery. So this is the agenda for the next 5 minutes. Let's start by looking at what's eDiscovery and how it's different from legal information retrieval. So eDiscovery is like digital investigation into digital documents. So while legal information retrieval mainly focuses on retrieving relevant information or judgments from previous cases like case law or statutes, eDiscovery focuses on discovering digital evidences from one party's electronically stored record, such as emails, text messages, etc., by another party in response to some kind of protection requests from the judges, right? One of the key data sets that is used for eDiscovery is the Enron emails dataset that was used in the Trek legal track from 2009 to 2011. So this Enron dataset is from a company. So basically, there was this company called Enron, which was an energy and services company in the US, which went bankrupt in the early 2000s due to some accounting malpractices and so on. So the federal agencies that were investigating Enron released these emails to the public after the case was closed for research purposes. So this dataset has about 450,000 emails and about 230,000 attachments from about 146 top executives. So we mainly focused on the protection requests or the topic statements of 2011. So these are something like produced documents that are related to, let's say, operations of Enron Online or marketing of Enron Online and so on. So these topic statements are also called as 4 series topics. So in this work, we mainly wanted to show how LLMs fare well, like how the LLMs fare at responsiveness determination of emails to topic statements. And we wanted to generate a reasoning. So basically, we wanted to do classification and say that this email is relevant or not relevant to a topic. And we wanted to show a reasoning as to why it's relevant or why it's not relevant. So the data set we used here, the distribution is shown here. So the blue bars show the training data and the orange ones show the test data, the orange shades. So as you can see in the blue shades like of the training data, there's a high imbalance in the data. So you see that the number of relevant emails to a topic are quite low compared to the not relevant emails. So let's start by discussing the methods. So we first use the out-of-box models, LLMs, out of box without training. So we start with an initial prompt for each protection request. We take a subset of 50 emails for each of the topics. So in total, we have 150 emails, and we evaluate these prompts on this smaller set. So till we get a reasonable F1 score, we keep on iterating the prompt. We keep on updating the prompt. We make minor changes, and we see the performance. And once we get the desirable performance, we run it on the full set. So this is how we used it out of the box. So whatever final prompt we got, we used it for instruction tuning the models as well. So we use the training set that I showed you earlier, and we use approaches such as LoRA or the low rank adaptation and its context version because it needs very few parameters compared to full fine tuning the models. So we fine tune on the training set and finally evaluate on the test set, and the results are shown later for the responsiveness determination. So one main thing about this dataset is that it only has responsiveness labels. It doesn't have the reasonings for as to why it's relevant or not relevant, right? So why an email is relevant to a topic or why it's not. So we don't have the reasoning. So we observed that if we get an out-of-box reasoning, the smaller models, the 7 billion llama and or Falcon and the 13 billion llama, so they are not so verbose in reasoning, and most of the times they repeated the topic statements of the production requests. Like for example, 401 topic statement is about producing documents that discuss operations and or marketing of Enron Online. So for this topic, most of the times the model would say yes, the email is relevant because it discusses operations or marketing of Enron Online, or no, it's not relevant because it doesn't discuss operations or marketing of Enron Online. So if you see this, like the reasoning is not that useful because it's just repeating the topic statement, right? However, larger models such as Llama 70 billion, they are quite good at producing the reasoning. So they identify parts of email that helped in responsiveness determination. They can pinpoint to which part of email, like what's being talked about and so on, which helped it in determining the response, right? So what we did was we basically used the out of box larger models. We got the reasoning on our training data, and wherever the reasoning, wherever the labels were correct, we used the reasonings and we trained a smaller LLM, the 13 billion llama model. So in a way, we were like distilling the reasoning capability of the larger LLM and teaching the smaller LLM. So we finally did a user study where we compared the outcomes of 5 different approaches on a randomly sampled set of 20 emails where all the 5 approaches were predicting correct labels. So these approaches were out-of-box outputs of Llama 70 billion model, the Llama 2 70 billion, out-of-box outputs of the 13 billion Llama 2 model, GPT 3.5 outputs, Llama 13 billion fine-tuned using the reasoning generated by 70 billion, and then finally the reasoning written by the subject matter specialist. So for all these 20 emails, the reasonings were shuffled for every question so that there was no order. Like let's say for the first question, if it is 13B to 70B and so on, for the second one, it could be 70B, GPT, then 13B and so on, right? So that the study is totally unbiased. So we presented to 5 different annotators who are asked to rate the preferences, rate the reasonings generated by these models as per their preference. So we'll see the results later. So in this slide, you're seeing the results of our initial and the final prompt. As you can see here, what we found that emphasis on certain task-specific terms such as emails, topic, related, and so on, and delimiting the emails and topic statements, structuring the outputs, and providing guidance on how to arrive at the outputs. All these help the model to achieve better performance. And in the table, you see the classification performance of these models. So we see that while the out-of-box performance of the open LLMs is not so great on the F1 scores and recall as compared to GPT 3.5, after fine-tuning, they get really better. And you can see that it performs better than GPT 3.5 in most of the cases. And in this slide, you're seeing the results of user survey. So I'll only focus on the rightmost figure for the sake of time. So the subject matter specialists were asked to rank the reasoning generated by these 5 approaches that you see on the x-axis on a scale of 1 to 5, where 5 was the highest score. So as you can see, this plot highlights the mean and standard error of the reasoning preferences assigned by the SMEs. So this is the average. You can think about the dot as the average score, right? So we can see that SMEs preferred the reasoning generated by Llama 70 billion out-of-box models most of the times. And we see that while the out-of-box performance of the smaller model, 13 billion model, is not so good, but after fine-tuning it with the reasoning generated by the 70 billion, it got really better. And it has similar performance as the model that was used to teach it, which is the 70 billion, right? So one of the key takeaways is that by fine-tuning smaller models, we can get good improvement both at responsiveness determination as well as by at reasoning. And our user study supports this. So in future, we'd like to cover a broad range of topics like the 2 series and the 3 series of 2009 and 10, while we focused here only on 2011. And we also want to perform a bigger user study and compute inter-annotator agreement so that it's more reliable. So thank you all for listening. So if you have any questions, you can email me. And this slide just highlights how we decided to choose the models decided in the described here in the paper. So thanks a lot.
Cool, thanks, Amit. We're gonna move to the next talk. Then we have Ali with us online again.
Hi, I'm just going to share my
Okay,
screen.
cool. Yeah. I will ask the two next speakers and the rest of the speaker if they can try to stick in the 5-minute slot because we are a bit behind the schedule. So do as
Okay,
best
just
as you can.
please let me know
Oh.
if you see my screen, and then I can just start.
Yeah, we see it. It's perfect.
Okay, great.
Thanks.
I'm Ali Hakimi-Parisi, and today I'm going to present our work on behalf of our team, a comparative study of prompting strategies for legal text classification. This was a collaborative effort between Thomson Reuters Labs and the Vector Institute. Nowadays, LLMs are being used to tackle many downstream tasks, such as question answering, summarization, being used in chatbots. However, the use of these language models train on a massive amount of data, normally on a general domain, still requires more exploration when using them in other domains like legal, which has a complex language, and also their long documents require specific consideration. Also, from the wide range of prompting techniques that has been introduced, which one would be the most useful one when transferring a foundation model LLM to a new domain without applying any domain adaptation technique? So in this work here, we decided to explore and find an answer for these questions for the task of legal text classification. We chose two data sets for this purpose, ECtHR and SCOTUS. ECtHR is a binary classification to determine if a human right article has been violated, and SCOTUS is a long-term multi-class classification, the task where Supreme Court cases decision are classified into 14 classes. Due to the limited resources that we had, we first downsampled these two data sets. You can see here the details of these two data sets. And also, since, as you can see, the lengths of the SCOTUS documents were much larger than the context list of most of the language models that we have access to, we first decided to shrink the size of the SCOTUS documents, summarize them using GPT-4, and bringing down the size to 512 words. And as our choice of our language model, we decided to go with OPT. We chose OPT since it's open source. It shows comparable performance to GPT-3, and it comes in various sizes. For our experiment, we chose OPT 6.7 billion and 175 billion. And since OPT models are not instruct-tuned, they are not suitable for question answering type of prompt. They are more suitable for completion tasks. Here you can see two types of this prompt that we use for our task, one for SCOTUS and one for ECtHR. And also, since the generation are not robust or unreliable, instead of getting the class label from generation, we use the distribution probability of the last non-padded token, and we pick the class with the highest probability. As the prompting strategies, we use zero-shot, few-shot, chain of thought, ensemble method, ensemble approach that, for instance, we took a bit in prompts, pass it to LLM, get several outputs, and then we use a simple voting mechanism to get the final answer. Here we choose three prompts, and the last one is activation fine-tuning, which is similar to fine-tuning other language models like BERT, freezing all layer, and then training a simple feed-forward on the top. As the choice of input, you can either pass the raw document or document plus a prompt. Here you can see the result for each of these data set and methods. One thing that right away pick our attention is the poor performance of COT, chain of thought, but we should note that OPT generation contains a lot of noise, which only misled the COT, and also COT mostly shows a good performance on those models that their training corpus contain code. However, the OPT corpus doesn't have any code. And we can see the activation fine-tuning with prompt and without prompt is the best performing method, and is getting close to the performance of fully supervised model shows as the black dotted lines. This shows that even though the model generation might not be high quality, however, the internal part of these language models contain rich information that could be beneficial for training a classifier. And for more details of these experiments, you can please refer to our paper. And also to make sure that our assumption that these language models are not suitable for question and answering and most suitable for completion, we also did some other experiment to compare these two type of prompts, one completion, one generation, on a SCOTUS data set, and using both models. And as we can see on both models, the completion task outperformed the question answering type, and the margin is great. Here we look at some prompting techniques. We found out that these techniques are generally helpful, but their applicability to a specialized domain require further exploration. Activation fine-tuning improved performance the most among all the strategies that we looked to. For OPT 175 billion, this approach improved the macro F1 score of zero-shot baseline by 35 and 47 point of F1 score for ECtHR and SCOTUS. And as the future steps, we would like to explore first some instruction-tuned LLMs like OPT IML, and also to consider more advanced approaches. We would like to experiment with parameter efficient fine-tuning methods and compare them with the just simple prompting techniques. And also we would like to ask whether current LLMs exhibit notable bias in their legal decision with respect to protected groups. And thank you. And if you have any question.
Okay, let's move to the last talk of the first part of this session. We have Reha with us. And the title is A Comprehensive Evaluation of Large Language Models on Legal Judgment Prediction. And then I'm going to have a brief joint QA.
Okay. Hi, everyone. I am Shui Hao. I'm from National University of Singapore. I'm very glad to present our paper of the EMNLP findings that we evaluate the several large language models on the task of legal judgment prediction. So first, I will give a very brief introduction. So we all know that the large language models have achieved great success. So we wonder how them perform in legal tasks. So in the GPT-4's report, the GPT-4 was claimed to pass the UBE with a 90% with a 90 percentile score, but this result was pointed out to be overclaimed. So our motivation is to propose a new benchmark to measure the law competency of the large language models. And there are several issues of previous benchmark. First, the UBE is too general and it is not subject to any legal jurisdiction. And second, so some previous benchmarks like the HELM use the multi-choice questions, but the multi-choice questions is not very comprehensive enough. Some other benchmarks like the UBE use the open-ended questions, but it requires the human evaluation. So we hope to propose an automatic and transparent benchmark. And third, the similar cases are not fully studied in previous works. So to this end, we choose the legal judgment prediction as the example task because this task requires both the legal language and the legal reasoning ability. Then we design 4 settings to cover the open and multi-choice questions and the usage of similar cases. Specifically, we consider 2 work scenarios. The first is that the LLMs work alone. The second is that the LLMs coordinate with an RR system because currently the Retrieval-Augmented language model is very popular. Yeah, so we hope to see how the IR system can benefit the language model. Specifically, the IR system can provide some similar cases. So the cases can be used as the few short demonstrations, and it can also propose some label candidates. It's like the charge name options. So the label candidates convert the setting from the open question to the multi-choice multi-choice questions. Okay. In the following slides, I hope to highlight some key findings of our paper. So first, considering the different settings, we find that the label candidate or the similar cases contain some like complex domain knowledge, and the GPT-4 and ChatGPT can fully utilize this complex knowledge and gain much more performance. Yeah. But for the smaller models, they cannot gain much from the similar cases. And if we compare different models, we find that the models tuned by the instructions can achieve a high performance when there are when the prompts only include an instruction, like the Bloom-Z. But for the models tuned on the chat data, they can achieve a better performance when the charge names are provided, like ChatGPT and ChatGLM. Then we hope to understand the role of the label candidates and the similar cases. We find that the label candidates can improve the self-consistency of language models, which means that the language model can be more confident on their results because they can recall more domain knowledge. And for the similar cases, we do a validation study and use the fixed demonstrations for all queries. We find that the fixed demonstrations hardly benefit large language models. The reason can be that the large language models can understand the instruction well, so it do not need the fixed demonstrations to recognize the task. But the similar demonstration can contain rich domain information, and the LLM can learn a lot from similar cases. Yeah. Then we also raise a question that do language models gain a substantial improvement from IR systems? The intuitive is that like we can have a very strong IR system. The information retrieval can achieve a very high accuracy score, but if under that in that case, can LLM achieve substantial improvement? So the observation is that the IR system can sometimes outperform the IR enhanced language model. Yeah, the reason is that the language model may fail to fully utilize the informative retrieved documents. So this also raises the important future work, like how to enhance the synergy between the language model and the retrieved documents. Yeah, so and I think there are also some work on this topic, like the ritual, yeah, to make the model better utilize the high quality retrieval documents or like similar cases. Yeah. Okay, yeah, so this is all of my presentation. Thank you.
Cool. Thanks to all the speakers again. We can maybe have one or two brief questions because we're a bit behind. Is there anyone on Zoom online that wants to pose a question? Maybe you can open your mics and ask directly. Yeah. I don't see any questions online. There's some on the chat, maybe, yes. Let me check the chat. Is there anyone in the room that has any questions so we can move quickly? Okay. Take them on.
I'm just wondering, so can you say why you thought activation fine-tuning did so much better? You didn't really go into detail on why you thought that might be. Could it be a result of you only use two versions of one language model, or what do you think?
Is that directed to me? Could
Yes.
you repeat the question again? Sorry.
Sorry, just what is your opinion on why the activation fine-tuning did so much better than the other methods?
Yes, so the reason is that after just probing the generation of the OPT, we found that the OPT generation are not, they're not, so OPT is not aligned. So the generation are not of high quality. And most of the time, it's just going to add noise. It's just going to generate some noises. And we found that if we just rely on the internal component of the language model, the knowledge that is preserved in its hidden state, and then train something on top of it, it's just normally going to show a better performance and it's going to be more robust.
Okay, thank you.
Cool. And we have one more question on Zoom. It's for Vaiban for the very first paper. And the question, Vaiban, are you with us still?
Yes.
Cool. And the question is for the chain of thought prompts, were they changed with each domain, legal versus financial, or with the type of the question?
Yes, so we had two data sets. So we had two different prompts. And like for all the questions, we used the same prompt, but like we had one prompt for each data set. Yeah.
Okay, cool. So if we don't have any further questions, we have one question. Let me bring.
Hi, I have a question from the second speaker on the long legal documents. You mentioned that, okay, even though the data is pretty small for training the language model, but the language in the documents is pretty structured and patterned. Did you see any of that in the perplexity score of the model as it trains, for example, early saturation or other evidence that suggests this type of suggests that the model is picking up this structure in the text? I don't know if they are here still.
Okay, are the presenters still here? Probably the last, sorry. Cool. So let's move to the second part of this session. We have 6 papers that are presenting new data sets that we all use in our work. And I will just go straight to Joel for the first paper. It's called Scale, Scaling Up the Complexity for Advanced Language Model Evaluation.
Thank you. Hi, everyone. Happy to present Scale. The motivation for this work is that code view generation and long document-to-document information retrieval tasks are very hard and scarce, and multilingual corpora from the same jurisdictions are also very rare. So that's what we try to fix with Scale. We introduce very hard tasks, in our opinion, that are multilingual from the same jurisdiction. We also think that it's the first end-to-end benchmark for a judicial system, including 650,000 cases and 35,000 laws. So this is how we view Scale being used. So first we have law area prediction, routing a case to a specific department in a court. Then we have criticality prediction, helping to prioritize cases, information retrieval to help judges and clerk in their research, then court view generation, helping them with drafting, and then judgment prediction, helping with the decision or proposing a possible decision, and then again criticality prediction for determining which decisions are most important and will be cited most often, and then leading decision summarization, which helps summarizing existing decisions. All of this can be, all of these tasks can be supported by a large pre-training corpus of cases. So what makes it special? We have very long documents, up to 50,000 tokens. We have domain-specific knowledge in the legal text, multilingual understanding with 5 languages, and multitasking with 4 task categories. So let's look a bit in more detail towards the criticality prediction task. So as input, we have the facts of a federal case, and we want to predict the importance to be able to prioritize most important cases. Then next, let's look at information retrieval task, where we have again the input, the facts of a case, and then we want to predict relevant case law or legislation which could help in legal research. And then the court view generation task, which we see as giving input the facts, relevant legislation and case law, and maybe even a lower court decision. And the output would be legal reasoning that could be generated by a language model to help in drafting decisions. This is very hard in our opinion, exemplified by the average age of appointment at the Swiss Supreme Court, which is 50 years. Then the relevant legislation, case law, and analysis are multilingual, and the input size can be enormous, well over 100,000 tokens. Even the output size is very large, with an average of around 4,500 tokens, but can reach up to 50,000. Last, let's look at leading decision summarization, where we have the full text of a leading decision, and we want to produce a summary, which has 3 main parts in Switzerland, which is the main articles that are important. Then we have keywords from a thesaurus, and then finally the main theme in text form. Yeah, this can make case law more accessible and easy to parse for lawyers. So to conclude, we created a multilingual benchmark from the same jurisdiction with 8 classification tasks, 2 generation, 1 information retrieval, and 1 token classification task. The models that we tested struggle greatly. Please refer to the paper for more details there. We release every data set on Hugging Face for you to use. I really hope it can be helpful. Yeah, we tested models without retrieved case law and legislation. This could be tested in future work. Thank you.
Cool, thanks. Now we'll have a presentation from Biaoyan again. We saw again his previous conversation with the judiciary. We have the dataset description and presentation. The paper is called Super-SCOTUS, a multi-source dataset for the Supreme Court of the US.
Yes, sir. Cool. Hi everyone, thanks for being here. My name is Biaoyan Fang, and today I'm going to present our paper Super-SCOTUS, a multi-source dataset for the Supreme Court of the US. And first, I would like to introduce a brief concept of the Supreme Court, which we also call it scopes. It is the highest court in the federal judiciary of the United States, and briefly, the case decision procedure can be broken down into multiple steps. First, we will have the case submissions from the petitioners, and the other case will enter the surplus, and the case will be selected by the justice and to be here. And then we will have the oral arguments in the courtrooms, and after this, and all the justices will sit together and talk about the case. And finally, the legal system will issue the outputs. And from this pipeline, we can see that there's a variety of procedures and a lot of related documents are involved in the case decisions. However, in the legal and in the NLP domains, and there's no existing work contacting those varieties called documents of the Supreme Court of the US. And in light of this, and we created our Super-SCOTUS dataset, and we tried to collect and connect in various core documents from the Supreme Court of the US. And we present a case study and showcasing the importances of considering various court documents for the analysis of the court. So for the creation of the super scope, and we roughly break it down into 3 stages. And the first is prior hearing, and we have various documents such as search rows, and we have the brief from the petitioner respondents. And the second stage is the cause hearing, and we have the oral arguments from the justice, advocates, and amicus curiae. And the last stage will be the post-hearing, and we have the information from the opinion syllabus and other summaries from other annotation platforms. And across all, there's a lot of case information, which is the Supreme Court's database. And for our data set, we included all the resources in the blue rectangulars here, and mostly in the cause hearing and post-hearing phase. And for the case studies, and we asked the research questions, how do cause material reflect the decisions of a case? And so for the case decision, and it's a label, we obtained it from the Supreme Court database, and it have 2 labels. It's a binary task, and it will be predicting the case if it's a conservative or the liberal, and the label is decided by the voting outcome and the case issue area. For example, if it's under the issue areas of the criminal procedures, and a liberal label could be indicating the case outcome is pro civil liberties or pro underdog, and it's vice versa for conservative. And for the data set, we use two types of court documents, and since we investigating different court documents from different phase, and we have the oral arguments from the cause hearing phase, and we have the syllabus from the post hearing phase. And here is our primary experiments, and for the baseline, we use the randoms and majorities, and for all the other models, we consider the statistic machine learning base, which is linear regression and support vector machine. And we use unigram TF-IDF features for these 2 methods. And we also have birds with 2 settings. One is with the first 512 tokens, and another one is using the last 512 tokens. And we also have the legal birds. And overall, we can see that the model performs better compared to the baseline. And interesting, the bird model actually outperformed in the legal birds. And we might subject that because the oral arguments and syllabus are more in a general domains, and you might not really need a lot of legal knowledge to understand the documents. And also compared to the oral arguments, and the model performance better when the input is from the syllabus. And for in the scopes of fairness and bias, and we further investigating the good disparities of the model performance. And more specifically, we look into 3 attributes. One is the issue area, another one is the winning side, and the last one is the voting distribution, which means that the voting agreement based on their majority votings. And so we can see that the group performance varies, and especially in the group of the issue areas, which is the first one, and the voting distribution, which will be the last one. But interestingly, for the voting distribution, the syllabus-based models perform better when the voting patterns become more disparate, which means that they tend to have less agreements here. And we can also see that compared to the oral arguments compared to the performance with the oral argument as an input syllabus, the model with the syllabus inputs to achieve better performance, and we show that the different information are encoded in the different course documents. And so for the takeaways, and we created a Super-SCOTUS dataset, and we make it publicly available, and we presented a case study showcasing that it's really important to consider different variety resources to analyze the Supreme Court of the US. And thank you for listening.
Cool. Thanks, Marianne. We move again to the next talk. Is Joel again. He will present a MultiLegalPile, 689 gigabytes multilingual legal corpus.
Hi again, happy to present MultiLegalPile. So why did we do this? Large language models need huge amounts of pre-training data. Most corpora are English only and predominantly based on web crawls. So high quality multilingual domain specific corpora are rare. And that's what we do with MultiLegalPile. So MultiLegalPile consists of 4 parts: EURLEX resources from the EURLEX database in 24 languages. Then the native MultiLegalPile, where we scraped national case law and legislation in 14 EU languages. Legal MC4, where we filtered web crawl data sets with legal citations in 24 EU languages. And then we integrated the pile of law, which consists of diverse legal text from the US. So here you can see the distribution across text types. We see that case law is by far the largest portion. Across languages, this is a log-scaled y-axis. So we still see that most of the data is in English, but in comparison to other data sets, we have a lot of multilingual data as well here. So this data set, we can cover 2 times more total speakers in the world and 4 times more native speakers. Then we went on to train multilingual and monolingual legal models on this data. For 1 million steps, the base model sizes and the large model sizes for 500,000 steps. And we evaluated them on the multilingual benchmark LEXTREME, and finding that our models outperform even the largest XLMR model. The long-former model that we trained even outperforms the short context models, especially in the single label text classification tasks. We see that in some tasks, these are named entity recognition tasks, other models are better still. We also evaluate across languages, and we find that on aggregate, we don't outperform the base models, even though we come close. Interestingly, the monolingual models are very good in some languages. So as a takeaway here, it might be already very good to just continue pre-training a little bit for your language monolingually. We also evaluated on LexGlue, the English models that we pre-trained and the multilingual ones, and we see that the large English model sets a new state of the art on LexGlue. In some tasks, we still underperform, for example, the LETCAR and the unfair terms of service tasks. To conclude, we created a large pre-training corpus multilingually. We pre-trained 2 multilingual models and 24 monolingual models, and set new state-of-the-art on LEXTREME and LexGlue. Again, we release all data sets on Hugging Face. In the future, we would like to pre-train large generative models on this data set to see in how this can improve these models there. Thank you.
Thanks, Joel, again. And now we'll move to the next talk. Do we have Claire with us? No. Yeah, AsyLex, yeah. So you're Mark. Okay, we have Mark with us. Perfect. So it's AsyLex, a dataset for legal language processing of refugee claims. Everything is working.
Yes. Yeah. So hi everyone. I'm not Claire. My name is Mark Kleisonen. I'm a PhD candidate at the University of Edinburgh in Scotland, and I'll present our work on AsyLex, a data set of refugee claims that we created as a benchmark for legal language processing. So refugee claims are usually within the boundaries of international refugee law, but here specifically for AsyLex, our data set, we focus on Canadian cases. So the Canadian Legal Information Institute, CanLI, provides documents related to the refugee status determination cases as PDFs online, making them publicly available. And those RSD cases are a result or output from hearings and discussions from the Immigration and Refugee Board of Canada. Here on the right side, I brought a distribution of those cases ranging from 1996 to 2022, so totaling 60,000 RSD cases, constituting our data set AsyLex. So what do those documents look like? We distinguish individual RSD documents in 3 different parts: the main text, the case cover, and the case outcome. And you can think of the main text as the main document body, including all the information and details concerning the case. The case cover is usually the first page of the document in semi-structured format, sometimes tabular format, comprising details such as where did the hearing take place, when did it take place, who's the judge, and personal information and details concerning the applicants. And also the case outcome, which is a binary decision outcome, whether a case has been accepted or rejected. So we discussed with legal practitioners what could be of interest to extract in terms of labels, and we came up with those. And then finally decided to do human annotations for those RSD cases, gathering those numbers of labels for those different parts, main text, case cover, and case outcome, highlighted here in yellow, which we refer to as our gold standard annotations. And as I mentioned before, the case cover is semi-structured, sometimes similar to tabular data, which makes it perfect for rule-based extraction, which we do with regular expressions, generating more annotations and labels here. We then fine-tune a legal BERT model on our gold standard annotations, inferring further labels, which we call silver standard annotations here, highlighted in yellow, the number of generated inferred labels. What do those documents actually look like? I brought an example here on the left side. So that's the first page of such an RSD document. The case cover, highlighted in yellow, the different labels that we extract. And overall for our data set on the bottom right, the table, showing all the different labels that we are interested. So for example, date of hearing, the date of the decision, was it a private or public hearing? Was it virtual? So for example, during COVID, or was it an in-person meeting? Also judge name, etc. The top right shows the conclusion or the decision outcome. So here marked in green as determination whether the case has been accepted or rejected by the judge. So in our paper, we present two tasks, legal entity extraction and judgment outcome classification. But we think that our benchmark is a first step, having lots of opportunities for like further up research and follow-up papers. So generally speaking, for the NLP community, we think of more legal entity extraction using NER models, also case and bias analysis. But more specifically for legal practitioners, we've received quite early feedback from them that this would have like opportunities to enhance case review and also legal search. And maybe as another example from the applicant side or for like the lawyers, generating more insights for new applications. So we make all our data and models available on Hugging Face, so please come find these. And happy to take any questions later. Thank you.
Thanks, Mark. Really interesting data set. And now we'll move to Joel again. He will present to us LEXTREME, a multilingual and multitask benchmark for the legal domain.
Hello. Happy to present LEXTREME, multilingual and multitask benchmark for the legal domain. So most benchmarks are English only and often for the newspaper or Wikipedia data. So multilingual and domain-specific benchmarks are still rare. As you know, language models made huge progress in recent years, saturating many benchmarks. So we argue that more difficult benchmarks are needed now. And we argue that LEXTREME could be one of those, because it's multilingual, multitask, and domain-specific for legal data. So why is reasoning over legal text difficult? As you all know it's very complicated with the legalese language, very long often. Legal knowledge is required, and it can be different in each jurisdiction, not like computer science or medicine, which is more universal. Some statistics about our data set that we aggregated. So we have many multilingual data sets, as you see here, covering many languages. We also have some data sets that contain very large label sets, which make them more difficult. To show you a few examples, we have the online terms of service dataset integrated, where you need to predict if a certain sentence is clearly fair, potentially unfair, or clearly unfair. And also the COVID-19 emergency event task, where you need to predict from British legislation the COVID-19 emergency events. We evaluated 5 multilingual language models. They're all encoder-based. We also evaluated ChatGPT, but the ChatGPT underperformed always. They're all covering 100 languages, and yeah, are all multilingual. So how do we aggregate results on the benchmark? We want to maximize fairness across languages and data sets. So that's why we use the F1 score everywhere, so we can make it comparable everywhere. We use the macro-averaged F1 scores. So we have robustness across classes, because many data label sets are imbalanced. And then we take the successive harmonic mean over the F1 scores, because also the F1 scores uses the harmonic mean. This brings more weight to the smaller values, promoting fairness. So to see the results over the data sets, we aggregate first over the languages in the tasks, and then over the tasks in the data set. And we see that, as usual, the larger models are better, with some exceptions. When we aggregate over the languages, we first aggregate over the tasks in the data sets, and then over the data sets in the languages. Again, we see that the largest model gets the largest performance, but here we see that the XLMR base model is worse than the MD-BERTA model. We see that in some languages, the native BERTs outperform even the multilingual models. Then we aggregate all of the data set aggregate score and the language aggregate score to produce a final score, and we see a quite normal line where we see the larger models performing better, with MD-BERTA base and XLMR base, one performing better across the data sets and one better across languages. To conclude, we selected 11 out of 108 surveyed dataset to create the first multilingual legal benchmark, and we established a point of reference with 5 multilingual models on LEXTREME. The benchmark is available on Hugging Face, and we invite you to check it out. In the future, we would like to extend it to cover generative tasks as well, and also extend to cover more languages. Thank you.
Thanks, Joel, again. And I think you're going to also do the last presentation for ECtHR for your work with. No, we didn't do it. So if you want to do it now, you want to do it?
Go ahead.
Okay, perfect.
We can do it after.
Yeah. If you want, yes, sure. Can do it later. Okay, let's then close with a joint QA session for all the dataset papers. Are there any questions from the room? I don't know if there are any questions online. Maybe I can ask a question for starters. I have a question for the AsyLex paper for the refugee claims. And I wanted to know if you have any sort of metadata related to what sort of conflicts, for example, we had at any given point of time. So for example, in my understanding, the status of claiming asylum in a country is much affected by what sort of conflicts we have around the world. So different ethnicities or different groups may be affected differently. So maybe at some point you are a perfect candidate to take asylum, and maybe in some other case you are not eligible to take. So I want to know if you have any sort of information about this in your data set to somehow combine this information and make it easier to say, okay, this person is from this country, so in this time period when this decision was taken, it made sense to give us asylum, while 5 years later, maybe it wasn't the case.
Hi, I'm Claire. So it's international refugee law, so there are the rules are the same everywhere in the world. In terms of can we know in time who should be granted or not asylum, we have the dates of the hearing and the decisions, and we have so usually in the cases they do cite something like NGO reports for a specific country or for a specific geographical area in time. So it's like the report for the Middle East in 2020, for example. So based on that, you can infer some information, but you would have to go back to the NGO report.
Nice. Any other question from the room? The data sets? I don't see anything. Okay, so maybe we can close the session pretty early, and we can all go for lunch and an poster session. I think the poster session is in East Foyer. What's the name of the area?
Yeah, we're checking where lunch will be delivered. Probably it will be where the posters are, which is in the East Foyer, so next to the registration. And the idea is to have lunch and see the posters, whoever wants to set up the posters. Yeah, I think Daniel wanted to confirm that indeed that's where lunch would be delivered. So yeah, but it's still 10 minutes, so we're 10 minutes ahead for some weird reason. So yeah, lunch and posters are gonna be in the posters area, which is in the East Foyer next to the registration, and we're back at 2 p.m.
Okay, so we'll be back at 2 with our keynote talk and then some more sessions with our presentations.
So we'll start in 2 minutes. Meanwhile, we'll have first the keynote by Gerald, who is already ready. And then the next session, which is going to start right after the keynote. So I would kindly ask the presenters to be ready so that we have no delays. So if you're presenting the session afterwards, just be on alert so that we can properly start. So wait 1 more minute and then we'll start. Okay, so we'll start. So as if you have been a friend of the workshop for some time, you know that the keynote is always given by somebody from the legal domain, so as to trigger us a bit and stimulate a bit our work, and have somebody from the legal domain to tell us what we should be doing. So it is our pleasure this year to introduce Gerald Shaw, who is an assistant professor of law, also the deputy director of the Center for Computational Law here in Singapore. And yeah, his title is, the presentation is NLP in the legal world. So without further ado, the floor is yours. We are all eager to hear what you're going to tell us.
Right, thanks very much, Jerry, and I will try my best to trigger and stimulate this crowd. So good afternoon, and for our friends who have flown here, a very warm welcome to Singapore. It's really a great honor to speak here, especially at a time when most people are willing to pay good money to speak with anyone who knows how ChatGPT works, or even a Q-star. You know, I thank the organizers for the invitation and really for consistently organizing this workshop series. As I will touch on in this talk, these interdisciplinary conversations are really, really important and need to continue. So to quickly introduce myself, I've been at SMU, the School of Law, since 2018. That was around the same year I graduated from the NUS Law and Economics program, and I've then studied and focus on the regulation as well as the use of AI systems in the law. All right. And on the regulation end, I've been working with colleagues at at our Center for AI and Data Governance on several issues. I've put some selected works here. And on the use angle, as Jerry has introduced, I work with a pretty interdisciplinary team at the Center for Computational Law. There are about 12 people and only 2 lawyers, including myself. The rest are computer scientists, logicians, mathematicians. So I raised this just to highlight and to caveat, as lawyers always do, that I'm not formally qualified in computer science. So I might get some of this stuff wrong. The talk will be a bit less technical and more of a position piece, sharing some experiences working on technology from out of a Singapore law school, right? So the title of the talk is NLP in the legal world. And it's actually inspired by a paper published in 2010 by a legal and moral philosopher by the name of Joseph Raz. Now, Raz and his PhD supervisor, H.L.A. Hart, were 2 of the most prominent legal positivists. And what the positivists argued, if I could oversimplify a little bit, were that rules became laws simply because they had gone through some kind of positive recognition process. For example, being passed by Parliament in Singapore. It didn't necessarily have anything to do with the inherent nature of the rule, right? Whether it is immoral or even downright evil, law is a law if Parliament says it is a law. Now, there are interesting parallels here, I think, to what passes for AGI nowadays, but I will leave that aside for the moment. In this paper, Raz tried to challenge the conventional notions of what it means to be responsible for something, and the principles conventionally held people responsible, mostly for things you either intended or controlled. Instead of this conventional view, he argued that we hold ourselves responsible and also others responsible for conduct that falls within what he called a domain of secure competence. And these he defined as domains which we ourselves are confident that if we set ourselves to do something, we will actually do it, we will achieve that. Barring certain competence-defeating events that may cause but also excuse failure. Now, this sounds a bit philosophical and abstract, so let me give an example. I regard the writing of law journal articles as something within my domain of secure competence. I set myself to do it. For various reasons this year, I haven't produced as many as I would have liked. Now, I neither intended nor controlled this, but my employer very much wants to hold me responsible. But although I would try to argue that it's all because of certain competence-defeating events. Now, why do I raise this? It's because we now live in a time where AI's domain of secure competence is expanding, especially for NLP systems, right? And that also means that the range of what AI and NLP researchers are and should be confident of doing if they set themselves to it has expanded. If Joseph Rez is right, that means that society and we ourselves should be held responsible, we'll hold ourselves responsible for many more things, including things that might be outside of the intended or controllable users of the AI system. And in this light, so in this talk, I would want to centrally suggest one thing, which is that for NLP to succeed in the legal world, and pardon the typo over there, it has to undergo, and in many ways is already undergoing, an important transformation. It's a transformative process that, for lack of a better word, I will call it growing up. And I do mean this in the most neutral way possible. I'm not trying to imply that anyone here is childish or childlike or immature. What I do mean is that until relatively recently, NLP systems were not in prominent use anywhere in the law, or perhaps even the larger consumer-facing world. They're all behind the scenes. But in this brave new world of, ChatGPT, where you have widespread legal consumer adoption, including in the law, where, as I heard somebody put it, every second sentence that's uttered today contains the word ChatGPT. Every third sentence is written by ChatGPT. It's a different world, and I would say very quickly that the field will be pressured, strongly encouraged to develop a new set of theories, practices, standards for handling all these newfound applications. How do you deal with that? Is the question. And this is especially true because we're now talking about entering domains like medicine, like law, like finance. And these are domains that deal with nothing less than life, liberty, and particularly important in Singapore, the pursuit of money in finance. So in this talk, I'll try to highlight three ways that I see the field as in the process of growing up. New attitudes, new consequences, and new responsibilities. I'm not, as I said earlier, I'm not a computer scientist. I've worked with many of them. I would just try to offer one law professor's view of what this is all about, what this all means, contextualized, I hope, with some real-world examples, particularly but not limited to Singapore's case. Right. So it's I would say that it's not quite the structure from the abstract that you've been given. I promise that the content is in there. The flow I just reorganized a little bit, and just as an excuse, given that recent events suggest company can change CEOs 3 times in 5 days, I think we should all get a free pass for adapting to change. So growing up, part 1, new attitudes. What does that mean? Well, the first aspect of growing up is really recognizing that one is becoming an adult and being recognized as such. In the law of Singapore, adulthood is actually defined using a few numbers. The age of consent is 16. You need to be 18 years old to get a full-time employment contract, to buy alcohol and tobacco, and to marry with your parents' consent. Once you're 21, you can do so without your parents' consent. But a lot like precision recall or F1 scores, actually age is just a number sometimes. Growing old is physically compulsory. Growing up is mentally quite optional. Some people never go through that process. It is a lot about carrying yourself and being seen by others as an adult. So what does that mean for the field of NLP or legal NLP, and how has it matured along these lines? Well, the most prominent sign of the field's coming of age is really probably the now, as you're aware, incessant buzz around LLMs. So the adults all want to talk about them. You see on screen here the recent UK AI Safety Summit. I'm sure people are aware of this, all the important people there. Today, there are daily conversations being had about LLMs by people who I would very much assume, or at least hope, are grown-ups. I'm referring, of course, to lawyers, regulators, policymakers, who, more than any other demographic, and trust me on this, they tend to take everything too seriously. AI and NLP researchers are getting invited into to contribute to regulatory roundtables, to speak in, to comment on legal reports or proposals, to give workshops on how all this stuff works, or even summoned to congressional hearings. To put it metaphorically, really the field has now a seat at the adult table. What does this all mean? Further evidence of legal NLP's maturity can be seen in how lawyers are not just talking about regulating these systems. They're actually talking about using them. Right? I'll come back to regulation later, but importantly, they're talking about using them. I'll highlight some examples. There is a project recently announced where the Singapore Supreme Court has started a pilot with the American legal AI company Harvey. I'm sure you're aware of what Harvey is. I won't go into that. There's other projects going on. The Chief Technology and Innovation Officer of the Supreme Court, which I speak to quite often, has tried building his own Retrieval-Augmented Legal LLMs for Singapore. He was very excited about some parts of it and not so excited about the other parts. About 2 weeks ago, I was at a dinner where the Chief Justice of Singapore announced that one of the largest case law providers in Singapore, called LawNet, which is government-owned, is building a LLM summarization tool. And we're working on some of the RLHF reinforcement learning processes on that. Of course, outside of Singapore, I've already referenced this, the UK Summit on AI. This is the Bletchley Declaration. It's been signed by 29 companies, including Singapore, China, US, the UK as well, many other important ones. One of the interesting sentences, as you'll see here, is that AI systems are already being deployed in many domains of daily life, including justice, right? And the use is likely to increase. Right? This is not a simple statement. It's a bigger deal than it sounds. Why is that so? Well, as some of the longer suffering members of the AI and law community who might be in the room will attest, researchers have been thinking about legal AI systems for as long as they've been thinking about AI systems. If you want, you can trace this all the way back to the original Leibniz, who was both a lawyer and a mathematician, who said, let's have a universal logical language who can, if we reduce all the rights and obligations of law to a calculus, then we can calculate and see who is right. If you want to trace it back as well, there's famous text Leviathan. It's a key text in legal philosophy about the role of the state. But he also took the trouble to talk about artificial intelligence, right? Artificial springs and basically automata. So despite decades and decades and decades of predictions, that AI is disrupting law, and some experts in this field have been predicting this for a long time now. You'll see on the screen Professor Richard Susskind, who since the 80s had published a groundbreaking PhD on legal expert systems. And the ICAL conference, the first ICAL conference was in 1987. So it's been a while, right? But it hasn't really happened yet. It hasn't really happened yet. Lawyers have consistently been very dismissive of any notion that computers could ever handle the nuances and complexities of legal language. A lot of that skepticism still exists, or as my colleague, the computer scientist Ming likes to say, they will tell you that computers can never handle law cases because every case is different. You can't reduce them to statistics and algorithms. And then you ask them, oh, but why should I hire you for my case? And they'll tell you, oh, simple. I've done tons of cases just like yours, right? So I joke, but the lawyers had a point. Until quite recently, commercially available NLP systems weren't all that great, if I may be honest, right? Chatbots couldn't string sentences together. They got caught in linguistic loops. They struggled with co-referencing. And in law, even simpler things like sentence tokenization wasn't really quite solved. There was I recall a talk in the 2019 workshop just on this point. So we weren't worried about higher order problems or first world problems like racism and bias, because it was a challenge just to even get something to work. Who cared about whether the system worked well or even fairly? So there was this so-called legal language barrier that scholars in the space have been talking about for years, or the idea that law has been so far insulated from technological transformation because it trades mostly in natural language, not some kind of computable numbers or data. So while most other professions, medicine, accounting, economics, psychology, they've all took a kind of empirical turn, law hasn't really gone through that quite yet. So even up to about 5 or 6 years ago, few lawyers took the AI hype seriously, even if about once every year you will see some news outlet feel the need to publish an annual reminder that, hey, AI is going to replace lawyers. Eventually, if we keep saying this every year, we'll get it right one time. In around 2017, this was just 6 years ago, I had co-founded a legal analytics startup with a few of my friends from law school, and our main and quite misguided goal was to try to sell analytics to lawyers. Selling software to lawyers is the toughest job, or used to be the toughest job in the world, if anyone has had that misfortune. In those days, even suggesting that a lawyer could use some kind of data analysis could net you a bit of a dirty look. I would give you one example. We had tried to convince somebody whose job involved determining sentences for criminals who were convicted. We had tried to convince them that maybe you could use some kind of a regression model to inform your decision. This was way before some of the new developments. So just as a statistical tool to inform what the past sentencing data was and to inform your current thinking on it. And the person smiled and said, hey, we already have that. I was like, okay, that's cool. I have not heard about Singapore courts using any kind of AI in those days. So that person then took out a histogram. It was this dashboard which produced many, many histograms of different crimes, and for every crime there's a histogram. And then that person said that, well, that this is it, right? I don't need a regression. Why do I need a regression? Because I can look at the histogram, and with enough data, everything becomes a bell curve. So I can just visualize the bell curve over the histogram, and it'll all be great. So I'm sure people understand what's wrong with that kind of thinking. I myself debated whether I should go into a seminar on the central limit theorem and its limits, but thankfully I had the wisdom to recognize a lost cause. So that was barely 5-6 years ago, at least from my personal experience. Right, and the situation today could not be more different. We went from a time when, why do we need ML systems if everything is a bell curve? That's, pretty extreme. But last year, our friends, the Khartoum and Daniel Katz presented this at Future Law, a conference at Stanford, where they were confident enough to say that, with GPT, with GPT-3 and 4, have we broken through this legal language barrier? The audience would know that, these things, 3.5, 3.4, perhaps not so much scientific advancements in the sense that what they really did was to hyperscale existing practices with lots of investor money. But I think they were, to be fair, significant technological advancements in the limited sense, at least, of managing somehow to become widely adopted in the real and legal world. And as more and more lawyers started to use LLMs, very observably, legal hearts and minds were swayed from people being shocked that I would even dare to mention AI. Now they get annoyed if I don't mention it. Hey, we got you to talk about AI. Can you talk about AI? Well, this may just be my selective Singaporean experience, but I have been constantly impressed over the past few months and past 1 year or so by how informed and some of the lawyers and regulators and policymakers are in this space. They know the latest trends. A legal report on generative AI that was published last month cited several papers in this field, Legal Bench, which people might know. And this is a regulator writing a paper and I told him, you could well be doing my job for me. Anyway, so they've clearly studied this. And of course, this might not be surprising for the Singaporeans in the room. You might know this. Singapore is still very much, I think, the only country in the world whose prime minister has degrees in computer science and mathematics from Cambridge, right? And it makes sense that everything, well, he understands the stuff, right? So this is not just Singapore, to be fair. The commentaries I've read from legal scholars, policymakers around the world have all become a lot more sophisticated, a lot more tech savvy, and really the highest praise that a lawyer can ever give to any field is to devote their time and attention to understanding it, especially if understanding that field requires doing math, right? It's really, really tough. So legal NLP is really growing up now, and we can see that that from the kinds of things it's been doing, people who take it seriously, and the rooms it now has access to, right? This shift has been really quite remarkable. You would know how quickly all this happened, right? It's only been about 14 years since ImageNet and the whole new wave of deep learning, big data sets, 10 years about there since word vectors, 6 years since the attention paper, 4 years since BERT, well, some would say 5, but was it an echo paper, and 1 year since ChatGPT. We were just about the 1 year birthday, right? So this is really exciting, but it also worries me in some way because there is such a thing that we call growing up too quickly. Right? There is such a risk. NLP for now might have earned the lawyers' attention, but it has some way to go, I think, if we want to earn their trust. Lawyers are professional skeptics. Law school is basically a 3 to 4 year course in identifying problems without offering solutions. We have a word for that. It's called to problematize, to make a problem of, right? And if Legal NLP really wants to establish itself as a trusted, reliable partner for delivering legal services, delivering justice, all the good stuff, I think the technology systems have to play within the rules, recognize that actions have consequences, and to take responsibility for some of these consequences. And I should quickly qualify that I'm not saying that it doesn't already do that. I'm just pointing out that this transformation is happening, and I think it should very much happen. So take, for instance, the now burgeoning field of AI ethics, right? Or you want to call it bias, fairness, trust, safety, responsibility. There are quite a few labels now. I've been reviewing for the FACCT conference, the Fairness, Accountability, Transparency, if I'm not wrong, conference last year, and the number of submissions it got was really quite interesting, surprising, up from about 0 10 years ago, because there wasn't such a conference. You will see a visualization here that I didn't make myself. It's from Arvind Narayanan, right? One of the known fairness researchers. And there are also all these AI trust and safety teams popping up, and to be fair, getting shut down around the world. As alluded to earlier, I see this as a first world problem because we only start worrying about this stuff, this higher order stuff, after we make systems that actually work and people actually use. Now, the heightened scrutiny around AI is really due, at least in part, to its expanding domain, right? Standard practices like scraping data or importing data sets from the internet without really checking what's in there. It could be acceptable if you're trying to distinguish chihuahuas from muffins, right? But maybe it's less acceptable if you're making something like this that could determine how long somebody spends in jail or how much of whether they get bail or not, right? As is probably well known by now, thanks to this Compus debacle, which I won't jump into too much. If the data set is fundamentally skewed or against certain races or demographics, and as a result, your model, your system is biased as well, it is no excuse to say, hey, but I followed standard practices. Everybody uses this data set. I didn't intend or control this. It is not an excuse. Tell that to the person who has to spend more time in jail because of it, right? In a book chapter, which will actually be published next week, it's a law book, so you don't really have to bother looking it up. I explored when and how legal duties for machine learning datasets could arise. Generally speaking, outside of specific legislation, there is a general law that we call the tort law, and the law holds people liable for any foreseeable harm that you carelessly cause, amongst other things, and the lawyers in the room would know. If you put out a data set or a model that's meant for cat detection, it's going to be a little bit of a stretch to say you probably foresee that if it was carelessly done or compiled, somebody's going to get hurt, right? Who's going to get hurt by a cat detector? Now, it's a bit different if you're talking about a model for a self-driving car to train human detection, right? If that system fails, somebody might get run over for medical diagnosis and, of course, for legal predictions. And even if it was not initially meant for these things, if you have a data set and it's wildly successful, we're very happy about that. It becomes a kind of foundation data set. We have foundation models and then there are canonical data sets. And people start using it for all sorts of things beyond your initial intentions. And you learn about that. Maybe you have a duty, an obligation to refine it in some way and to check, and to go back. And this was essentially what happened with ImageNet, as some people might know. And this could also happen with any of the corpora that are standard currently in NLP. So now one might be thinking, well, ImageNet is actually quite small, right, by today's standards. In NLP, we're working with planetary scale data sets. The common crawl is the whole known internet, plus a bit more. How am I supposed to check all of that stuff? Well, the quick answer is you don't really have to, right? This is not the point. Let's consider how the other professions do these things. Accountants sample. They don't read all of the company's documents to try to find financial irregularities. Lawyers in an evidence discovery process or a due diligence process, they don't read everything either, right? Some lawyers try very hard to do so because they are paid by the hour, but that's a separate point. But they don't do everything. And you think about the food industry, right? The food industry mass produces millions of tons of products that people eat every day. If something goes wrong, people are going to get seriously ill. I don't think they check everything as well. They don't check every single chicken or nugget that goes in and out of their factories. Right? What we do is we have a publicly transparent and trusted process led by the federal administrations, led by the food and drug authorities, and people just sometimes misplaced trust in those processes, but it kind of works. So all these rigorous ways to sample, and to be sure, sampling isn't perfect. We've had massive accounting scandals, massive legal and food scandals as well, right? But the goal is not to be perfect. The goal is just, the obligation is not to catch every single thing. The obligation is really just to take precautions to an economists would call this efficient level. You do a cost-benefit analysis. How costly is the precaution? How much is the expected harm? And you take a reasonable amount that is roughly determined by this broad rule. So all of the grown-up industries have this. Why should AI be any different? To quote last week, Professor John Norton, who has a pretty interesting title of Professor of Public Understanding of Technology. He published an op-ed in The Guardian on the ill-fated EU AI Act, which I will actually come back to. And he wrote that foundation models are like building a new system for drinking water. And there are all these giant reservoirs that the foundation models represent. And we have a vital interest in knowing how is the water filtered? How is the water purified, enhanced? What's going in there? Currently, we don't. At least not for all the models, right? Some of them we do. Of course, software companies have a strong tradition of quality assurance and testing. I'm not trying to shortchange everyone here. With formal verification, with formal methods, code review, rockets have been landed on the moon with software. Could not have been done without software. But the funny thing about data science or data work is sometimes I feel like I get to throw every good software practice out of the window. I'm copying and pasting cells, right? I have everything in one notebook, a huge file, and I collapse them with markdown headers. When it comes to machine learning, you have a few things that I think would make computer science professors very triggered, right? No provable correctness. It works 80% of the time. We don't know which 20% of the time it will fail. You can't trace the program or perfectly predict behavior. You run the same code, you get different models. You run the same model, you get different outputs from the same inputs. Right? This is not traditional computer science. I'm not saying it's worse or better. I'm just saying it's different. And it sometimes feels like, while conventional software development workflows are built to be agile, AI workflows are built to be fragile. But yet the traceability and explainability are really, really important in the law, because the law is only half about the outcomes that people like to predict and so on. The other half is about reasons and accountability. Right? Assume that we have this perfectly accurate but completely opaque legal outcome predictor. We know, to the extent that it can be known, that the model is 100% accurate. Every single holdout test set, future test set that we put it to, it has gotten 100% F1 score, perfect score. The catch is that it's a complete black box, doesn't give you anything. At the most, we know that it is some kind of transformer, as usual. Now the system has predicted in a drug trafficking case, and you know that this is serious in Singapore, if not in many other countries. It's predicted that the accused person will be found guilty. What use would this prediction be to lawyers and judges? How would they use this? Well, the judge might be willing to take the prediction into account, but still they would have to invent or come up with or think of reasons why this should be done, right? And so must the lawyer. If the lawyer is going to the client, the lawyer has to tell them, okay, you're probably going to jail. Or if you traffic too much drugs in Singapore, you might be sentenced to capital punishment, right? To death. The first thing the client is going to ask, and the family is going to ask, well, why? Why is this the case? And you cannot say, right? You cannot say, well, because the algorithm said so. And the algorithm has always been right. George Orwell could have written this, right? And you can't also say, well, because guilty is the most probable continuation of the prompt that enter into the system based on the training data, which is on the whole internet. And there are some proprietary data sets that's been created by people, paid $2 an hour to review these things, and that's the most probable continuation. Well, that's not going to work as well. Firstly, the client will be wondering, what on earth are you talking about? So what's the whole point of all this? I wouldn't be surprised if even if you had a perfectly accurate system, but it couldn't give any reasons, lawyers would just not want to use this because it wouldn't be useful in the legal world, right? So how do you work around these things and build traceability, accountability, and so on? Wrapping its head around all these new and possibly severe consequences will be another key challenge for legal NLP systems in its process of growing up. I can very much understand the pain of all these ethics and compliance checklists. There's a reason why lawyers are not the favorite people in the room. You know, you have barely making a conference deadline, behind on sleep, you want to submit the paper and hang on, fill in this model card, right? No. So I'm just suggesting that some of this is important. I don't know if form filling exercises and checklists are really the best way to do this, to encourage real engagement with ethics and fairness and responsibility. But it is one way of one step forward. So my next point is probably the only future-looking prediction that I will make in this talk. And it's this: over the next 5 to 10 years, there will be more new responsibilities for this field. By that, I mean that the amount of laws, regulations, governance principles, all this stuff that will be invented and applied to AI and NLP systems will skyrocket. And I know this, and I'm confident of saying this, because every major jurisdiction that I know of has either passed, proposed, or is in the process of thinking about drafting some kind of regulation for AI. I have very major concerns on some of the proposals, which I think are quite unworkable. But this is happening, right? And if you thought the GDPR was earth-shattering and very annoying, which it is, and it's actually created an entire new set of industries around privacy, data protection officers. It's a huge industry created just by essentially new laws, right? And entire careers have been built commenting on it. Well, if you thought that was earth-shattering, then AI regulation, I expect, will be even more tectonic. And it will actually be pretty messy, unfortunately. It looks to be the case. On the screen, you'll see the current vice chairman of Microsoft, Brad Smith. There was, at a workshop that my law school, and I helped organize it in July this year, a video was played where he shared one insight which I thought was quite worth sharing here, which is that in most cases in the past, the major industries like finance, oil and gas, what have you, they grew big domestically, they got regulated domestically, and then they went international. Now with tech, partly because of its international nature, right, it has gone big internationally before any kind of domestic regulation. And this is a fundamentally different kind of set of events. My own takeaway from this is that regulators are basically now playing catch up, while at the same time grappling with a far more complex, multinational, and unfortunately politicized industry than they are used to. And if there's one thing I would say is that rush legislation is seldom good legislation, however you define what good means. Imagine, in the words, in the idea of growing up, that you've just turned 21, and the next day someone hands you a 20,000 page rule book on everything you need to comply with as an adult. And that rule book was mostly written by GPT-4. Here's what that rule book could look like, right? The first part will contain all of the existing laws: data security, cybersecurity, electronic transmissions, communications, decency, whatever, that software has always had to comply with, theoretically. But up till recently, there wasn't much of an appetite to enforce these things. Software companies got off pretty lightly, if you ask me. That's just the first part. The second part is a patchwork of new laws drafted for new problems, with recommendation engines, fake news, deepfakes. Give you some examples here. In about, where is this? In about 2019, Singapore, my country, made headlines around the world by passing this act, the Protection from Online Falsehoods and Manipulation Act, or POFMA, as we call it here. It empowered the government to direct content creators on the internet as well as platforms to attach correction notices to what it defines as deliberate online falsehoods. And those three words are chosen very carefully. In more extreme cases, it could even direct the ISPs to block IP access to those contents within Singapore. Around this time last year, we also passed a new Online Safety Act, which allows the government to issue directions to online platforms, trying to regulate what is defined as egregious contents, for instance, materials about self-harm, terrorism, child pornography, and extreme violence. Right? China has passed, amongst other things, a specific legislation that targets recommender systems. Before people, and you'll see them here, this is an unofficial translation. And before people start chalking this up to some kind of authoritarian or socialist government thing, let me just point out that the UK has also, 2 months ago, published its Online Safety Act. And this has 286 pages. Singapore's act has 40 pages, right? The EU's Digital Services Act, which is targeting also online intermediaries and platforms, comes into effect next February, 2 months from now. Last month, a few researchers in the EU, Zenner and colleagues, published what they called a dataset of EU legislation in the digital sector. You can't see what's here. The phone is tiny because there's too many things. Every cell in this heat map looking thing is one piece of legislation in the EU, right? I was surprised by the number myself. Thankfully, not all of these have direct relevance to legal NLP researchers. Some will shape industry practices, which then shape academic practices. But importantly, there have been several laws targeting AI systems specifically. And this is where there are some provisions that I would be quite concerned about working in this space as well. This is part 3 of the new rulebook, and it's the fastest growing part of the rulebook. The most famous or infamous of this is something I've already mentioned, the AI Act of the EU. It was first proposed in April 2022. It has gone through a lot of revisions. No one knows what final form it will take. Literally, they are discussing and talking about this now. We are expecting a press release in a few hours' time on the latest update, the trilogues. And what the Act does, at least based on the original proposal, it outright prohibits some unacceptable uses of AI, which it deems unacceptable. For example, social scoring, manipulation, subliminal, I think they use subliminal messaging or something like that. It's a bit strange. But more importantly, there are also other applications that are deemed to be high risk. This includes the use of AI in law enforcement, some types of use cases, not all. And quite importantly, for the purposes of this workshop, AI systems intended to assist a judicial authority in researching and interpreting facts and the law, in applying the law to a concrete set of facts. So this is a high-risk system. And how that, it's not that it's illegal, you can still build a high-risk system, but anyone who is a provider of a high-risk system, and a provider is a person who places it on the market or puts it into service in the EU, even if it's for free, it's expressly there. If it's a high-risk system and you're a provider, there are all these obligations. I'll highlight one of them. Article 10 of the proposal says, datasets that are used to build high-risk systems must be relevant, representative, free of errors, and complete. So of course, this is an automatic breach, right? I have not seen such a data set in my life. How is that possible? And to be fair, this part is currently being vigorously debated. Here you'll see that this is an official EU document. There are 3 versions and they are tracking changes. So this document really wants to be a Git diff, but leaving that aside, you will see that essentially there's more words added in to say, okay, only to the extent that it's reasonably, only to the best extent possible, right? Otherwise, it's just going to be an automatic breach. You might be interested to know that penalties for high-risk system providers, they are drafted competition law style, which means it's a percentage of your annual worldwide revenue, 4 to 6%, and the numbers are being debated. It's a huge amount of money. Right? And quite relevantly for this audience, there are later discussions about adding exclusions for research, because that makes sense. AI systems that, including their output, are specifically developed and put into service for the sole purpose of scientific research and development, that is meant to be excluded from all this regulation. But you see, the word sole is doing a lot of work here, right? What if you have a collaborator from industry, which is a good thing, to be clear. So it remains to be seen how much of a safe harbor this will be. As I've said earlier, we'll have to wait for some updates. I don't know when it. No, they've said that they want to put it into force this year, and then it didn't happen. And so we'll see, right? Meanwhile, here are several other things that are keeping policymakers around the world also busy. This is a Chinese legislation on recommender systems. I do read this stuff, even if I'm not very good at it, but I'll just highlight one part of this. Some people in the audience might be able to read this, but to translate this, in case you can't, where am I? These are China's generative AI measures released in April, and they specifically and comprehensively regulate AI and requires amongst generative AI, and it requires amongst other things that the content generated, this part, it should reflect core socialist principles and values, whatever that means, right? There's Canada with its Artificial Intelligence and Data Act that was tabled in June 2022, which, like the EU legislation, it tries to regulate what it calls high-impact AI systems, and also to prohibit reckless and malicious AI use. You would know this is the President Biden's US executive order on the safe, secure, and trustworthy AI systems that was signed about 2 months ago, and it directs tech companies to work with the NIST, the National Institute of Standards and something, to come up with standards, tools, and tests that ensure that AI systems are safe, secure, and trustworthy before companies make them public. The UK's Artificial Intelligence Regulation Bill, this is a sort of a very small bill that is not, it was tabled as a private members bill, which means it's kind of an individual project. It was tabled only last week, and it proposed setting up what it called a national AI authority in the UK. It's unclear how much traction this will get. It's again an individual project. And apart from all this hard law, quick honorable mentions, countries around the world have been publishing all sorts, of soft law and guidances and policy papers on AI. By soft law, I mean that it's not legally binding in the sense of, you could go to jail or pay a fine if you don't comply. But if you don't comply, regulators might come and knock on your door and show you a very big frowny face. There could be political and reputational, even if not legal, consequences. And of course, you would know that there's a lot of litigation, primarily in the US, but not only in the US. There are some areas like patents, copyright ownership, infringement in particular, but even also defamation. Anytime you generate content, there are all these considerations. And the courts are trying to answer some of the toughest questions around AI systems right now. A lot will be hammered out by regulators, lawyers, and courts in the next few years. Right? And we see that all in the making. So last part of the talk, I will just try to make sense of all this. What does this all mean? What does it mean to grow up? I'll offer a few suggestions, though I must quickly add that, this is meant just to start a conversation. I am not qualified to advise, quite literally. And in making these suggestions, I will assume that if you're here and not, one of the dozens of other workshops, you're interested in how NLP can make useful things for lawyers. The first thing, is really to build interdisciplinary connections. You would see on the screen that The Onion wrote a very cheeky riff to Dan Katz's and colleagues' article on GPT passing the bar exam, right? GPT wanted to be an art bot, but was forced to take the bar exam and be a lawyer. It's a very Asian thing as well. For lawyers, especially, I imagine that when GPT shows up to work in its white shoe law firm first day, what's the first thing it's going to do? It's going to try to make friends. And this is really, really important for a lawyer. And you want to have friends who are not lawyers, because other lawyers will never become your clients. You want to have friends in other disciplines, and it works both ways. The scale and complexity of many of the big NLP questions, legal NLP questions that we face today, are beyond what any individual researcher or even discipline can tackle. Just look at the amount of legislation, right? I am not going to read all that stuff. The last computer scientist I met right away, who thought, as usual, I will do a weekend project. It'll be a hackathon. I will solve the law and I'll move on to something else. Yeah, he ended up spending 7 years working on this project, and now works with me at SMU. So be careful what you wish for. This is all to say that the interdisciplinary dialogue, which happens at events like this, are crucial really to the general health and progress of the entire field of AI, I think, not just NLP. And on this note, I would suggest that computer scientists need not even go outside of your own discipline. There are oceans of unexplored research opportunities in the nexus between NLLP, right, as we understand it in this room, and I suppose more conventional threads of AI and law that people in the room might also be familiar with. ICAL, Zurich's conferences. Here's a slide that I presented for the Computational Law and Legal Studies conference that we organized in around July as well. You notice that NLLP is right in the middle. So this is the standard data science trifecta, right? Domain knowledge, math, and engineering. NLLP is kind of a bit of all of them. You're in the middle, and it's very easy to reach out to some of the is empirical legal studies, it's computational legal studies, computational, it's a lot of terms, but I think people are all trying to build useful things for lawyers, right? I've been reviewing workshop papers every year and very happy to do so. Organizers take note. And I've noticed that generally some of the papers from other conferences, they get missed out even if they're relevant. There are papers in law reviews that get missed out even when they're relevant. And of course, it works the other way as well, right? And I think we need more of this interdisciplinary, interconference kind of dialogue. And this is not really just to get through peer review. That's not the thing. Most of the stuff is good enough to get through. But really, although my own work is mostly empirical as well, I've worked with and learned a great deal from my colleagues at the Center for Computational Law who use more formal methods, programming language theory, for example. And speaking as an AI outsider, really, I've never quite understood this whole thing about the neuro-symbolic divide, that, if you do symbols, I can never talk to you. Is there a public field between people? Have they now united? I don't know. To me, and if I can misquote a famous American judge, to me, they sound like perfect complements of logic and experience. Oliver Wendell Holmes said that the life of the law is not logic but experience. I kind of disagree. I think it's both. And that's the first point. My second point, my second conversation starter, is on the importance of the legal backdrop to anything you're researching. Really, anything. Law is not something that you can just really import and then be done with. No, at NACO 2019, I remember I chanced upon a poster at the main conference, which had used some kind of EU law dataset to benchmark their proposed labeling approach, new algorithm, structure. It all looked very sophisticated. So I asked them, how have you used this data and know what the label set was and what's this data all about? All the presenter could really say was that, well, this is some kind of legal data set. It's the standard data set we use to benchmark stuff. I think it's a data set that some people in the room created, actually. So, if collaborating with a legal scholar is unfeasible because of different, what I call publicational aspirations, some attempt to review and just present the legal background would still very much be appreciated. In the social science background that I come from, you write 4 to 8 pages on the data set alone. And the whole paper is 25 pages, right? Not 48 pages on the entire thing. Again, it's not just about getting past peer reviewers, it's to make sure that the data sets and systems that are being built actually make legal sense. This legal backdrop is particularly important for generative AI models, because a lot really depends on the prompts that people are going to put in. What kind of prompts are lawyers going to use? You can't know this unless you ask them. You have to go to the field. What impact would this have on legal workflows, on legal processes? Well, again, you can't just think about this. You have to actually go out and maybe conduct an A/B test. It's not something that an F1 score can really tell you much on. And at the same time, the legal industry's newfound enthusiasm for AI means that it's not just sitting by and waiting for technology to descend from the heavens. It is also actively trying to build its own systems, some for the better, some for the worse. There is a real chance that a system that you are working on is also currently being developed or conceptualized by people in the legal innovation and tech firm of some big major law firm or a ministry somewhere in the world. Wouldn't it be quite nice to work with them and maybe get some funding? Well, 2 days ago, the Singapore government announced that it was going to spend 70 million Singapore dollars to build a large language model for the Southeast Asian context. And this context involves about 12 different languages spoken in just this part of the world. I don't know about you, but I wouldn't consider getting a 70 million 2-year grant within my domain of competence, right? It's not something that people can really manage. I'm not sure how they're going to spend $35 million a year, but I'm just putting it out there. This is all part of a larger AI strategy, National AI Strategy 2.0, which was announced literally 2 days ago, which includes some plans to involve R&D, academia, to invest in building talent, attracting people from all over the world to, well, make Singapore AI great or something. Okay, now that I have cleared the official messaging, I can finally end the talk. My final observation is a call to action, really. Now, very important debates on the future use and regulation of LLMs and AI systems are currently occurring. And it is not really just about the technology narrowly defined. Instead, it's this whole battle of narratives, hearts and minds. It's a lot of politics. You would be familiar with the so-called AI doomers and the accelerationists. Some people call them the bootleggers and the Baptists. And apparently, it's all China's fault. Many public, private, and vested interests are at play here. I find this really hard to relate to as someone who first learned about logistic regression in econometrics class and really understands AI as applied linear algebra. It's a bit simplistic, I know. But who would have thought that math would be so controversial? I believe the NLLP research community has a lot to bring to this debate and can step up in a really big way if we set ourselves to it. It would be very unfortunate, I think, if the answers to some of the most pressing questions on the regulation and use of AI systems in society end up being determined by profits and politics rather than science and facts. But if you have tenure, then you have one thing that even billionaire tech CEOs might not have: job security. I shouldn't oversell this, of course, because some tertiary education isn't in the best financial shape all over the world. But more than many others in industry or governments, the people in this room actually have perfectly the right expertise and incentives to guide lawmakers on what LLMs actually are, and equally importantly, what they are not. Industry will always have more resources to chase a few profitable things. The researcher's advantage is in having fewer resources to chase even non-profitable things. And this forces us to focus on what really matters. Innovate under necessity, and when necessary, to challenge existing orthodoxies. That is the role of the academic. And to conclude, as legal NLP grows up and its domain of secure competence expands, it will have to decide what kind of person it wants to grow up into. Will you want to be like the average law firm partner, very rich, but very bitter? Or would you aspire to something humbler, but perhaps more meaningful? And all of that is really up to us. Thank you so much, and welcome again to Singapore.
Thank you, Gerald, for this fascinating talk. I think speaking on behalf of all the NLPers in the room, maybe before the talk, our problems was like, okay, how I'm gonna apply the best LLM to beat the state of the art, and maybe after the talk, you have thoughts like, dear God, what am I doing, right? So in that sense, I think the reason for bringing you here, I think it really worked. So thank you so much for that. We have time for questions, so please feel free to raise your hand. Otherwise, meanwhile, I can get us started, or yeah, Nikos.
Gerald, thanks for the great talk. It was it's really amazing. Actually, you mentioned about regulation and AI and large language models, and in one of your slides, you stated that harassing legislation and regulation might not be a good idea. Could you elaborate a little bit more of what are the pitfalls or dangers of like rushing into making decisions about it now rather than doing it in a more long-term plan?
Yeah, so if I were to give a bit of a theoretical answer to this first, in the sort of theory of regulation, there's this famous thing about the timing of legislation. It's called the Collingridge dilemma, named after the person who proposed it. And it's the idea that if you regulate too late, coming too late, you might have a lot of information on the risks and harms and the application of the system. But well, the processes, the technologies are already entrenched. So you can't really change things. But if you regulate too early, the problem is you don't really know what's going to happen. You don't know what's the real risks and harm. You don't even know what the technology looks like. And that's, I think, the big challenge that regulators face now. I would like to think that regulation should be based on facts. Some people say that regulation should be based on science fiction. There's a lot of that right now, and I'm worried that if you jump into it and you want to regulate something, and you're talking about generative AI or any new thing, and just as a knee-jerk response, write something in response to that, it's not going to be based on the actual harms that you're supposed to target. And this is unfortunately what kind of happened with the EU's AI Act, because when it was first published, there was nothing about foundation models and generative AI. It was April 2022, right? So it's kind of that was not yet on the horizon. But then when it came up, the challenge was, how do you patch the legislation? And whenever you patch something, right, and you graft it on, as software developers would know, the more you patch it, the more unrecognizable it becomes, and you have all these problems with conflicting laws. You've added something to Section 12, but it conflicts with Section 1, and nobody realized. Standard stuff with software development as well. So rushing it is always bad, as with software, I think. Thank you very much. Thank you.
I really like your point about the sort of this alignment of interest in terms of publication that sort of prevents CS people and law people to collaborate on research projects together. But at least on the CS space, I've seen a lot of conference sort of try to build mechanism that encourage more collaboration between not just CS and like the humanities in general, but CS and law specifically. Like for example, FACT, like the conference that you review for, has a non-archival option for paper, so that FACT conference paper can later be turned into like law review paper and so on. So what do you think? What is your observation about the legal publishing space? Like, is there a lot of initiative going on in terms of law review journal or student-run law review kind of publication venues that's also hopefully encourage those kind of CS and law collaboration?
Yeah, that's a great question. And the thing about the law publishing circle, it's quite fragmented. There's this whole US system, which is, as you've alluded to, run by students, run law reviews, and then there's the rest of the world, which uses the metric system, which uses the peer-reviewed journal system, and that's the one that Singapore really looks at the most. So it's a bit fragmented, and I would say that because of the student involvement in the US system, it tends to be a bit more broader, a bit more broader in terms of the ideas and everything that goes through. The gatekeeping is on footnotes, not on substance. And I've seen a lot more interdisciplinary work get published in the US system, to the extent that a university outside of the US recognizes the US publication, and many universities do. That's great, and that makes it slightly easier. But I wouldn't say that the US system is perfectly good as well. There are some also drawbacks to it, but I think I'll just leave it at here for now.
I think we are running low on time. So is there any other question, or maybe to also act a bit as a lawyer and try to problematize you a bit? So you mentioned that, of course, like the concept maybe of legal AI is as old as Leibniz or something. Yeah. So, and we've been here before in a way, like in the 80s, where AI maybe overpromised and didn't deliver. So my question to you would be, in your opinion, right, what maybe we should avoid as a field as looking ahead, or maybe what we should be focusing on in order not to repeat the same steps?
Yeah. I just one quick response, which is really not overpromising, because lawyers are very, very sensitive to that, and you know, they don't really understand the technology, and you can pull one over them on that front. But overpromising, they can literally smell it, and so I think a lot of the AI winters that came about is not because the technology is not good. I mean, well, beating the world champion of chess is a great achievement, but it was really the hype after that, and people overpromised and underdelivered, and so every dystopia starts out by an attempt at utopia. Every winter starts out by an attempt at an eternal spring. So if somehow this time around the field can avoid overpromising, I think it will have a much more sustainable sort of a marathon rather than a sprint into the future.
Okay, thanks. So yeah, thank you again, Gerald, and please join me for another round of applause for our invited speaker. Okay, and without further ado, we'll move to the next session, which is on retrieval, one of my favorite topics. Trying to find, is the first speaker of the session in the room? Okay. Now or? Okay.
HDMI.
So you just need to connect to.
You just need to connect to the Zoom session, and then you share your screen.
Really?
If you're not ready, can we do the
Okay. If
second
you
thing?
can't do it from here.
No, you need to connect from your laptop to the Zoom session, and then you share your screen. So
So if you're not already connected to the Zoom session, would you mind going a little later?
Maybe I can use the Gmail to download my file.
But we're running low on time, so I would say maybe you can connect to the Zoom session.
Okay, maybe.
No, he doesn't. He's got them in his email, so he needed to download them. So why don't you?
Can go later.
Yeah, just go later. Yeah, we'll just swap around.
Connect to the Zoom, and then you will share your slides via here. So that's the easiest thing. But yeah, meanwhile we can. It's in the email we sent yesterday. So yeah.
Yeah, so just go to your email, connect, go to your email, download the stuff, then go to Zoom. Okay, then you come back.
Okay. We have some technical difficulties. We'll move to the second paper and come back to the first. So the second paper, Joint Learning for Legal Text Retrieval and Textual Entailment. Are the authors online or?
I'm here. I'm in a Zoom online.
Oh, great. Yeah, you can share your screen and you can start.
Okay, thank
whenever you're ready.
Have you seen my my screen?
Yes, we can see your screen. You have 5 minutes, right? I'll give you a warning when it's time.
Okay. Hello everyone. My name is Hải Long Nguyễn. I am delighted and honored to be here to present my research titled Joint Learning for Legal Text Retrieval and Textual Entailment. My presentation consists of 4 main parts as outlined on this slide. In the first part, I would like to introduce two problems legal document retrieval, and legal textual entailment. These are two crucial problems in the legal question answering system. In the first problem, called legal document retrieval, the input consists of a query and a legal corpus. The output is a set of legal articles from the legal corpus that are relevant to the query. To solve this problem, the model, represented by the F function, need to predict for each query document pair whether they are related or not, corresponding to the label yes R and no R. For the second problem, legal textual entailment, the input consists of a query and a set of relevant documents, and the output of the problem is the correctness of the query based on the content of the provided legal article in the relevant document set. To solve this problem, the model represented by the function G need to predict two labels, yes T and no T, corresponding to the correctness of the query. The two described problem has a close relationship with each other. This is inferred from the fact that when a lawyer wants to prove a query is true or false, they tend to search for laws with content that support their perspective. In some cases, the correctness of the query plays a decisive role in determining which legal articles are relevant to the query. Based on the observation above, our research team has proposed a new problem, which is the combination of the output of the two original problems, and we named it legal outcome-based retrieval. However, to combine these two problems, first our team proposed to decompose the relationship in the legal textual entailment as the formula on this slide. The relationship between Q and the set of relevant text A1, A2, and AN is decomposed into one-to-one relationship between Q and each document in that set. Throughout survey, although this decomposition may affect the rightness of the original data, the rate of case leading to error according to our statistic is not significant. After breaking down the entailment relationship, we combine the outputs of the legal retrieval problem and the outputs of entailment problem after decomposition to form a new problem. The model need to predict both label E and R. The proposed problem can be used to enhance the performance of the retrieval problem, because now the information of entailment has been added to the model output through the backpropagation process. To verify the effectiveness, we propose a simple multitask model based on the BERT architecture to solve proposed problem and evaluate the model retrieval result. This is our overall architecture. The body part utilize the BERT architecture initialized with pre-trained parameter and is supplemented with two output heads for retrieval and entailment. We conduct experiment on the COLI 2022 and 2023 datasets, which are the QA dataset in legal domain. The legal corpus use either Japanese serial code. Based on the result table on the COLI 2022 datasets, it can be observed that the multitask model consistently outperforms the single task model in terms of F2 score. Moreover, the multitask approach even achieves higher results than the top performing team in the COLI 2022 competition. Similarly, with the COLI 2023 datasets, the multitask model continued to outperform the single task model. Compared to the result of other teams in the COLI 2023 competition, The multitask model also demonstrates the superiority by achieving an F2 score close to the top performing team while maintaining a simple model architecture with two output hits. To surpass the top performing team, all model need to be weighted and sampled to enhance the overall generalization of the retrieval system. Through experiments, it is evident that the multitask model achieves superior retrieval performance. My presentation concludes at this point. Thank you all for your attention.
Thank you for the presentation. As usual, we have a joint QA at the end. So are the authors of the first paper ready now to present via the Zoom, or you're ready? Okay.
I take the HTML. You're in the Zoom now.
So you're in the Zoom and you share the screen.
Oh, yes.
Share the screen.
Good afternoon, everybody. I'm Nathan Min, CEO of Law and Good, and it's an honor to present our meaningful work in legal technology. Actually, it's a quite short presentation of 5 minutes, so I'll make a quick speech. Law and Good is a leading legal tech startup in Asia using the power of LLMs to democratize access to knowledge for law firms, corporates, and public institutions. In May, we launched the first legal GPT in Asia using our legal data gathered from our legal marketplace. In the process, we gained meaningful insight into applications of LLMs in the legal space. Today, I'll be discussing the retrieval-based evaluation for LLMs, case study in Korean legal QA, collaboration with Link Labs and Law and Good and Yonsei University. The advancement in large language models, such as GPT-4, has opened new doors in various fields, including law. However, their application in specialized domains like legal QA comes with challenges, especially the potential for factual inaccuracies. Accuracy is paramount in legal context. Therefore, a robust system for evaluating the reliability of LLM-generated text is vital, especially for legal queries, where precision is important. To address these challenges, we developed EVARAG. It's a novel evaluation method that utilizes retrieval-augmented generation principles to assess the validity of LLM-generated text in legal context. EVARAG stands out by leveraging related legal documents to evaluate responses. This approach ensures that evaluations are grounded in actual legal principles and precedents. The EVARAG framework functions in two phases. Initially, it retrieves legal documents related to a query. Then it evaluates the LLM-generated answers against those documents, employing advanced techniques and models like GPT-4 for precision. Our methodology involves embedding techniques and LLMs for both retrieval and evaluation, ensuring the relevance and accuracy of the documents used in the assessment process. Let's consider an example to illustrate EVARAG's effectiveness. The query is a transfer of real estate ownership through divorce subject to capital gains tax? Then GPT responses like this. Explains that property transfer in divorce may be subject to capital gains tax, but can be exempt under certain conditions. But RAG responses like this cites a Supreme Court precedent asserting that such a division is not subject to capital gains tax. And document refers to a specific case law supporting RAG stance. And evaluation scores, lawyers and EVARAG-based evaluations favor RAG, while traditional chat eval methods show mixed results, often inaccurately favoring GPT. So this example demonstrates how EvalRec aligns more closely with expert legal opinions, enhancing the reliability of LLMs in legal context. Yeah, so in conclusion, EvalRec represents a significant advancement in legal AI. It bridges the gap between the capabilities of LLMs and the precise demand of legal expertise. Thank you for your attention. We're excited about the potential of EvalRec to revolutionize legal question answering and look forward to its continued development and application. Thank you so much.
Thank you so much. We'll take questions in the end. We move to the next paper, Tracing Influence at Scale, Contrastive Learning Approach to Linking Public Comments and Regular Responses. I think I saw Lindsay on the Zoom, but
yeah.
Okay, cool. Yeah, you can share your screen and take it away.
Okay. Sounds good. Can you guys see the screen?
Yep.
Okay. So hello everyone. Today I'm going to introduce our research work, Tracing Influence at Scale, a contrastive learning approach to link public comments and regulator responses. This is a joint work by UBC and Ivy Business School in Canada. Okay. So the policy or rulemaking process of the United States can be summarized as 4 stages in high level. First, agency will propose rules, and then they collect comments from the public, and then they review received comments and they revise these rules accordingly. And finally, they publish final rules with responses to the public comments. And recently, more and more research try to monitor, assess, and understand the role of individual organizations that comment on proposed rules and how these comments influence the rulemaking process over time. The final rule observation, which includes responses from regulators, is published in the Federal Register, and its associated comments can be extracted from the website regulations.gov. The answer to the question of how comments influence the rulemaking process, the first step is to figure out which comment has impact on which rule. But as the number of comments received by regulators has been growing over time, and the federal government now regularly receive more than 1 million comments per year, a follow-up research question urgent to be answered is, how can comments and regulator responses be effectively and efficiently linked in the large scale? Aiming for this research question, we formulate comment response linking as a text semantic matching task and propose a contrastive learning approach to enhance the matching accuracy of conventional text encoder-based methods. So in practice, we have a rule observation consisting of a set of comments and a set of regulators' responses, and a vanilla common response text matching model, which we choose here, we choose the sentence word by encoder as the foundational architecture. We basically propose this contrastive learning approach to fine-tune the text encoder in this common response matching model. As we do not have ground truth matching label, we make the model training entirely rely on the labels of created pseudo-positive and negative common response sample pairs. To do so, we first identify a set of positive pairs by searching for the most semantically related comment for each response by using the initial common response matching model. Here we can see each row is a pseudo label whether a response match each comment, and only one label is positive in the row as in our setting, a response only match one comment. At the same time, we can also obtain the prediction from the common response matcher. And after computing the loss between pseudo label and prediction, we pick those pairs with the highest loss as hard positive or negative samples and optimize the encoder part on them. And it's worth to notice that this contrastive learning framework is iterative, which means that the updated matching model will be used to select hard positive or negative samples in the next iteration. And for evaluation, we create 160 common response pairs manually labeled using a 5-point Likert scale and compare with 5 semantic matching baseline, including 2 powerful gigantic language model, Llama 2 Chat 70B and GPT-4. The way we tested these 2 language models on this task is prompting them with the same annotation scheme we provide to human annotators. We first observed that applying our iterative contrastive learning framework, the performance of common response matching model using both Roberta or SentenceBird as text encoder gets substantially enhanced by Pearson correlation with human. We then also found the contrastive framework we introduced here, plus the SentenceBird, can perform much better than Llama 270B and achieve comparable performance at GPT-4. But it is a more cost-effective option in the large-scale setting because usually comments or response text can be very lengthy. And as we know, those closed source large language models, we need to pay them by the input and output length, and also the number of your data. So yeah, here's some key takeaways. So first, we aim for automatically matching response in policy regulations and relevant comments to respond to. And then based on that, we propose a simple yet effective contrastive learning approach. And this approach can make the text matching model achieve comparable performance, but more cost-effective than GPT-4. And also our method from the experiment, our method exhibits the model agnostic behavior. So it's not just to perform well on SentenceBird as the base encoder, it also performs well on Roberta. And if in the future, there are more powerful text encoding model, it might also work. And thank you very much. And yeah, you can also find our code from this link. Thank you.
Thank you so much. And we'll move to the last paper. I think the authors are also online.
Yep.
Great. You can share your screen and start.
Perfect. Hi, everyone. It's a pleasure to be here with you. I am presenting some work that we presented as kind of a position paper on disconnects between legal NLP and legal practice. And so the key takeaway is that we find ourselves amid an access to justice crisis, and it appears that legal NLP could help address this crisis by scaling the provision of legal services. But as we discuss, our community does not always focus on this. And so what is access to justice? This is this long-standing principle in judicial systems that everybody should have equal access to legal systems. The problem is that we observe around the world that not everyone does have this kind of access. Even in the United States, 90% of civil legal problems encountered by low-income individuals receive inadequate legal support. There's a similar kind of picture for small businesses. About 60% of those have problems gaining legal support for civil problems. In criminal contexts, public defenders around the United States are systematically overworked and underfunded. And we observe and we discuss in the paper similar issues in jurisdictions around the world. This seems like a tremendous opportunity for legal NLP. The problem is that in conducting a rapid review of legal NLP literature, we find that the tasks that are focused on are not always informed by the needs of legal practitioners. Instead, legal tasks are kind of cast in an NLP way that doesn't always address the key issues from the legal practitioner's perspective. We also see that these publications tend to be produced by and consumed by the legal NLP community, and there's very little interdisciplinary citation, and it seems like there isn't a whole lot of interdisciplinary communication, which may in part be responsible for the slow adoption of legal technology in the legal community more generally. A fine example of this disconnect is legal judgment prediction. This was the most common task identified in our literature review. And often what legal judgment prediction will do is use facts from a judge's opinion to predict the outcome. But the problem is that these facts aren't really neutral. And so you're not always picking up the key kind of legal elements, and instead you're doing something that's more akin to sentiment analysis. Even when legal judgment prediction is framed correctly and uses the legal data correctly, it presents pretty serious ethical questions. Biases in legal judgment prediction would present massive societal risk of incorrect judgments. And there's also this kind of human element of judging, which we argue should probably make legal judgment prediction one of the last things to be automated. So what are the right tasks to focus on? We inform that partially based on a survey of 60 senior law firm partners from 17 different countries. This was conducted as part of an executive education program at Harvard Law School. And we asked them kind of what applications of NLP or generative AI would be most interesting to you. And some of the things that bubbled up include things like persuasive legal reasoning. So how do I make the best possible argument in the context of a specific judge or a specific jury? Practice-oriented legal research. So we know that there are a lot of papers already focusing on legal research. This is a big part of practice. But there would be ways to align that research more closely to how lawyers actually conduct legal research. And finally, retrieval-augmented generation with private data. A lot of data is privately held by law firms. And so discovering methods that allow that data to be leveraged to generate texts like briefs and filings would be tremendously helpful and is something that the lawyers are actively asking for. So to wrap up, access to justice has the potential to be a normative goal for legal NLP. And we hope that the community kind of embraces it more. And I'll just wrap up by saying that this kind of work was made possible by an interdisciplinary team of legal and NLP experts to whom I'm very grateful. And thank you. I look forward to your questions.
Thanks. We have some time for questions before we go into the coffee break for all 4 papers. Is there somebody who would like to start for any of the papers? Yes, I'm coming.
I have a question for the paper, retrieval-based evaluation for LLMs. As I saw in the presentation, I believe that the RAG output and the eval-rag evaluator might be prompted with, okay, I see. I believe that the RAG component and the evaluator component are prompted with the same, possibly prompted with same document examples. So I believe that if they are seeing the same snippets, the results that the RAG, eval-RAG correlation improving is rather trivial because they are exposed to same documents. And it is a slightly less important question, but what is the embedding model that is used in the paper?
If you don't mind a quick answer so that we have more time.
Yeah, so they're not the same document. There's the law, decree, and interpretation data, and then there's the previous consultation data, and so they're not the same. And The second point, embedding model, we use a proprietary model that doesn't rely on OpenAI. Thank you.
Thanks. Any more? No, because the Zoom one.
Okay, so my question was that if the evaluator and the generator are having the same snippet, so you have to probably split the document pool of retrieval-augmented generator. So, I mean, like there could be different kinds of documents, but if the retrieval pool is the same, it doesn't matter if you like evaluate with RAG. It's obviously better results. I believe you got it.
Maybe you are saying what happens if the retrieval is not good, or
so you generate with snippets and you evaluate with snippets. So you use document snippets in both cases. But if the pool is the same, it could be a serious matter, because like if generator sees document ABC and the output is evaluate with ABC, then it's kind of trivial that the retrieval augmented generation will give better points. So I believe, yeah.
Quick comment.
Yeah, I think we can take this offline. But yeah.
Any more questions? We have any questions in the Zoom or? Yes, one question in the room. Please.
So this question is for tracing influence at scale. Was there any attempt at deduplicating the comments? Because when you look at the comments that usually come in, you would have different organizations who have organized letter writing campaigns. And so the comments will differ by maybe just a line or two, sometimes just the greeting or the name on it. What pre-processing methods did you have in place to deal with that?
Yeah, so because this paper, the contribution presented in this paper, it's like one part of like a larger picture, like of our project. So there's another colleague who is particularly working on like pre-processing the data. But yeah, but like from my experience and from my observation, it is also very like the data, the raw data, very noisy, because a lot of times even those comments, they are just they are not like they're just scanned and then uploaded like pictures. So like the quality like of those comments sometimes can be like very bad. But what we basically do is, so for a lot of like those not make sense at all, like those comments, we just drop those comments. But like for some others, we basically try to remove like all these paragraph, or like remove like all these paragraph breaks, or like remove like those blank lines. And then we try to segment those, like using the sentence segmentation and paragraph segmentation models, and try to make them like more structured and organized. And yeah, so sometimes like if they only contain those greeting, or like they just have one or two lines, then we usually just drop them. Yeah.
Thank you. I know you all want to go to the coffee break, but I have maybe a quick question for Gwen. So the second paper. So in your paper, you showed, you worked a bit on the one hand with the weighted and the average approach, and I'm wondering the weighted seemed to work better. So what exactly was the weighting there? So which of the two tasks or two approaches were weighted better?
Could you repeat your question?
Well, you had the ensemble approach, right, with the weighting and the averaging. So, and the weighting, of course, worked better. So I'm wondering if you had any more thoughts on how did you do the weighting and which approach it favored in the end?
Oh, yeah. I have four main model is that single task zip in Japanese data, English data, and multitask in Japanese data and English data. I I do a research process in validation sets and set and choose the best weight for each relevant score that are output of that model, and I choose the best weight.
Okay, thanks. Given the time, yeah, I propose we now go to the coffee break with only a 6-minute delay. So we'll be back at 4 with the last session of the day. So yeah, feel free to grab some coffee and some snacks, and we'll see you back at 4. Also, Gerald is still around, so if you wanna poke him for more thoughts, please feel free to do so. So we'll be back at 4.
Am I sharing the screen from here? Should I stop share from here? Sorry. Right, there you go. Right, Santos is our first presenter. 5 minutes. Right, let's go.
Hi everyone, I'll be speaking today about towards explainability and fairness in Swiss judgment prediction, benchmarking on a multilingual dataset. So the task of LJP is to determine case outcome from facts description. Currently, the trend is to apply deep learning methods to predict the outcome based on fact statement, but bypassing all the interpretability and the reasoning process underneath. So this can turn out to be having a significant risk when they rely on factors which may be predictive, but really lack legal relevance or does not make or involve some sensitive attributes. So such reliance will lead to unjust outcomes. So evaluating these models or understanding from an explainability standpoint is very important at this stage. So we technically analyze explainability at a rational level using Swiss judgments, and we annotate 108 cases at a sub-sentence level with labels called support and oppose judgment. Unlike the current works, which only try to identify the sub-sentences which are important for explainability, we also do at a fine-grained level to understand whether this particular sentence, because it's not a black and white, it's a gray area between. So we want to identify which factors try to support the judgment, which tries to oppose it. And we use an perturbation-based occlusion technique to remove those rationals and see what is the change in the prediction confidence happening over the outcome prediction. Then we also observe bias based on Supreme Court jurisdiction setup, where that handles the cases from lower court. So we try to identify if we just change the lower court name, which is just a 7-token text in a whole case document, and try to analyze how does inserting other lower court names into those case documents and measure the change in prediction confidence scores. So this is the Joel's SJP dataset, which is the multilingual dataset available in 3 languages, German, French, and Italian. So we have 3 legal experts annotating 108 cases, both from validation and test set, equal proportion of languages. And we ask them to label at the sub-sentence level to identify supports and oppose in the final judgment outcome as the sub-sentence level. We also try to annotate neutral sentences, which is not a label per se, but we want to identify just removing these changes should not have any effect on the outcome. And we also annotate for the lower court mentions in the fact statement. And we observe the inter-annotator agreement, and we observe lower court and support judgment is notably high. And opposes judgment is very difficult to obtain a good agreement on, because it's disagreement between annotators to arrive at what are the factors which are really opposite playing to the final outcome. So this is a final dataset we create. The occlusion dataset is for explainability, where we occlude different number of sentences with the same label and try to pair it with a baseline to observe and measure what is the difference with prediction in the probabilities just by occluding them. And the LCI dataset is the lower court insertion dataset, where we derive counterfactualness test by replacing it with other lower court names. and try to understand how much is the change in prediction performance by just changing the court names. So we use the metrics to observe difference in the temperature scale probabilities and try to, based on the sign of the direction it is changing, we try to assign the labels and we report F1 score for each labels. Whereas for LCI fairness, we try to change the explainability score and apply and understand whether it is a pro dismissal or whether it's a pro approval that court is influencing. And we also find flip ratio on whether the small 7 token lower court name has a power to even flip the label of a predicted label. Yeah, so I mean, final takeaways of the results, which I'm presenting very briefly, are you observe better scores for F1 score for supports than neutral and opposes, because neutral is a much more tighter condition, because just changing a sentence or just occluding a neutral sentence should not change probability at all. But changing that epsilon border of probability is very marginal. So that makes models much more tougher to predict that as a neutral stance. Given the multilingual nature of the dataset, we observe fringe is better in specific label, but this does not apply well for other labels on fringe. So there is this language representational bias also coming into the dataset play. And then usage of multilingual models versus joint training also has an impact on your final prediction performance. And data augmentation has helped in some setups, has not helped in some setups. So there is a ultra lens we need to look at from explainability point of view, because different factors are at play at the end of the day. Similarly, for LCI bias, the main takeaway is like there is a change in 5% of confidence score with a 7 token length lower court name. So with addition of data augmentation, the bias further increased. So the bias further increased. So the data augmentation components need to be studied and analyzed. How is this data augmentation really helping the model? Is it just influencing for a particular lower court towards a pro approval or a pro dismissal stance? And finally, joint training model helped only on a specific language of Italian, but didn't come across at other languages. So there is this representational bias in the data set which need to be studied further. So the main takeaways is providing a data set of 108 trilingual cases at a very fine-grained level, which is for supporting and the opposing factors. And we use a perturbation technique called occlusion to assess the explainability. And we also assess the bias in the models of using lower court using counterfactual LCI test. And we observe an average of 7 tokens has potential to flip even the predictions. So current LJP models need to be analyzed from explainability and fairness perspective. Thank you.
Right on time. And now we're going to move to the next presentation for this session. The paper is called Mixed Domain Language Modeling for Processing Long Legal Documents. Do we have any of the presenters here or online? The second paper. Actually, we can move to the next paper then. Wait. But I see, oh, sorry. I mean, I read a different paper. Sorry, that was from the morning session. What I'm saying. Okay, so do we have any, LLMs, the good, the bad, or the indispensable? Do we have any of the authors here?
Yeah. I'm present.
Okay, sorry, I made a
Yeah.
mistake. All right, you can share your screen, and Atharva, you have 5 minutes, okay?
Yeah, okay. So LLMs, the good, bad, or the indispensable. So very strong motivation for this paper is as follows. Whenever AI prediction is considered, the faith on judicial system, careers, money, reputation, social image, everything is at stake. So the end users or the legal professionals are not likely to trust an absolute black box. So therefore, explainability of AI system is vital. To show how an explainable system might work is the use case of statute identification with explanation. So these are the facts of a Supreme Court of India case, and the statute applicable in this case is punishment of murder, IPC 302. The part of the text highlighted in red is actually the explanation for the applicability of the statute. So when we provide the facts of the facts of the case as the input and we get the output IPC as the result, along with the explanation which is highlighted in red, then we can say that the system becomes more transparent and is actually close to an explainable system. So nowadays, LLMs are becoming popular not only to the common man, but also to the legal professionals themselves. So in the light of this, we have attempted two legal specific tasks, statute prediction and judgment prediction, and have also discussed the presence of bias and the ethical considerations for using LLMs in law. So this is the structure of the prompt for statute prediction. Here we can see that we have provided the instructions for carrying out a task, and then we have provided in context learning. So this is a form of few shot method of prompting for only prediction purpose, and this is for the prediction for explanation purpose. We have also used the chain of thought prompting where examples of explanations are also part of the prompt. So the results we can see that whenever we provide explanation, whenever we ask for explanations in addition to predictions, the LLMs perform better in all other cases when compared to other cases. And we can see that LLM outperforms all the baselines in the prediction only task. And it is significantly better than EXCELNet, which is the best performing baseline. In this binary classification problem of judgment prediction with explanation, we have also used few shot method of prompting with chain of thought. This is the structure of the prompt. And EXCELNet large was again the best performing baseline, probably due to lots of parameters to train from. And we are doing better than InLegalBERT and are close to LegalBERT. Now we tallied the explanations generated by the LLMs with the expert annotated ones, and we see that the BERT score value is better. So this probably indicates a good semantic match, which is not captured by a verbatim match. Here are some perfect examples. These are the annotated examples, and these are the generated explanations by the LLMs. We have also then provided this the statute prediction, judgment prediction. So explanation analysis to an expert. We have provided 10 cases, and on the Likert scale, we have asked him to give points out of 10. So in judgment prediction, it is better. So regarding hallucinations, so hallucination analysis was done in our paper. We have also recorded fairness and bias in the paper, in which we recorded gender frequency disparity and group disparity. So we can see there is an increase in male by female ratio in the generated explanations over the annotated ones. Like here's the presence of he, she, and these gender pronouns in the generated explanations. About ethics, yes, LLMs have tremendous potential of spreading misinformation, but there are concerns. But there is a way ahead in which we can see that we can use LLM technology as not only as an augmentative, we can use LLM technology as an augmentative technology and not as a substitute for an human effort. So thank you.
Thank you. Right, so we're gonna move now to the third presentation, which the paper is exploiting contrastive learning and numerical evidence for confusing legal judgment prediction. Do we have any of the authors here?
Yeah.
Cool, all right. Can you share your screen?
Yes. Hello, can you see the screen?
Yes, we can see your screen. You can start the presentation. You have 5 minutes. All right.
Okay.
Thank you.
Hello, everyone. My name is Gan Lele, a research fellow from the College of Software Technology at Zhejiang University, China. I will present our work entitled Exploiting Constructive Learning and Numerical Evidence for Confusing Legal Judgment Prediction. Legal judgment prediction is one of the most attractive research topics among legal artificial intelligence, as shown in Figure 1. Given the fact description test of a legal case, legal judgment prediction aims to predict its charge, applicable law article, and term of penalty. One core problem hiding the performance of LGP from being satisfying is confusing legal cases. Will have subtle tests or number difference, but with totally different charges, applicable law articles, or terms of penalty. Figure 2 shows 2 examples of confusing legal cases. Figure 2A shows an example whose golden charge label is crime of picking a quarrel, which is easily classified into its confusing charge, crime of intention injury. Figure 2B shows an erroneous prediction of the term of penalty, which does not exploit the amounts related to the crime. To tackle these issues, we present a framework that leverages numerical evidence and moment contrast-based supervised contrastive learning for confusing LGP, as shown in Figure 3. Firstly, the framework proposed to extract numerical evidence, the total crime amount, from the fact description as a named entity recognition task for predicting the term of the penalty, where the recognized numbers make up the total crime amount. Then the extracted numerical evidence is infused into the term of penalty prediction model, while preserving its numeracy, which is achieved by a pre-trained number encoder model. Secondly, in order to pull factor representations from the same class closer and push apart factor representations from confusing charges, the framework introduces the moment contrast-based supervised contrastive learning and explores the best strategy to construct positive examples pairs to benefit all 3 subtasks of LGP. To evaluate the effectiveness of the proposed framework, we conduct experiments on the CAIL small and CAIL bigger datasets from table 2 and table 1 and table 2. We can conclude the proposed framework can improve all the baselines and achieve new state-of-the-art results on the 2 datasets. To examine the effect of the numerical evidence for predicting the term of penalty, we conduct ablative experiments as shown in table 3. The improvement of MoCo-based SL only is relatively tiny on number-sensitive legal cases. However, when the models are further provided with the extracted numerical evidence, the FE scores of all the baselines have a considerable boost. We also conduct experiments to validate the effect of contrastive learning for predicting charges, particularly confusing charges. As shown in Table 4, the absolute FE scores improvement of confusing charges are greater than those of the overall charges, which demonstrates the effectiveness of the MoCA-based LSL in learning distinguishable representations for confusing charges. To summarize, we propose to extract numerical evidence from the factor description as a named entity recognition task for predicting the term of penalty. We introduce the moment contrast-based supervised contrast learning and explores the best strategy to construct a positive example pairs to benefit all three subtasks of LGP. Extensive experiments on two real-world datasets demonstrate that the proposed framework achieves new state-of-the-art results. Ablation studies also demonstrate the effectiveness of each component of the framework. Thanks for your listening.
Thank you, Lele.
Thank you.
Okay, so moving to the next presentation, which is multi-defendant legal judgment prediction via hierarchical reasoning, and we have the presenter in person. Yeah.
Share my screen.
Share your screen, yeah.
Okay. Okay. Hi everyone, I'm Yougong Lu from Shannon University. It's my great honor to be invited to present here. Today I will talk about I will talk our EMNLP findings paper, multi-defendant legal judgment prediction while hierarchical reasoning. In this work, we collect a real-world multi-defendant legal judgment prediction dataset and propose a hierarchical reasoning network to distinguish different judgment results among various defendants. Now, let's talk about the multi-defendant LGP task. Here is an example. The input of multi-defendant LGP task is a multi-defendant fact description, and the output are relevant law articles, charges, and terms of penalty. And next, let's move on to discuss the challenges. The first one is that the lack of real-world multi-defendant LGP datasets. Most LGP datasets only return single defendant cases, and on the other hand, the MAMD with multiple defendants is not public available. The second challenge is that indistinguishable judgment results among various defendants, as shown in the left figure. Since complex interactions exhibit among various defendants and fact descriptions of different defendants are mixed together, it is hard to distinguish different judgment results. Next, I will introduce our method. To better address these challenges, we draw on judgment process from human judge and formulate as a hierarchical reasoning chain. Specifically, in order to distinguish different judgment results between among various defendants, a judge has to clarify criminal relationship. The criminal relationship is used to determine whether defendants share same law articles and charges. For example, defendant B helped defendant A, so the defendant B has the same law articles and charges as the defendant A, and then the judge has to determine the circumstances the sentencing circumstances affect the terms of penalty. For example, the defendant C has the confession circumstances, so the defendant C will get a lighter punishment. And finally, based on these intermediate results, the judge could accurately predict the judgment results. To tackle the first challenge, we collect a real-world multi-defendant LGP dataset. It is characterized by two features. The first one is large amount of data. It contains over 23,000 cases and 80,000 defendants, and the second one is complex cases. On average, there are 3.4 defendants per case and multiple law articles and charges per defendant. And to solve the second challenge, we convert the hierarchical reasoning chains into sequence-to-sequence generation task and applies MT5 to model them. Specifically, the hierarchical reasoning chain are divided into two levels. The first level is to predict criminal relationship and the sentencing circumstances, and the second level chain is to predict and verify the law articles, charges, and terms of penalty using forward prediction and backward verification process. Next, I will present our experimental results. This table shows evaluation of multi-defendant LGP task compared to three types of baseline: single defendant method, pre-trained method, multi-defendant method. Our method ECtHR achieves the best performance for all subtasks. And additionally, we also conduct evaluation study for each reasoning chain. As shown in the figure, the absence of all reasoning chains will decrease the LGP performance. Finally, I will summarize our work. First, we collect a real-world multi-defendant LGP dataset, and second, we propose the method to follow hierarchical reasoning chains to distinguish the judgment for each defendant. And third, we demonstrate the effectiveness of our methods through empirical experiments. For more information, you can scan the following links. Thank you for listening.
Thank you very much. Right, so the next paper is titled Pre-trained Language Models versus Court Ruling Predictions, a case study on a small data set of French Court of Appeal rulings.
Yes, I'm here. I'm remote.
Okay, no problem. Can you share your screen?
Yes.
Okay, Olivia, you have 5 minutes.
Thank you. So hello, everyone. I'm Olivia Rodot, and I'm going to present you our article, Pre-trained Language Model versus Court Ruling Predictions, a case study on a small dataset of French Court of Appeal ruling. It was made in collaboration with informatics, statistics, and law researchers at the Grenoble University. So first of all, the context. We chose to work on a corpus made of French Courts of Appeal rulings about children's habitual residence. So there are three possible outcomes. We took the most simple. The children goes with their mother with the label M, or with their father, label F, or in alternate residence with both parents, so label B for both. So the objective for law professors was to assess whether pre-trained language models, such as Flowbird, Camembert, or Jurybird, deliver on their promises, and the task was to predict the outcome of appeal cases ruling on the residence of children, so with three possible outputs that I said earlier. For the data, we used 987 rulings from French Courts of Appeal about children's habitual residence. And the main issue was that judges' writing is poorly standardized. The text, vocabulary, sentences are complex. And throughout the documents, there are some sentences that reveal the outputs, like little spoilers. So it wasn't possible for us to use the raw documents, and we had to perform a manual annotation of each segment of text by law students who cut the text in 4 parts. First of all, the facts, where the children and parents are introduced, and where the parents said what they want, what is the outcome, what they want as an outcome. Then we have the judgment under appeal. This is not the final decision of the ruling. This is the first judgment made in the lower court. Then we have the reasons, which are the arguments of the judge. He explains why he is going to make his decision. And finally, the decision. This is a part of the text, and the law students used it to determine the output label. And so the rest of the text is irrelevant. As a method, we made some baselines with 5 classifiers: multinomial naive Bayes, a key nearest neighbors, a support vector machine, some forest of decision trees, and a multi-layer perception. And we vectorized the text using bag of n-grams, weighted or not by TF-EDF. Then we chose to use some language models. So first of all, 2 generic French language models, Flaubert and Camembert, which are based on BERT. And French language models specific to legal documents, which is jury-BERT, still based on BERT. We split the text in chunks to avoid the limitation of 512 tokens. And we use some by LSTM to obtain the fixed pi vector for the whole document, because every document doesn't have the same amount of chunks. As I said earlier, we didn't use the whole text, and the classifiers were trained on facts plus reason, then facts plus reason plus judgment, then only the decision, and finally decision plus judgment. For the results, for the baseline, we chose to kept the best feature-based classifier. So we can see it's almost always the MLP with bag of trigrams without TF-EDF, except for facts plus reason, where this is the MNB with bag of unigrams without TF-EDF was the best. Then we remark that for the facts plus reason and facts plus reason plus judgment, the best feature-based classifier beats all language models, but still performs poorly. We can see that the accuracy goes no higher than 57%. But for the parts decision and decision plus judgment, the classifiers have no difficulty reading over the decision and inferring the label. We can see that the accuracy is often over 90%. So to conclude, we can see with this experiment that unstandardized dataset still resist pre-trained language models, because we can see that the text is difficult. It requires a specific analysis. Then viewers part of, we can see that reading the explicit decision is easy, as they perform better with decision and decision plus judgment. And we can see that it requires some form of reasoning. We made, in addition, a control experiment to see the human performance on the task. And our accuracy was higher than 90% versus 60% for pre-trained language model, as I showed you. Thanks for your attention.
All right, so the next presentation is on legal judgment prediction. If you're going to do it right. Do we have any of the authors?
Yes, so we're both online.
Okay,
yeah.
No problem. Marsha, you can start presenting. You have 5 minutes. Thank you.
Great. I was sharing the screen, yes. So for our work, we surveyed 171 legal judgment prediction papers from the past 10 years. And while we made report really high scores, there's even 100% there, we witnessed a very sad picture. So let's look at the data that most of the models are trained and most importantly tested on. Almost everyone either uses full judgments or so-called case facts that are often part of datasets such as LEXTREME, KO 2018, CGPE, and other abbreviations. But this approach, also reflected in today's presentations, is a really big problem. These facts are almost always extracted from judgments that already have a verdict. We tend to think about case facts as something indisputable, something that is the same for everyone, but really there's no such thing in legal proceedings. The facts in a judgment had to be established by the court. Most times the reason that people end up in the court in the first place is that they have different facts. They would like to dispute the facts of the opposing party. The facts that we see in published judgments are written after the decision is made. They're selected and edited to fit the final decision. Because a court judgment is really just a story that a judge writes to explain their decision. These facts do not exist before the judgment is made. They're not available to anyone who would actually want to predict a decision of a case that doesn't have a decision yet. And being tested on the data that is not available to the potential user, the models are only able to predict what the decision was rather than what the decision will be. But if you want to know what the decision was, you could just check the judgment. So there's absolutely no clear utility to these models when it comes to actually predicting court decisions. Unfortunately, out of all the papers that we reviewed, we found that only 12, approximately 7%, use the data that is available prior to decision-making. They use submissions by the parties, legal brief, complaint documents, and other information that is available prior to decision-making. But as we can see, they don't report nearly as high scores. And the rest of the papers simply do not do legal judgment prediction, even if they claim that they do.
Doing legal judgment prediction wrong has real-world consequences. It feeds into AI hype. It encourages policymakers to believe that legal judgment prediction is a solved or nearly solved task, and that these systems are ready for use in the wild. It means that claims that these systems have utility in the sense of enabling prediction of future judgment are false and misleading. Using appropriate data is the crucial first step in doing legal judgment prediction right. Doing legal judgment prediction right is about more than using appropriate data, however. For example, it means not only recognizing that explainability matters, but that the right kind of explainability matters. For many users, if an explanation is to be useful, it will have to explain the prediction in terms of the relevant legal rules. And it will not be sufficient to evaluate these explanations according to metrics like blue and rouge. They will have to be evaluated according to whether they are in line with the relevant law and respect conventions of legal reasoning. In fact, the key to doing it right, we suggest, is an application-centric approach to evaluation. This approach, suggested by Hutchinson and others, applies to researchers as much as to developers. An application-centric approach implies a keen focus on the class of user, for example, judges, lawyers, or citizens, their use case, and the context of use. It focuses attention on how the system may have utility for those users. What kinds of explanations, if any, should be output by the system? What good data is available? What data should be used to test the system, and the wider implications of use? Today, we are a long way from building systems that could do a good job of predicting future judgments. We want to advocate for better research in the field and hope that our recommendations seen here will contribute to doing legal judgment prediction right. Thank you.
Right, so we're running a little bit late, but we reached the last presentation of this session. The the last presentation title is Extracting Sentencing Related Factors from Criminal Cases in Hebrew. Do you have any of the authors here? Okay, yeah, we have
Yeah.
the screen being shared online. Excellent. Then you have 5 minutes, all right?
All right. Can you see the slides?
Yeah, all good.
Okay. So hello, my name is Dean. Today I'll be presenting the study Extracting Sentencing Related Factor from Criminal Cases in Hebrew, along with my colleagues from Ben-Gurion University. This research is supported by the Israeli Ministry of Justice. Let's start with the motivation for the research problem. When attorneys are asked to propose an appropriate punishment for a new case, they should find verdicts with similar features and propose a similar punishment. Today, the search for similar features between the verdict is done manually. Let's focus on the manual search. As part of identifying similar characters between the cases for just the punishment, the attorneys must delve into the details for each cases, a process that may take a long time. Let's look at an example of information that can be extracted from the text. This sentence contains information about the weapon carried by the accused, and this contains information about the weapon bought by the accused. The attorneys use this information to determine the severity of the punishment. Following manual extraction problem of the attorneys, our research question is how to extract significant sentences for determining the punishment for cases. We base our approach on several lines in related work, like information extraction. A main study was extend name entity recognition to entities from legal domain. The second was the few shot learning and study related to pre-trained model like model trained on Hebrew, multilingual, and model that were fine-tuned to specific domain. When choosing our approach, we had to take into account the following constraints. Explainable result. The result should be explainable to the attorneys in order to establish the determination of the punishment. These constraints lead to determination of many labels, which lead to difficulty in tagging large amount of data. The last challenge is choosing the language model because the Hebrew language is limited resources and language model. Following to this constraint, we apply the following methodology. First, we determine 2 levels of labels with guidance of attorneys. Then we implement hierarchical binary classifiers. If a sentence is classified into specific category in first level like offense, it's move on to second classifier to more granularity labels like weapon trade. The hierarchical models enable the solution of a simpler task. To deal with limited data, the second constraint, like I mentioned before, we use the set-fit few-shot framework, which leverage contrastive learning to increase number of samples. In the results section, I will present the agreement in the labeling of the sentences, the performance of the different language model on which we are based, and the performance of hierarchical models. This table display intercoder reliability measured by Cohen's kappa at the first level classification. The table compares experts, the attorneys, and non-experts, our research assistants. As we can see, even among experts, complete agreement is challenging. It can be seen that our research assistants, with the help of our coding scheme, reach a high level of agreement, even though they are not related to the word of law. In our sentence classification task, we test 3 types of language model. Firstly, the multilingual BERT. Secondly, model adapted specific to Hebrew. And lastly, model is legal Hebrew, the model that fine-tuned to specific domain. The table shows that there is no significant difference among these models. Surprisingly, the legal model performed the least well compared to the other language model. A possible reason for this is that we use few-shot learning that not require a deep understanding of the language. The comparison between the hierarchical model to direct second classification, it can be seen that the hierarchical model in orange column outperform the direct model. To summarize, our research contributes coding scheme that enable non-legal experts to tag in relevant sentence with high agreement. Additionally, we implement a successful few-shot model to extract significant aspects from verdicts. In our next steps, we will extract feature from the classified sentence,
for example, the specific type of weapon. And when each case have a set of features, we will be able to implement a retrieval system case. Thank you very much.
Thank you. Well, it was 10 seconds early, but actually the session is running 15 minutes late. How did I manage that? Right, so let's take questions offline if possible, and move straight to the next session, chaired by Leslie. Thank you. Let's thank the authors again.
Hi, everybody. Welcome to the next session. Give me 1 second. Okay, so our first paper in the second half of the set of presentations. Just to remind you guys, don't go away at the end of this. We do have the best presentation awards, so that's going to be pretty fun. So our next paper is going to be Do Language Models Learn About Legal Entity Types During Pre-Training? Do we have the presenters for that? It looks like we do. So take it away. You have 5 minutes.
Okay, so hi everyone, I'm Claire Barale. I'm a PhD student at the University of Edinburgh. So this work is a language model probing task applied to legal NLP. So the first idea for this was to explore if language models do capture any kind of legal knowledge that we could later use as a source of weak or indirect supervision in place of fully annotated datasets. So we know that language models of all sorts learn the probability distribution of a language, but some research papers have made the hypothesis that incidentally during training, they also memorize some semantic, linguistic, and factual knowledge. Second, it has been demonstrated that domain-specific and task-specific pre-training improve models' performance and adaptability. On the other hand, language modeling and NLP and legal NLP are reliant on high quality and recently updated annotated datasets. So if this assumption is even partially true, and if language models do memorize some sort of knowledge, then we could leverage this for downstream tasks. So the idea of this work is to understand to what extent this is true, if true at all, and what types of signals do language models learn during pre-training, in particular semantic or syntactic signals. So for this, we propose 2 experiments around the task of entity typing. So for both experiments, we act in a closed set, and we provide the list of possible entity types, such as a location or date, making it a multiple choice QA task. So we ask the model to predict the entity type and not the entity itself. So for example, if the prompt sentence is the appellant has spent the last 2 years in mask token, something, we expect the model to know that the only type of entity that would make sense grammatically is a location. So for the first experiment on the left of the slide, we mask the entity in a sentence. And for the second experiment on the right-hand side, we provide an entity extracted from our legal dataset, and we ask directly the model to predict the entity type. So one experiment is in the context of a sentence, and one experiment does not provide context at all. So the first experiment is performed on only BERT-based models, including models that are pre-trained on legal corpora. And the second experiment uses Llama 2. So here we present the results. So we aggregated the categories of entity in 3 categories. So first, the entities that are very generic and that you can find in any sort of text, such as locations or date. Second, the entities that are common to most legal domains, such as legal citations or evidence. And finally, the entities that are more specific to the dataset that we used here, which is in the dataset in refugee law. So you find things like NGO report citations. So it is not surprising that both experiments with both type of models struggle to find entity types for specific refugee law entities. On the mass language modeling objective, we obtain best result with the case hold and the pile of law models, which are both pre-trained on legal text. And seeing that we obtain similar accuracy with both generic and generic legal entities, it does confirm that the domain of pre-training is very important here. On the second experiment with Llama 2, the result also makes sense because it performs better on the more generic and common entity types. So I think the most interesting part was to conduct an error analysis on the cases where the language models fail. So we systematically analyzed the errors made and we categorized them. So one thing we wanted to see with the BERT-based models is if the model was maybe a little confused by the sentence because of the lack of context, but could predict an entity that would still grammatically make sense. And we find that this is 13% of the errors. On the second experiment with Llama 2, most errors are due to the model not precisely following the instruction. So for example, it would not pick up an entity type from the predefined list of entities that we give, but it would make one up that could be relevant, but that was not from the list. And the second way forward is probably to improve the prompt templates. So we do find that pre-training corpus is important, but also that the length of the entity used as input, which can be like multi-token, does not make a significant difference in the performance of the retrieval. We also find that BERT-based models seem to pick up some syntactic signals that Llama 2 fails at this. So to come back to the initial question, could we use the signals as a source of supervision for further training? I would say that it is promising on some entities if you can pick up the right model, pre-trained on the right corpus. But that it does require further work to improve the information retrieval step. Thank you for your attention.
Okay, our next paper is questions about contract prompt templates for structured answer generation. Are those folks in the room?
Yeah, I'm here. Hi there.
Oh, you're online. Okay, great. Take it away. You have 5 minutes.
Thank you. So hi everyone, I am Radha Chitta. I'm a researcher at Zuva. And over the next 5 minutes, I'm going to try and answer the question, can we use LLMs to extract structured data from contracts? So let's dive in. Oops, yeah. So let's imagine you're a tenant and you found some mold in your property and you're trying to find out if you're responsible for paying up for those damages or your landlord is. What you or your lawyer would do is go into your lease agreement here and pull out a clause called environmental indemnity, and therein would lie your answer. This is fairly easy to do if you have one or two contracts, but most businesses and law firms are looking at hundreds and thousands of contracts. So we need to do this at scale. So we wanted to see if LLMs can be used to do this at scale. We started with ChatGPT. So we basically typed in this clause and asked who indemnifies whom, the tenant or the landlord. So each time we ran it with a couple of times with the same clause and the same question, but each time we got a different response. So these two are two example responses that we got. Both are correct, mind you, but they're pretty different from each other. So they're inconsistent and so not very easy to evaluate. And there's no way we can actually build an actionable automation around this. So chat paradigm really won't work on a large scale. What we really want is a structured response like this, maybe a multiple choice where you have options A, B, and C, and you want the model to tell you which option it is. Based on that, you can build up some automations. So our first task was to see if we could build a prompt to give us just that. And we went through hundreds of prompt styles and hundreds of prompts with different classes. And we finally arrived at a few conclusions. If we ask the model to only select the lettered option and not provide any other information or justification, in most cases, they do give us structured responses. They do even better if we ask the model to pretend to be a party to the legal agreement and even give specific information about what clause it's looking at. In this case, it's environmental indemnity. So these question-specific prompts did pretty well. We tested it out on 4 questions, 4 different types of questions, and lots of hundreds of clauses, and with 4 large language models, and we got accuracies in the high 80s and 90s. So that's pretty decent. The only caveat there is these are pretty sensitive prompts. You change the wording a little bit here and there, and it could significantly affect your results. So these question-specific prompts, though perform pretty well, are pretty cumbersome and not very reliable. So we would try, and our next task was to see if we could templatize these prompts. So we built a fill-in-the-blank style prompt template from the second prompt here. So the user would have to just fill in the clause name, the clause, and the options. So, and instead of specific questions such as who indemnifies whom, they would ask a question, generic question like which of the following is true. So this makes it easy to apply to multiple types of questions, multiple types of clauses, and we only need to engineer the options. So we ran these prompt templates also on the same clauses and the same questions, and though they did not perform as well as the question-specific prompts, they were pretty close and they were more consistent. So the 2 key takeaways from our work. So with most instruction-based LLMs, which I run the GPT 3.5, Turbo, GPT-4, PaLM-2, Llama 2, 13 billion model, it is possible to obtain reasonable accuracy and to obtain structured answers. And then the second key takeaway is we can also construct generalized prompt templates, which will do almost as well as question-specific prompts. Thank you for listening. Please take a look at our paper when you get a chance, and I'm happy to answer any questions later. Thank you very much.
Thank you, Radha. We're going to do questions at the end in about 15 minutes. Thanks so much. Our next paper is Resolving Legalese, a multilingual exploration of negation scope resolution in legal documents. Do we have the authors? Authors are online. Okay, fantastic. Go ahead when you're ready. You have 5 minutes.
Hello, everyone. I'm Ramona Christen from the University of Bern, and I'm happy to talk to you about negation scope resolution in the multilingual legal domain. Why do we choose negation? So here you can see an example that BERT, a large language model, still struggles with recognizing the meaning of negation in a sentence. And as you will see later, also ChatGPT still has issues with this task. What is our task? This is negation scope resolution. It consists of 2 parts. The first part is the negation queue. You can see an example here in bold. These are words such as not or no that initiate the negation. And the second and most important part is the negation scope. You can see here in the example, the underlined part, which is all words affected by a negation queue in a sentence. And our goal was to train language models to accurately predict the scope of these negations in sentences. The contributions of our paper are new data sets. We produced new data sets in German, French, and Italian that all include legal data that are annotated for negation queues and scope. We then train and evaluate different language models in negation scope resolutions on our new data set, and we publicly release all the data, our best model, the experimentation code, as well as the annotation guidelines. Here's a quick overview of the data we produced. You can see the top rows there are our new data sets in French, Italian, and German. They all consist of court decisions, and you can see the bottom rows there are existing data sets. These are all in French or English, and none of them are in the legal domain. Our data sets are available on Hugging Face. On to the experiments, we first used ChatGPT with the API to try to get negation scope predictions. And then we used the NEXT architecture, which allows to train language models in negation scope resolutions. There we took different approaches. First, we tried a cross-domain transfer, where we trained on all the external data without any legal data, and did a zero-shot transfer onto our legal data sets. Then we also did cross-lingual experiments, where we trained on the legal data in 2 languages and evaluated on the third. And finally, we also used all available data for the experiment. These results can be reproduced using our pre-trained model, which is on Hugging Face, and also our experimentation code, which you can find on GitHub. And the results you can see here. First, note that ChatGPT is the small gray bar there. As you can see, it did not perform well at all. This is the average over 0, 1, 5, and 10 shot experiments, and it was not successful in any of these tasks. And then you can see our models. We mostly use XLM Roberta and BERT models. And you can see the zero-shot cross-domain transfer, where no legal data was included in the trained data. It's the lowest at between 60 and 70% one score. We were then able to significantly improve this by adding legal data to the training data in the cross-lingual experiments. And finally, the multilingual experiments using all available data, including legal data, yielded the best results overall. Just a very quick error analysis is an example from our cross-domain experiments. We could see that often the models wouldn't recognize the subject as part of the scope, but this should be included as per our annotation guidelines. We were able to improve this by using our legal data to train. In conclusion, we can say that the legal domain does pose a significant challenge for negation scope resolution models, especially if they are not trained on legal data, but we are able to improve these results by using a legal data set to train our models. Even if it's just a small models, we can see that the results significantly improve the performance of these negation scope resolution models. With that, I thank you for your attention. You can find all the resources here, and I would be happy to see you use some of these data. And for questions, you can contact me or also Joel, whose presentation you've seen a couple of times today.
Great, thank you, Ramona. Right on time. Gosh, the three of the last speakers right on time. Thank you. You all are killing it. You're keeping us on schedule. Our next paper is Beyond the Text, Analysis of Privacy Statements through Syntactic and Semantic Role Labeling. We have the presenters online.
I'm right here.
Fantastic.
Hi, everyone.
Take it
Can you
away.
hear me?
You have,
Yep.
We can
Good.
hear you perfectly.
All right,
You have 5
great.
minutes.
Great to be here, and thank you for a wonderful workshop. So, hi everyone, my name is Jan Schwarzenegger, and I'm going to discuss today our work on analyzing privacy statements using syntactic and semantic role labeling. It's collaboration with NYU and Lausanne School of Engineering. So, I hope I don't need to spend too much time on this slide. Hopefully we'll all agree that privacy policies are notoriously lengthy, hard to parse, understand, written with legal lingo, and the list goes on. So there's a lot of work in this community, in particular, looking at ways to help out consumers and whoever uses services to understand their privacy implications of those services in any way possible. So in our work, we taking a bit of a different approach to traditional privacy definitions. We look at contextual integrity, proposed by Hell and Nissenbaum, that defines privacy as an appropriate flow of information. And kind of an intuitive example, given the limited time, consider you going to a doctor's office, sharing your medical data, and with expectation that it's done confidentially. If any of those things change, so if it's not a doctor, it's somebody on the street. If it's not your medical data, it's someone else's. And if it's not confidential, things might not be as pleasant. So you might think something is off and your privacy is potentially violated. So in order to do those kind of analysis, contextual integrity provides us with a framework of five essential parameters, and basically asks to specify explicitly the values for the sender of the information, the subject of information, the recipient of information, the type of information being shared, and the transmission principle, which is the purpose or the condition under which the information is being shared. So having that in mind, we thought it would be it's a good idea to apply this to privacy policy statements and see if we can essentially define a new CI parameter extraction task. Giving a privacy statement, we would like to see whether they specify all five parameters and we were able to identify them, whether they state who as the sender is in this example from Yahoo privacy policies, and information that they share, but whom they share it and under what condition. So in our paper and in our work, we tried a few different methods, off-the-shelf methods, models, sorry, and the paper discussed the results for all of them. A bit of spoiler alert, a lot of them didn't do so well, but a couple of them did provide some promising results, and I'm going to discuss briefly what we did with dependency parsing and semantic role labeling, and in particular, adding some CI-based heuristic to help out to boost some of the results. So for dependency parsing annotations, what we essentially did, we took the output, the dependency types, and the role, the semantic role labeling, so dependency types, and map them to the CI parameters and see whether there will be our rules be effective. And they were. Well, I'll show you the results shortly. But beyond that, we wanted to see whether something like semantic role labeling, which tries to actually look beyond I'm missing the word, sentence depends basically beyond the types into something that triggers semantic frame, essentially a meaning of the sentence by looking at the verbs and predicates of the sentence and seeing how the arguments associated with it map to something like an agent, purpose of a goal. So for example, if the semantic frame triggered by a verb collect, there is an agent that collects something, and there's something that's being collected, and so forth. So having those output from a model, SRL model, those arguments, we map them again to CI parameters. And by choosing particular types of verbs that essentially indicate something being sent or shared or being received in terms of information, and essentially trying to see if that will help us find the CI, extract the CI parameters. Right, so briefly, and again, the paper gives you much more detailed results. The dependency parsing performed okay. Was promising, so we wanted to go further. SRL gave us much better result, and then we introduced, and it's kind of the takeaway really, that we introduced some CI domain-specific knowledge to help with a bit of a heuristic to help boost some of the SRL results, and that helped a bit, as we discussed in the paper. Note that SRL was not able to detect subject in our work. We analyzed 50 privacy policies from the OPP 115 dataset, and overall, it's again very promising. That shows that quite a few policies reached a high F1 score. But we also discussed the limitation that some of the method doesn't work on all privacy statements, and there's something that obviously can be done to improve it. Some conclusions, we trying to introduce a new NLP task that is based on CI parameter extraction, and we looked at several conventional NLP models that provide us with some result, but we also discovered that they cannot perform this task can be performed trivially. You need something else, and introducing CI based domain specific knowledge helped us boost those results, and we believe that's kind of where this will go. You will need this type of intervention to help us ensure that you get a high accuracy in those models. And what we're really trying to do is build systems that meet users' privacy expectations by construction. And we hope this work will get, getting one step towards that. I'll stop here. Thank you so much, and looking forward to your questions.
Great, thank you so much. We're going to take questions at the end. Our next paper is Connecting Symbolic Statutory Reasoning with Legal Information Extraction. Looks like the authors are online. Okay, ready to go?
Yep. Hi, can everybody hear me?
Yes, we can hear you. Thank
Okay,
you very
great.
much. You have 5 minutes.
All right. Okay, so hello, everyone. So the title of my paper is Connecting Symbolic Statutory Reasoning with Legal Information Extraction. So there are two, in that title, there are two tasks. One is statutory reasoning, the other one is information extraction. And the thing that connects both of these is law as code in this context. So here, the main idea I want to keep from law as code is the idea that laws, which are normally represented with natural language, should be represented with some form of computer code. And that's something that has been done historically in certain contexts. So, for example, some governments in the world curate expert systems to compute the taxes of their taxpayers. So the idea is that
You can collapse that window, by the way. I know it's in the way.
Oh yeah, right. Okay. The idea is that lawyers and computer scientists will produce some expert system that represents the tax code, and then taxpayers will enter their own information into that system, and then the correct tax amount will come out. But then in that setting, there's one thing that's missing, which is that taxpayers have to enter things in the language of the expert system. So we're missing that part where the situation of the taxpayer that's best described in natural language is translated into structured information that's differently expressed in computer code. And so this is a natural language processing task here, translating this natural language here to this computer code. So to work on this task, we used the SARA dataset. So that dataset is made for a different task, but we're recasting it for information extraction. So it contains 9 abbreviated sections from US tax law. And then it also has a set of cases that were handwritten, so they're not real cases. And those cases all relate to these 9 sections. And what's interesting in this data set is that there is a translation of the statutes into Prolog and of the cases, of each case into Prolog. So just to reiterate this, so there's statutes and cases, and then each of these has a translation into Prolog. And what some governments have done historically is this top arrow. They've done this translation themselves. And then we're interested here in trying to perform this translation at the bottom automatically. And so that's a form of legal information extraction. So we did this in 2 steps. The first one was to re-annotate the SARA dataset to make the Prolog knowledge bases more user-friendly for IE systems. So this was done in 2 steps. The first one was to link the elements in the knowledge base to some anchor in the text. And then the second thing was to make the use of the ontology more consistent. The second contribution in this paper are models that we developed for legal IE. So at a higher level, they're span-based parsers that incrementally segment the input text and then type each segment. And as part of that, we've tried out different pre-trained encoders. So here are some of our results. So we tried out 5 different pre-trained encoders. Some of them have been pre-trained on the legal domain. So that's the case for the last two models here on the right. And those two also happen to have the highest performance on information extraction. So legal domain pre-training matters in that context. Another interesting thing is that both of these models on the right here were started from BERT and then were continuously trained on legal data. But they achieved quite different performance in the end. So it seems that it also matters what kind of legal data these models are then further trained on. Right. So to summarize the contributions here, we've extended the SARA dataset for legal information extraction, and we've reached some really promising performance on just this small dataset, and with a fairly strict metric. And then one thing I didn't clearly state here, but which you can find in the paper, is that the performance that we reached in information extraction also correlated with performance that we achieved in statutory reasoning, which is the original task that the SARA dataset was designed for. Right, thank you very much, and I'll be happy to take your questions later on afterwards.
Fantastic, thank you. Okay, so our next paper is automatic anonymization of Swiss Federal Supreme Court rulings. Joel, come on back.
It works anyway now. Hello, happy to present our paper on anonymization of Swiss Supreme Court rulings. So why do we do this? Releasing court decisions to the public relies on proper anonymization, at least in Switzerland, to protect the involved parties. So far, the Swiss Federal Supreme Court relies on an existing system with regular expressions, and then uses human experts to finalize the anonymization. So if we can improve this system, we can save a lot of human resources that can be deployed elsewhere. So what we did is we enhanced the existing anonymization software by using this large data set annotated with entities that need to be anonymized. So we also compared BERT-based models with models pre-trained in-domain on legal data. And we show that using this in-domain data to pre-train models further, we can improve the F1 score by more than 5%. So to have a look at the data set, we have a trilingual data set of Swiss Supreme Court rulings that are between a few hundreds to a few thousand tokens long, usually, that they each contain between 10 and 1,000 anonymized tokens. And yeah, many entities, many different entities we have there, and also a lot of different anonymized entities. So the results show, especially in the multilingual setting, that we improve quite a lot by using in-domain pre-training, especially if we pre-train on the Swiss data sets only, a bit less so if we pre-train multilingually. For the monolingual results, we don't see as large improvements. To conclude, we combine existing anonymization methods, such as regular expressions, with machine learning. And like this, we can further use manual labor and enhance the automatic suggestions that the Supreme Court gives to the manual labeler before the decisions are released openly to the public. In the future, I think we could improve this system further by improving the sentence splitting part, because we saw some errors that were still occurring there. As well, so far we only trained the base size models because of the limited infrastructure in terms of GPU compute inside the Supreme Court. So extending this to larger models could also be beneficial. Thank you.
Okay, very good. Thank you, Joel. Our next paper is can ChatGPT perform reasoning using the IRAC method in analyzing legal scenarios like a lawyer?
Good afternoon, everyone. My name is Xiaoxi, and today I'm presenting our work can ChatGPT perform a reasoning using the IRAC method in analyzing the legal scenarios like a lawyer. So this research is done by the Monash University. So the main findings for this paper is that ChatGPTs can achieve around like 0.49 F1 score in the general like legal scenarios questions. And also it can be improved by adding the intermediate reasoning paths and adding the similar examples and also the decomposing legal questions. So the IRAC analysis is one of the main methodology that used by the lawyers. They identify for the legal issues, rules, and the application. And this part actually is the main part of the legal reasoning skills are truly tested. And also then the final thing is the conclusion. So in order to do this kind of research, we know that in the current like market, there is no like kind of like full like IRAC analysis data. So we construct the data by ourselves. Like we have the data from the Contract Law Malaysia and the Australia Social Act, and which is a full like IRAC analysis, which the issue, rule, and the analysis and the conclusion by the annotators. So after we create the data, we do the assessment like by using the scenarios like we created, assessment by the ChatGPT, which we ask the general conclusion, which is the correctness, fluency, the rule which is identified by the information relevance, and also the correctness of the concept identification. We also ask the annotators to identify the assumptions made by ChatGPT, which are how many assumptions that are made, and how many are correct assumptions that identified by the ChatGPT. And also it's like we found out that even though sometimes ChatGPT identifies some of the legal concepts correctly, but they didn't discuss correctly. So that's why we also have these factors to ask the annotators to evaluate if the legal concept is discussed correctly. So from our result, we have the performance of the general, like the scenarios correctness is like the performance are best in the Australia Social Act, which can achieve for the 0.79. And the average of the overall data set we are trying is like 0.49. So we found that in general of the conclusion, based on the conclusion, there are still a lot of room to improve for the following steps. So that's why we have the experiment by adding some the rules or like more information in the prompt. So we found that there are some improvement, but they still have very poor performance on the articulation of the reasoning. So the formulation of the analysis from ChatGPT is sometimes very confusing and logically inconsistent based on our annotators' feedback. And then we tried on adding some reasoning paths into the prompt. So because we have the ground truth of the from the annotators, so we pass by some reasoning paths in the middle in the prompt. So then we found out by adding 20%, 40%, and 50%, even 100%, actually the result is getting better and better. So this can prove that by adding on the reasoning paths in the intermediate steps actually can help ChatGPT to answer the legal questions better. So hence we have also done the experiment on the adding the similar examples. So from to give the ChatGPT with we call it like in-context learning. So from this result, we find that actually the analysis can improve a lot by 50% by giving the scenarios after adding the examples. So especially on Australia Social Act, because the Australia Social Act, we are using simpler scenarios. However, for the Malaysia contract law, because the source of the scenario is coming from the exam questions and the tutorial questions, which is very complex. So even though by adding the similar examples, the answer are still not expected as better as the Australia Social Act. So hence we done another experiment on by adding more like decomposed question, which is the smaller issues. This is a kind of like critical task for a lawyer as well. They have to identify for the smaller issues in order to do the full analysis. So we can see that there are very big improvement on that by adding the decomposed question. The results shows that not only they can identify the legal concept, and they also can analyze well. Because as we all know that ChatGPT, especially answering the small questions, they actually can do it better. So the more specific questions that we ask, the better result we can gain. So in conclusion, that the data set we construct, which we call CREC, is a comprehensive error analysis for the legal scenarios. And also the performance of ChatGPT can be improved by providing parts of the reasoning paths and also in context learning and the decomposed question. So this will be our future work. And so thank you. That's all for my presentation. Thank you.
Okay, thank you so much. So we now are up to our last paper, information extraction from legal wills. How well does GPT-4 do? And we have that one in person. Come on up.
Hello, everyone. Finally, I'm the last presenter of today's workshop. Yay. So my name is Alice Kwok, and I'm going to present a paper titled Information Extraction from Legal Wills. How well does GPT-4 do? So, yes. So information extraction from legal wills is highly practical because it can serve as foundation for many downstream tasks, such as automatic will review or electronic will creation or execution. And it is also an important evaluation platform for large language models, such as GPT-4. So in our paper to facilitate studies in these fields, we introduced a manually annotated data set for information extraction from legal wills. And the data set consists of 16,000 annotations of entities, relations, and events from 45 legal wills from 2 United States, Tennessee and Idaho. And we also evaluated GPT-4 with in-context learning on our dataset in both in-domain and out-of-domain settings. So I'll briefly explain how our dataset was created. So we collected wills from Ancestry, and we collected 45 wills from 2 United States. And the wills execution dates ranged from 1978 to 2001. And all the collected wills were manually anonymized prior to the annotation process. And the annotation was done by 2 annotators, and the inter-annotator agreement score was 74%. And we annotated 26 types of entities, 18 types of binary relations, 20 types of binary events, and that resulted in 16,000 annotations in total. So the figure here shows a brief example of our annotation. And as you can see, like even in this small will statement, these large amount of entities, relations, and events were extracted. And we also evaluated GPT-4 on the information extraction from legal wills using our dataset. And it was done in in-context learning setting, which means that the model was only given a prompt with a few examples without any fine-tuning. And in the evaluation, we restricted the range of tasks to reduce the complexity. So the model was asked to extract 4 most common entities: testator, beneficiary, asset, and will. And the 4 most common relations: testator to beneficiary, testator to asset, beneficiary to asset and then testator to will. And prior to the evaluation, dataset was split into 4 sets: training, development, test, and out-of-domain data. And training data was used as an example pool for developing a prompt, and development was used to optimize the prompts. And we used tests and out-of-domain set for the evaluation. And with the prompts and these testing datasets, we produced a output using GPT-4, and these outputs were compared with the human annotators' annotations. So here's our results. So we report precision, recall, and F1 scores, and the numbers in the parentheses are our confidence interval, which was created from resampling technique. And the scores show that GPT-4 handles the legal information extraction task reasonably well. And we can see that by F1 scores ranging from approximately 67 to 83. And it was also noticeable that GPT-4 performs equally well, or sometimes even better, on the out-of-domain data. And this means that the prompts created from our training partition can be transferred and used to extract information from out-of-domain data, which are legal wills from the United States other than Tennessee. And even though it is working okay, there are still a lot of room to improve. So we did some error analysis to find out how we can improve our system. And as a result of error analysis, we found 2 major issues of GPT-4. And one of the issue was that the result is inconsistent. And what we mean by that is GPT-4 is not capable of setting consistent criteria from the information given in the prompt. For example, it was not consistent whether to include positive pronouns, quantifiers as part of the entity or not, or whether to divide a list of entities into multiple small entities, or just to include whole list as a single entity. So there were some differences there. And another issue was that it sometimes overgeneralizes the prompt and produces false results because of that. So there were many cases where GPT-4 forcibly extracts human entities such as co-executor as beneficiaries, which is really wrong. And sometimes it also extracted money-related assets, entities such as tax, expenses, debts as assets. And there were also cases where document-related entities such as statutory sections as wills. And this behavior was not observed when we didn't give any prompt to GPT-4. So it seems like this is happening because of overgeneralizing the prompts. So the conclusion is that our main contribution of this paper is introducing a manually annotated legal information extraction dataset, which consists of 16,000 annotations from 45 legal wills. And we also annotated many entity types, relation types, and 20 events types. And you can find this information in our paper. And the dataset that we created can serve as a foundation for several downstream tests concerning legal wills. And also it can serve as an evaluation platform for large language models on information extraction tasks. And we also evaluated GPT-4 on the legal information extraction task with our dataset. And we found out that the model can handle the task reasonably well. And it was also found out that the model performs equally well, or sometimes even better, on the out-of-domain data. And we also found out that as a result of error analysis, there's 2 major issues of the GPT-4, which are inconsistency and prompt overgeneralization. So our conclusion is that further investigation is needed to mitigate these issues and enhance the performance of the model in in-context learning setting. So that was it, and thank you so much for your attention.
Fabulous, thank you. Now it does turn out we have one more paper because unfortunately somebody was skipped earlier. So assuming Santosh is in the room, I'm going to leave you with the last paper, ECtHR-PCR, a dataset for precedent understanding and prior case retrieval in the European Court of Human Rights.
So I'm Santosh, and this is a joint work along with Rashid and Matthias, where we work on ECtHR creating a new prior case retrieval dataset for European Court of Human Rights. While today's presentation has advocated for how to do LJP legal judgment prediction right, we advocate for doing PCR the right way. The ideal task of PCR is to identify important prior cases, whereas in common law jurisdictions, people rely on existing case decisions that form a vital source of law. So there's a growing demand to have better PCR systems. The problem with existing common law datasets such as COLI or IRLED is the query comprises of both facts and the reasoning sections, where they only just suppress the citation text, which boils down to just doing exact text matching because it's more prominent that people verbatimly quote the citations as a part of reasoning section. And they also create artificially pooled candidates as negative pool. So that may not really reflect the realistic setting. So we present an actual interesting scenario of a PCR dataset extracted from European Court of Human Rights, whose case law documents themselves give the leverage to separate or segregate facts from the arguments so that we can only use fact section to do an effective prior case retrieval, so that we ensure the queries which we use for PCR do not contain any kind of argumentation or verbatim quotations present. So we create a ECtHR-PCR dataset by scraping the WHODoc website, by parsing them and extracting citations with various regexes. And we obtain a 15,000 document set, which we chronologically split into training, validation, and test set. This is a brief statistics we find of different datasets, common law datasets such as IRLED and COLI and our dataset, which we presented, which has a larger negative pool, creating an realistic setting of PCR dataset. Then we tried different models, BM25 and other bi-encoder models with different types of negative sampling, starting from random negatives, BM25 based negatives, mix of both of them, and a specific type of negatives such as ANSI and SIMANS, where the idea of ANSI is use model itself to identify your top k negatives, whereas the idea of SIMANS is can you find the neighborhood of a positive and then use them as negatives. And these are the traditional information retrieval metrics we use to employ it. Surprisingly, dense models has just surpassed BM25 by very niche margins. But even surprisingly, if you observe recall at 500, which means giving even 500 documents as a first step retriever method, it's only about to only pick up 50% of documents, which means current IR models are really far from understanding just at a textual level what is relevant just based on facts. Similarly, even with other negative samplings, things don't improve well, with only minor improvements with using different types of negatives across the board. So the other issue which I want to bring out is the BM25 has a better temporal robustness compared to dense models. If you observe the lower part, the dense models with time deteriorate over, which says the models do not really have temporal distributional shift effectiveness because of the training and testing data distribution. That means the dense models are not really temporally robust and temporally misaligned. So future retrieval models should adaptively adapt over time so that they can create better PCR systems which evolve over time. So the future work should not only rely just on text, it also needs to leverage citation network to leverage impact factor on influence of a case, because some cases set a precedence which will go for years or which gets or reflects more citations. And we also need to evaluate dynamic evaluation of law, because law is never static and it's dynamic. And we need to deduce the reasoning process to understand why a document is even cited, or to understand the reasoning or explainability between such sentences. So given the last session, I'll take the opportunity. Tomorrow we have a birds of feathers session titled NLP on legal text. I hope to see you all tomorrow at this time at Aquarius 2. Thank you.
Okay, thank you, everybody. That concludes our workshop. We now have the question period for this session. I don't see anything on the chat, so let's jump to the room. And does anyone have questions for anybody in this session? Oh. Yeah, if you have a question, please unmute and talk.
Hi, this is Radha. So I had a question for Alice, with a paper about the information extraction from legal wills. So I was just wondering, could you clarify what you mean by overgeneralization of prompts? Do you mean hallucination or something else?
Yes, I would say it's pretty similar to hallucination, because when prompts were given, it was only given like an example for each cases, so it wasn't like enough maybe. So I think that caused GPT-4 to just overgeneralize that information, that limited amount of information, and just created many false positives, such as the cases that I just explained. Like, for instance, annotating co-executor as beneficiary while it's certainly not, or making any money-related entities like debts as assets, which is also pretty much false. And there were many such cases that we saw. So yes, I think that's pretty similar to hallucinations, but in a
So,
wrong way.
just curious, did you make any attempts to modify your prompts to avoid those hallucinations?
Could you repeat the question?
Yeah, I was just curious. Did you make any attempts to modify your prompts to avoid those hallucinations or avoid those false positives?
I'm not sure if I understood correctly, but we were not trying to hallucinate any data, but this was a side effect of our prompt, I believe. I think this limited amount of data has just caused this very unfortunate results, I would say.
Okay,
I'm
thank
not
you.
sure. Yeah, thank you.
Yeah, we'll take it offline. Thank you.
Thank you.
Any more questions? Do we have any more questions? I have a question for Alice actually as well. I noticed your inter-annotator agreement was actually relatively low, lower than I would expect for this kind of a task. Did you have any opinion about why that might have happened?
Yes. So I think that was because so in our information extraction tasks, we were using exact match, like exact text match, which is pretty rigorous. So if the two annotators were not exactly matched on what they use as a text span, we were just making it as wrong. So I think that has made this score very lower than what it actually is. Yes.
That makes sense. Kind of what I suspected, actually.
Yes, that
Okay,
was
thank
it.
you very much.
Thank you.
Any other questions before we wrap it up? Okay, well, don't go away because we're going to have the best presentation award. Just give us, I wish we had like some, some music. Give us give us 2 minutes and don't go away.
Okay, so while you were presenting your wonderful papers, which we're very thankful for, the organizing committee had a list of 35 criteria that we judged all presentations. Yes, we were very thorough. Yeah, so first of all, thank you all for your presentations and for staying so long. We know it was been a very long day, but we made it. So we called this award the Best Presentation Award for a reason, because we were looking for, presentations that went maybe beyond a bit the usual presentations we're giving, also given the constraints, right, that there were 5 main presentations. So obviously we know that you needed to make everything fit in 5 minutes, which is not possible. So I'm trying to build some anticipation, although I know that you're all tired. So yeah, shall we announce the award or you okay? Yeah, I hold the results. So everything, given the context of how we decided to give the best paper award, and to spoil it already a bit, the award will go to one of the papers that also both co-authors presented, and they are both online, so that should be the feature to determine who the award goes to. And the paper is the legal judgment prediction. If you're going to do it right. Very innovative title. by Masha Medvedeva and Pauline McBride. They are online, and yeah, maybe we can. Well, I would like to call them on stage, but yeah, that's not possible. So at least we can, or yeah, we can spotlight them so that I can hear them. We can see
Yes.
Masha on the
I'll
screen.
represent both of us. Maybe I don't.
Do you want to say 5 words?
Yes, thank you. I hope that the message also came across, not only the presentation. And I think I'd like to thank Wham, the band, for inspiring the title. If you know, then you know. But yeah, thank you very much. Appreciate it.
Yes, and of course we should mention that the award comes not just with the actual certificate, but also with 500 euro or dollars, US dollars, right? US dollars sponsored from Bloomberg. I guess we'll be in touch to arrange the logistics, but congratulations.
Thank you.
It's time. Yeah, before you flee, right? First of all, thank you all for attending, and also please be in touch with us if you have any ideas about what we'd like to see different next year. We're also thinking different things and different setups, different formats. We know that the program is a bit packed. We'd like to make it a bit less packed, but there are so many papers and so much interest. So I would say if you have any comments, just reach out to us. I think we are all a bit around the next few days, and you know the goal of this workshop is also to build the community around this. So please reach out with any comments or suggestions. And yeah, so Nico is saying that if somebody wants to do more things in their free time, because we all know that you'll have much free time, please also reach out. We need extra hands and helping on all fronts. Yeah, I have nothing else to say. Does anybody want to have anything else to say? Yes, so there is the welcome reception at, okay, this time is wrong. Yeah, also before we go, right, I would like to thank, of course, again, our keynote speaker, Gerald, for his fascinating talk. I'd also like to thank the co-organizers, Elias, Nikos, Daniel, Leslie, and Catalina, who cannot be with us, but she did also much work in the organizing committee. And thank you all again. Have a good rest conference. And yeah, thank you for being here. Hopefully see you next year in wherever EMNLP is going to be.
Yeah, thanks everybody. You crushed it.